Hello everyone, in this video we're going to review Unit 1, Topic 1.1 to 1.16 of AP Calculus AB and BC. Part 1, do not use a calculator for problems 1 to 37. Alright, question 1, f of -5 is right here, f of -5 is going to be right here, the answer should be 6. Question 2, f of 2 is right here, the answer should be 1, right? Question 3, f of 4 is right here, f of 4 should be this one, right? So it could be -3, be careful, this one is the limit, because you see the hole right here, right? This is the dot, so keep that in mind. Question 4, limit of LS when s approaches -7. So -7 is right here, so the answer should be right here, it's going to be 2. Now question 5, limit of the function LS when s approaches -5. -5 right here. It's still 6, right? Question 6. Limit of the function LS when s approaches 2. S approaches 2 is going to be right here. The answer should be 3. Now question 7. Limit of the function LS when s approaches 4. So we look at 4 is right here. We see that limit of LS when s approaches 4 minus is 2. 4 plus is -3. So it's not going to be the same thing. Then the limit of LS when s approaches 4 does not exist. Question 8. Limit of the function LS when s approaches 0. So 0 is right here. Limit of the function LS when s approaches 0 plus is positive infinity. When s approaches 0 minus, it can be -infinity. They are different, so the limit does not exist. Now question 9, limit of LS when s approaches 0 minus is -infinity. Or you can say does not exist. Right, it's going to be right here. Limit LS when s approaches 0 plus, it can be positive infinity. Or you can say does not exist. Right, it's right here. Question 11, limit of LS when s approaches 4 plus. 4 right here, 4 plus, it could be -3, right? Limit of the function LS when s approaches 4 minus is right here, it could be 2. Question 13, limit of LS when s approaches -infinity. So when s approaches -infinity, this guy keeps getting closer to the x-axis, which is 0 right here, right? It's above the x-axis, so it could be 0 plus. Question 14, limit of LS when s approaches positive infinity, it could be right here, right? The function is always below the x-axis. It's getting closer to the x-axis, right? So it should be 0 minus. Let's move on to question 15. Use the definition of a continuous function at a number to answer the following. Now, a function f is continuous at a number a if f of a is defined. Limit of the function f of s when s approaches a exists. What does it mean? It means limit of the function f of s when s approaches a minus equals limit of the function f of s when s approaches a plus. Number 3, limit of the function f of s when s approaches a equals f of a. Right. Now, question A. The function f is not continuous as s equals -7. We look at -7. It's going to be right here. Because f of -7 is undefined, right? We have the limit right here is 6. But f of -7 is undefined. So number 1 right here does not satisfy, right? f of negative 7 is undefined. Question B, the function f is not continuous as s equals 2. S equals 2 is going to be right here. The limit is it, right? F of 2 defined, right? But they're not going to be the same, right? So number 3 right here does not satisfy, right? So you need to say f of 2 is not equal to limit of the function f of s when s approaches 2, right? Question C, the function f is not continuous at s equals 4. 4 is right here. Again, the limit of the function ls when s approaches 4 does not exist. So these guys violate the number 2 right here, right? Now question 16. Limit of the function negative s squared plus 4s when s approaches 2. Substitute 2 for s. So it's going to be negative 2 squared plus 8. So it's going to be 4, right? Question 17. Limit of square root of s minus 3 over s minus 9 when s approaches 9 minus, right? So we just substitute 9 for s. We see that the top is 0. The bottom is 0, right? So this one is the indeterminate form, right? We just factor the numerator and denominator to simplify first, right? So it could be limit when s approaches 9 minus square root of s minus 3 over square root of s minus 3 times square root of s plus 3, right? We're going to use a different square formula, right? A square minus b square equals a minus b times a plus b, right? So this guy cancel out, so it could be limit 1 over square root of s plus 3 when s approaches 9 minus, right? So the answer is 1 over 6 minus y, because s approaches 9 minus, which is the number on the left of 9, right? So it should be less than 9, right? So if this guy less than 9, square root of a number less than 9 is going to be less than 3. 3 plus 3 is going to be 6, so it should be 6 minus, right? So be careful. Now question 18. Limit of the function s over tangent s when s approaches 0. We're going to substitute 0 for s. We have 0 over 0. So this one is the indeterminate form, right? So we need to manipulate this one a little bit. So it's going to be limit when s approaches 0, right? Of s over tangent s is going to be sine s over cosine s, right? So then it's going to be limit when s approaches 0 of s over sine s times cosine s, right? Then it's going to be limit of s over sine s when s approaches 0 times limit of cosine s when s approaches 0, right? We know that this guy is 1 by the formula, right? So the answer is 1 times limit of cosine s when s approaches 0 is going to be 1. So the answer should be 1, right? Now question 19, limit of the function s over s plus 2 when s approaches negative 2 plus. Substitute negative 2 plus for s, so it's going to be negative 2 plus over negative 2 plus 2, right? So the top should be negative 2 plus, the bottom should be 0 plus, right? And the answer should be negative infinitive of does not exist. Now question 20, we do exactly the same thing, right? So it's going to be 1 plus 1 over 0 minus, right? And then it's going to be 1 plus negative infinity, right? So it could be negative infinity, right? And this one does not exist. Question 21. Substitute 1 for s, so it could be sine of pi times 1, right? So it could be sine of pi, and it could be 0. Number 22. We're going to use the relative growth rate. When s approaches infinity, this guy right here grows faster than this guy, so we just ignore this guy. This guy right here grows faster than this guy, so we just ignore this guy, right? So it turns out to be limit when s approaches infinity of negative 6s to the fifth over s, right? So it's going to be limit when s approaches infinity of negative 6s to the fourth, right? And it's going to be negative infinity, right? This one does not exist. Question 23. We do exactly the same thing, right? So when t approaches negative infinity, this guy grows faster than this guy, right? So we just ignore this guy. This guy grows faster than this guy, right? We just ignore this. So it's going to be limit when t approaches negative infinity of negative t cubed over 7t cubed, right? Now t cubed and t cubed here cancel out, the answer is negative 1 over 7, right? Question 24. We use the relative growth rate, right? So this guy grows faster than this guy, we just ignore this. These two guys right here grows faster than this guy, we just ignore this, right? So it could be limit when s approaches negative infinity of s over s squared plus 2s, right? Then we just factor s out and we simplify, right? So it could be limit of 1 over s plus 2 when s approaches negative infinity, right? So it's going to be 1 over negative infinity. It's going to be 0 minus, right? Question 25. Remember, we have absolute value of s equals s if s greater than or equal to 0, negative s if s less than 0. Now, when y approaches negative infinity, this guy grows faster than this guy, so we just ignore this. This guy grows faster than this guy, we just ignore this, right? So it can be limit when y approaches negative infinity of negative y over square root of 6y squared, right? Now, this guy turns out to be limit when y approaches negative infinity of negative y. We check square root of y squared, it turns out to be absolute value of y, right? Times square root of 6 right here. Now we use the formula right here. When y approaches negative infinity, which means y is less than 0, right? So it turns out to be negative y. It could be this case right here, right? So this guy turns out to be limit when y approaches negative infinity of negative y over negative y square root of 6. Cancel out this guy, so the answer is 1 over square root of 6, right? Now question 26. Limit of the function ls when s approaches 2, when ls equals this guy and this guy, right? So we need to find limit from the left and limit from the right, right? So limit of the function f of s when s approaches 2 minus, it's going to be this guy right here, right? Because s less than 2, which means 2 minus, right? So it's going to be limit of s squared minus 3s plus 6 when s approaches 2 minus, right? So we just simplify this one. Substitute 2 for s, the answer is 4, right? Now, limit of the function f of s when s approaches 2 plus, right? We're going to use the bottom one right here, right? So it could be limit of negative s squared plus 3s plus 2 when s approaches 2 plus, it's going to be 4, right? So, limit from the left equals limit from the right, right? Look. So then, limit of the function f of s when s approaches 2 equals 4, right? Now, question 27. If a not equal to 0, then the limit of the function s squared minus a squared over s to the 4 minus a to the 4 is what, right? So we need to substitute negative a over here to see what happens, right? The top is 0, right? The bottom is still 0. This one is indeterminate form, right? So we need to simplify this one first, right? We need to use different square formula, right, to simplify this one. So we have limit when s approaches negative a. The top I just rewrite s squared minus a squared. The bottom right here I use different not two square formulas, right? So it could be s squared minus a squared times s squared plus a squared, right? So then this guy cancel out. So it could be limit of the function 1 over s squared plus a squared when s approaches negative a, right? So this guy turns out to be 1 over a squared plus a squared. It's going to be 1 over 2a squared, right? Now question 28. Find number c such that f(s) is continuous on the entire real line. In order to do this one, we need to use the definition of continuity, right? It's going to be right here, right? So we need to find limit of the function f of s when s approaches 4 minus, right? It's going to be this one right here, right? So it should be 4 squared equals 16. Limit of the function f of s when s approaches 4 plus it's going to be this guy right here, right? So c over 4, right? Now f of 4 is this one right here, right? 16. So the function f(s) is continuous. We need limit of the function f of s when s approaches 4 equals f of 4, right? Now limit of the function f(s) when s approaches 4 right here must exist, which means this guy right here and this guy right here must be the same, right? And you see that this guy already sitting equal this one, so we don't need this one anymore, right? So we just need the limit of the function f(s) exists when s approaches 4, right? So we have 16 equals c over 4, right? And then c equals 64. Now question 29. Find the s value, if any, at which the function f is discontinuous, label as removable or non-removable, right? So basically, we need to simplify this one, right? Factor the top is going to be 2 times s plus 3. The bottom should be 2. When you factor 2 out, it's going to be s squared minus 9. This guy actually different of 2 squared, right? So it could be s minus 3 times s plus 3, right? Now, this guy cancel out, right? 2 and 2 cancel out. So the answer is 1 over s minus 3, right? So now we need to answer this one, label as removable. When you remove s plus 3, this one is called removable discontinuity, right? So you must say removable discontinuity at s equals negative 3, right? Let this one equals 0 sub s. So s equals negative 3, right? And non-removable discontinuity is the remaining one on the bottom right here. This one actually the vertical asymptote, right? And let this one equal 0, s equals 3, right? Now let's move on to question 30. Determine all the vertical asymptotes of the function f(s), right? So we just factor this one and simplify s plus 2 over different of 2 square formula. It's going to be s plus 2 times s minus 2. So this guy cancel out. It could be 1 over s minus 2. So the vertical asymptote is s equals 2, right? We just let the bottom equals 0, so s equals 2. Now, how do we show work if the question wants you to show your work? So you need to say limit of the function f(s), which is this one right here, 1 over s minus 2, when s approaches 2 minus, it's going to be 1 over 0 minus, it's going to be negative infinity, right? Similarly, limit of the function 1 over s minus 2 when s approaches 2 plus, it's going to be 1 over 0 plus, it's going to be positive infinity, right? Then the vertical asymptote is s equals 2. Now let's move on to question 31. True or false? If the function f is undefined at s equals c, then the limit of the function f as s approaches c does not exist. This one false. Why? Because you could have the function like this. Right? So the limit right here is it. Now question 32. True or false? If the limit of the function f of s when s approaches c equals L, then f of c equals L. This guy also false. Look at the graph right here. Suppose you have the graph like this. Alright, and the function is defined right here, right? So this is f of c, right, equals L right here. And this guy different, right? So it's not the same. Now question 33. The graph of the function f is shown to the right. Which of the following statements is false? Answer choice A. S equal A is in the domain of f. Yes, because the function is defined, right? Question B. Limit of the function f of s when s approaches a plus is equal to the limit of the function f of s when s approaches a minus. Yes, the limit right here is it. Question C. Limit of the function f of s exists when s approaches a. Yes, because B is right, then C should be right, right? Answer choice D. Limit of the function f of s when s approaches a is not equal to f(a). Yes, that's correct, right? This is limit of the function f of s when s approaches a, right? And this one right here is f of a, right? They are different. Now, answer choice E. The function f is continuous as s equals a. It's not continuous, right? Because limit of the function f of s when s approaches a is not equal to f of a by definition of continuity. The function f is not continuous as s equals a. So the answer is E. Now, let's move on to question 34. We need to find the limit of this guy, right? So we need to expand this one and simplify it, right? So we have limit when delta s approaches 0 of use complete square formula to expand this one. So it will be s squared plus 2s delta s plus delta s squared minus 2s minus 2 delta s plus 1 minus s squared distribute -1, right? Plus 2s minus 1 over delta s, right? So it will be limit when delta s approaches 0. Now we're going to simplify this guy, right? So we have s squared and negative s squared gone. Negative 2s and 2s. So we have 2s delta s left right here, right? Plus delta s squared minus this guy right here, 2 delta s, right? 1 and -1 gone over delta s, right? Now we're going to factor delta s on the top out, right? So we have limit when delta s approaches 0 of, when we factor this one and we simplify with the delta s on the bottom, right? So it's going to be 2s plus delta s minus 2. When delta s approaches 0, this guy equals 2s minus 2, right? And this guy actually the derivative of the function f of s when f of s equals s squared minus 2s plus 1 right here, right? Now let's move on to question 35. On the graph, draw a function that has the following properties. A step or jump discontinuity at s equals 5. So this is 1, 2, 3, 4, 5. Alright, so as s equals 5, it could be right here, right? Now f of 5 equals 6, right? So I have 2, 4, 6, right? So this one should be a dot because the function is defined as s equals 5, right? So I have something like this. Now, because this guy is the step or the jump discontinuity, right? So right here I must have a hole, right? So it could be something like this, right? Now let's move on to question 36. Create a function such that the limit of the function f(s) when s approaches 5 does not exist. So what does it tell us? It tells us the limit of the function f of s when s approaches 5 minus is not the same thing as the limit of the function f of s when s approaches 5 plus, right? Because it is approaching positive infinity from both the left and the right. So we just get the example of the function right here, right? So we locate 5. So suppose I have 5 right here. Limit of the function f(s) when s approaches 5 minus, different from limit of the function f(s) when s approaches 5 plus, and they both approaches positive infinity, right? So right here I just draw the vertical asymptote, right? So it could be something like this, right? Now question 37. Find the function f(s) such that f(s) has a hole at s equals 7 and a vertical asymptote s equals negative 4. Now we're going to convert this one into the factors, right? So we just add 4 both sides. It turns out to be s plus 4 equals 0, right? This guy turns out to be s minus 7 equals 0, right? Now since the function has a whole, which means there is a common factor on the numerator and denominator, right? So it can be f of s equals s minus 7 over s minus 7 right here, right? Now since the function has a vertical asymptote s equals negative 4, so we have a factor right here, should be on the bottom, right? Now on the top right here, you could leave it like this, or you can put any number right here, right? So for example, I put 6, 7, right? Now let's move on to the second section. Calculators is allowed, right? So question number 1, approximate the limit numerically by completing the table, right? Now when s approaches 1.9, we're gonna bring up the calculator at calculator. Now we're gonna hit the fraction right here. So we put 1.9 squared over 1.9 minus 2, right? So it could be negative 36.1. We put negative 36.1, right? So we keep doing the same thing for the rest, right? So I'm gonna have, so we see that the limit of this function when s approaches 2 equals plus and minus infinity, which means it does not exist, right? Because you see that the limit of the function f(s) when s approaches 2 minus, it could be somewhere right here. It's go to negative infinity right here, right? And this guy somewhere right here, right? It's go to positive infinity, right? Now question 2. Find the limit of the function cosine of 1 over s when s approaches 0, right? So we just graph this one, right? So we're gonna press home screen right here, graph. Then hit enter. It's going to be right here. And you see that the limit of this function when s approaches 0 is oscillating, right? So the limit of this function does not exist. Now let's move on to question 3. Limit of the function f of g of s when s approaches 2, right? So we're going to let u be g of s, right? Then we need to calculate the limit of the function g of s when s approaches 2. So 2 is right here, the function g is right here, right? And you see that the function is discontinuous as equals 2, right? And this guy should be 4, right? But the graph is not above the line y equals 4. You see that? It cannot be above, right? So the limit of the function g of s when s approaches 2 equals 4 minus, right? Because you see that this guy right here is always below 4, right? So you need to use this one right here for the next one right here. So basically I substitute u for g of s over here, right? And then I have limit of f of u, right? And then GOS right now is u, right? And it's going to be 4 minus, right? So u approaches 4 minus, right? Go back to the function right here. It's going to be the same thing as limit of f of s when s approaches 4 minus. So we're going to use this guy right here, right? So 4 is right here, right? And 4 minus, which means on the left of 4, right? So it's going to be 2 right here, right? So the answer is 2. Now let's move on to question 4. Limit of LS minus 1 times GOS when s approaches 1. Alright, so in order to determine if the limit of this function exists, we need to calculate the limit of f of s minus 1 times g of s when s approaches 1 plus, right? And the second one, limit of f of s minus 1 times g of s when s approaches 1 minus, right? If these two guys are the same, then the limit exists, right? Now, this guy right here is the product of two functions. I just separate these two guys, right? So I have limit of f of s minus 1 when s approaches 1 plus, right? Now, since the input right here and right here different, I need to make them the same in order to use the function f right here, right? So in order to do that, I just look at this guy right here, right? I look at the input right here, it's going to be s minus 1, so I subtract 1 both sides, right? So it's going to be limit of the function f of s minus 1 when s minus 1 approaches 0 plus, right? Now, since this guy and this guy the same thing, right? So I can use the graph of the function right here, right? So it turns out to be limit of f of u when u approaches 0 plus, right? Now I look at this one, 0 plus is right here, so it could be right here, right? So the function approaches positive infinity, right? Now the second one I need to do is I need to find the limit of this one, right? So I have limit of g of s when s approaches 1 plus. Look at the function g is right here. When s approaches 1 plus, so it could be somewhere right here. The function approaches 3, right? Now we're going to multiply this guy and this guy. So the answer is positive infinity, right? Similarly, I have equals limit of the function f of s minus 1. Now I just subtract 1 both sides, right? So I have s minus 1 approaches 0 minus, right? Now this guy and this guy the same thing. So I can use the function f right here to find the limit, right? So it's going to be limit of f of u when u approaches 0 minus when u equals s minus 1, right? 0 minus it could be negative infinity right here, right? Now, limit of the function g of s when s approaches 1 minus, right? 1 minus is still right here, so it's still 3, right? Now, I'm going to multiply this guy and this guy. The answer is negative infinity, right? So this guy equals negative infinity. Now, this guy and this guy are different, right? So the limit right here does not exist, right? Now, let's move on to question 5. Limit of ls plus 1 over gls plus 3 when s approaches 1, right? So we just separate these two guys, right? So first, I need to find the limit of the function f of s plus 1 when s approaches 1 plus, right? Now, in order to use the graph right here, you need to make this guy and this guy the same, right? So I have limit of f of s plus 1. Now I'm going to add 1 both sides, right? So I have s plus 1 approaches 2 plus, right? So then I can use the graph of the function right here, right? Now it's going to be limit of the function f of u when u approaches 2 plus, when u equals s plus 1, right? Now 2 plus it could be 2 is right here, right? And 2 plus it could be 3 right here, right? So the answer is 3. Similarly, I have limit of the function g of s plus 3 when s approaches 1 plus, and then it's going to be limit of the function g of s plus 3 at 3 both sides, so it could be s plus 3 approaches 4 plus, right? So it could be limit of the function g of u when u approaches 4 plus, right? So we use the function g right here. 4 is right here, right? 4 plus, it could be this guy right here, right? It could be negative 2, right? Now, this guy is 3 over negative 2, which is negative 3.5, right? Now let's move on to question 6. No calculator. The p-square function for the function f of s is below. Find the value a, b, c, d that makes f of s continuous everywhere. Alright, so we're going to review the definition of continuity, right? So we go back over here. We need to make sure the function is continuous as s were 1, right? So we have limit of the function f of s when s approaches 1 minus equals limit of s squared plus s minus 2 over s minus 1, right? This is 1 minus right here, right? And this one is 1 plus, right? We're going to factor the numerator, right? So it could be limit when s approaches 1 minus of s plus 2 times s minus 1 over s minus 1, right? Now this guy cancel out. So it's going to be limit of s plus 2 when s approaches 1 minus, and then it's going to be 3, right? Leave it over there. Now, limit of the function f of s when s approaches 1 plus, I'm going to use this one right here, right? So, it's going to be limit of b times s minus c square when s approaches 1 plus. It's going to be b times 1 minus c altogether square. Leave this one over there, right? Now, we have f of 1 is going to be right here equals a, right? We're gonna determine if the function is continuous as s were 4, right? So we do exactly the same thing, right? So we have limit of the function f of s when s approaches 4 minus, right? Now 4 minus, we still use this one, right? So we have limit of b times s minus c square when s approaches 4 minus, right? Substitute 4 for s, so it could be b times 4 minus c square, right? Similarly, limit of the function f of s when s approaches 4 plus is going to be limit of this one, right? So it could be 2s minus 8 when s approaches 4 plus, and substitute 4 for s is going to be 0, right? And then f of 4 equals d right here, right? Now, by definition of continuity, right, we need the limit of ls when s approaches a exists, which means the left must be equals the right, right? So, we need to equate these two guys right here, right? So I have b times 4 minus c altogether square equals 0. This is the first one. The second one, this guy right here and this guy right here must be the same, right? So I have b times 1 minus c altogether square equals 3, right? Now I'm going to divide this one vertically. So what should I have? B and b cancel out, right? So I have 4 minus c altogether square over 1 minus c altogether square equals 0, right? So does that mean 4 minus c square equals 0, right? And then 4 equals c, right? Now c equals 4, I substitute back over here to solve for b, right? So I have b times 1 minus 4 square equals 3, right? So b equals 3 over 9. It's going to be 1/3. Alright. Now we know that limit of the function f of s when s approaches 1 equals f of 1 in order for the function to be continuous, right? Now f of 1 equals a, and limit of the function f when s approaches 1 equals 3 right here, right? So then a equals 3. Alright, so you have a, b, c. Now you need to find the same thing. You have the limit of the function f of s when s approaches 4 equals f of 4, right? F of 4 equals d right here. And the limit right here equals 0 right here. You see that? 0. So you have d equals 0. Right? We're going to review Unit 2 of AB, Calculus, AB, and BC. Alright, question 1. Determine whether the slope of the tangent line to the curve at the indicated point is positive, negative, or 0. Alright, so I'm going to show you a Christmas tree trick. If the line is going this way, the slope is positive. If the line is going down this way, the slope is negative. If the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Alright, so you just draw a tangent line to the graph at this point. You see that? The graph going up, the slope is positive, right? Similarly, draw the tangent line to the graph at this point. You see that? The slope is negative. And draw the tangent line to the graph at this point. The slope is 0, right? Now, question 3. If f of 2 equals 3, this one tells us that the order pair 2, 3, right? And f prime of 2 equals negative 1. This one tells us that the slope is negative 1 at s equals 2. Find the equation of the tangent line when s equals 2, right? So we have the point slope from formula y minus y1 equals m times s minus s1, right? This one right here is s1 y1, right? And the slope here, you just plug it in over here. So we have y minus 3 equals negative 1 times s minus 2, right? Now we're going to simplify this one, so it could be y minus 3 equals negative s plus 2, right? Add 3 both sides, so y equals negative s plus 5, right? Either this form or this form is acceptable, right? Question 4. Find the equation of the tangent line to the graph of f of s equal s squared minus 2s minus 3 when s equals 2. Right, so first we need to calculate the first derivative, right? So we have f prime of s equals 2s minus 2, right? And we need to find the slope, right? So we have m equals f prime of 2 right here, right? So we substitute 2 for s into this expression right here. So we have 2 times 2 minus 2, right? So it could be 2. Now, we substitute s equal to into this function right here to find the order pair, right? So I have f of 2 equals 2 squared minus 2 times 2 minus 3, right? So then it's going to be negative 3, right? Now we have the order pair. It's going to be 2 commas negative 3. This one actually s1 y1, right? So we have y minus y1 equals m times s minus s1, right? Substitute values y minus negative 3, right? So it could be plus 3 equals, the slope is 2 times s minus s1. s1 equals 2 right here, minus 2, right? Now this one is point slope form, right? If you want to convert this one to slope intercept form, it's going to be y equals 2s minus 4 subtract 3 minus 7, right? This one is the slope intercept form. Question 5. Differentiate y equals 3s over s squared plus 1. This one is the quotient rule, right? So we're going to use formula u over v prime equals u prime v minus v prime u over v squared, right? So this one is u and this one is v, right? So we have y prime equals 3 times s squared plus 1 minus 2s times 3s, right? Over s squared plus 1 altogether squared, right? So it's going to be 3s squared plus 3 minus 6s squared over s squared plus 1 altogether squared, right? So it could be negative 3s squared plus 3 over s squared plus 1 altogether squared, right? Now we just factor negative 3 out, so it could be negative 3 times s squared minus 1 over s squared plus 1 altogether square. The top we just use difference of 2 square, right? So it could be negative 3 times s minus 1 times s plus 1. The bottom we just leave it because we cannot factor the bottom, so keep that in mind. Alright, so this one is the final answer. Now note that you can stop right here, it's fine, right? Or you can do additional step to get this one. Mostly you will see this answer choice on the MCQ section, right? Question number 6. For the function f of t equal tq plus 2 over t, find the following. Question A. Find the average rate of change of the function f of t on the interval 1 to 4, right? So we have average rate of change equals f of 4 minus f of 1, right? The closed interval right here, over 4 minus 1. Remember, average rate of change is given by the formula f of b minus f of a over b minus a on the closed interval a to b. Keep that in mind. Alright, so f of 4 substitute for t. So you have 4 cubed. It's going to be 64 plus 2. It's going to be 66 divided by 4, right? So we have 66 divided by 4 minus, substitute 1 for t is going to be 3, right? Over 4 minus 1 is going to be 3, right? We're going to simplify this one, multiply this guy, right? So 66 subtract 12 is going to be 54, right? 54 over 4, bring to the bottom, it's going to be 12, right? Divide the top bottom by 6, so it can be 9 over 2. This one is the final answer. Now question B. Find the instantaneous rate of change of the function f of t when t equals 2. It means that we need to calculate f prime of 2, right? So we need to find f prime of t first. We're going to use the quotient rule, right? So we have f prime of t equals, we're going to use the formula right here, right? It's going to be u prime is going to be 3t squared times t minus derivative of this one equals 1, right? So t cubed plus 2 over t squared, right? Now we're going to simplify this one, so it could be 3t cubed minus distribute negative 1, so t cubed minus 2 over t squared, right? So it could be 2t cubed minus 2 over t squared, right? So f prime of 2, substitute 2 for t, right? So we have 2 times 2q minus 2 over 2 squared, right? 2q, it could be 8 times 2, it could be 16, subtract 2, it could be 14. 14 divided by 4, divide the top bottom by 2, so it could be 7 over 2. This one is the final answer. Now let's move on to question 7. Suppose that h of s equals g of s over f of s, and g of 2 equals 3, g prime of 2 equals negative 1, f of 2 equals 5, and f prime of 2 equals negative 2. Find h prime of 2. So we use the quotient rule, right? So we have h prime of s first. It's going to be g prime of s times f of s minus g of s times f prime of s over f of s altogether square, right? Now we substitute 2 for s, so it can be h prime of 2 equals g prime of 2 is -1 times f of 2 is 5 minus g of 2 is going to be 3 times f prime of 2 is going to be -2 over f of 2 square. F of 2 equals 5 square, it will be 25, right? So it's going to be -5 plus 6 over 25, and it's going to be 1 over 25, right? Now question 8. Let f of s equals ax for s less than or equal to 1. bs squared plus s plus 1 for s greater than 1. Find all possible values of a and b such that f of s is differentiable as s equals 1. Alright. So, in order for a function to be differentiable, the function must be continuous, right? So here's the side note. In order for the function to be continuous as a number c, we should have limit of the function f of s when s approaches c minus equals limit of the function f of s when s approaches c plus equals f of c, right? Alright, so now we need to determine if the function is continuous at s equals 1, right? So we need to have limit of the function f of s when s approaches 1 minus, right? So 1 minus, we're going to use this one right here. So it should be a times 1. This could be a, right? Now, limit of the function f of s when s approaches 1 plus s could be this guy right here, right? So substitute 1 for s, so it could be b plus 2, right? Now, this guy and this guy must be the same, right? So we have the equation a equals b plus 2, right? Now, next one, we need to take derivative, right? Now, next one, in order for the function f to be differentiable at s equals 1, we need to take derivative of this one. So f prime of s equals, this one is a linear function. Derivative of this one should be a, right? For s less than or equal to 1. Derivative of this one should be 2b plus 1 for s greater than 1. Now we need to calculate limit of the function f prime of s when s approaches 1 minus s could be this guy right here, a, right? And limit of the function f prime of s when s approaches 1 plus s could be this guy right here, right? Oh, I forgot s right here. So it should be 2b plus 1, right? Now, in order for the function to be differentiable, we need this guy right here and this guy right here should be the same, right? So we have a equals 2b plus 1, right? Now we have the system of two equations right here. So we solve for a and b, right? So I put this over here. So I just equate this guy and this guy, right? Because they both equals 8, right? So I have b plus 2 equals 2b plus 1, right? So then b equals 1, right? Substitute 1 for b back over here. So I have a equals 3, right? So a equals 3 and b equals 1 is the final answer. Now let's move on to question 9. If the function f of s equals 2s squared plus 4, which of the following will calculate the derivative of the function f of s? Recall, definition of derivative of the function f of s is given by the formula f prime of s equals limit of f of s plus delta s minus f of s over delta s when delta s approaches 0, right? So we look at this one right here. We need to eliminate a and d, right? Because there is no limit, right? Now b and c. So we look at the function right here. It could be 2s squared plus 4, right? Now if the input ask plus delta s, so we substitute ask plus delta s for s over here. So we have 2 times ask plus delta s square plus 4, right? For this one right here, right? So the answer must be C, right? Now let's move on to question 10. Let h of s equals f of s times g of s, find h prime of 2, right? So we need to calculate h prime of s first, right? We're going to use the product rule, right? So we have f prime of s times g of s plus g prime of s times f of s, right? So we substitute 2 for s, so it could be h prime of 2 equals f prime of 2. F prime of 2 is right here, right? So f prime of 2 actually the slope of the line right here, right? The slope of this line is actually -1, right? -1 times g of 2. So g of 2 is actually -3, right? So times -3 plus g prime of 2. This guy actually the slope of this line, right? Right here. So right is 2 run is 1, right? So it's gonna be right over run is gonna be 2, right? Times f of 2. F of 2 is 2, right? So the answer is 3 plus 4 equals 7, right? So it should be C. Now question 11. What is g prime of 3? G prime of 3 is the slope of the function g of s at s equals 3. S equals 3 is right here. And the function g of s is right here. Right at this value, the function has a sharp turn. So the derivative does not exist, right? So this one does not exist. Let's move on to question 12. On lazy day, Uncle C decides to sit under a shade tree next to a row by the swamp and count the number of ducks which cross the row. The data in the table below shows the accumulation of the number of ducks crossing the row at each hour after 9 a.m. Right? So we need to find the following. Determine the average number of ducks which have crossed the row per hour during Uncle C 7-hour observation. Label your result. Alright, so we need to find the average number of ducks. We need to use the average rate of change formula, right? So we have f of b minus f of a over b minus a, right? This one is a. This one is b. F of b is right here. And f of a is right here, right? So we have the average number of ducks is 28 subtract 0 over 7 subtract 0. So it could be 4 ducks per hour, right? Now question B. Estimate the value of f prime of 4.5 and explain its meaning. Alright, so 4.5 is between 4 and 5, right? So we have f prime of 4.5 approximately is going to be 21 minus 12 over 5 minus 4, right? So it's going to be 9, right? So we need to conclude that there are 9 ducks crossing the row per hour at time t equals 4.5, right? Now let's move on to question 13. Limit of this guy represents f prime of c for a function f of s and a number c. Find f of s and c. Alright, recall we have the definition of derivative, right? It's going to be f prime of c equals limit of the function f of c plus delta s minus f of c over delta s when delta s approaches 0, right? Now, in general case, we have f' of ask equals limit of f of ask plus delta ask minus f of ask over delta ask when delta ask approaches 0, right? So we use the general case to find the function f of ask, right? So the function f of ask is actually right here. We just replace ask plus delta ask with ask, right? So the function f of ask right here is 2 ask q minus 2 ask minus 2. That's it, right? And the number c is actually negative 2 right here, right? If you look at the formula right here, right? So c equals negative 2, and the function f of x is right here, and this one is the final answer. Now we need to check our work, right? So we just find f of negative 2, right? Substitute negative 2 for s over here, right? So it could be 2 times negative 2 cubed minus 2 times negative 2 minus 2, and it's going to be negative 14. This one is exactly this guy right here, right? F of c. Now let's move on to question 14. Suppose the function f of x and g of x and their derivatives have the following values at x equals negative 1 and x equals 0. Evaluate the first derivative of each of the following combination of f of x and g of x at the given value of x, right? So we're going to take derivative of this one. It's going to be 3 f prime of x minus g prime of s, right? And substitute negative 1 for s, so it will be 3 f prime of negative 1 minus g prime of negative 1, right? So it's going to be 3 f prime of negative 1, it's going to be 2 right here. And g prime of negative 1 is going to be 1, right? So minus 1. So the answer is 5. Now question B, we're going to use the product rule, right? So it could be 3 times f prime of s times g of s plus g prime of s times f of s, right? And substitute negative 1, right? So we have 3 of f prime of negative 1 is going to be 2. G of negative 1 is going to be negative 1 plus g prime of negative 1 is going to be 1 times f of negative 1 is going to be 0, right? So the answer is negative 6. Now question C, we're going to use the quotient rule, right? So it could be f prime of s times g of s plus 2 minus g prime of s times f of s over g of s plus 2 altogether square, right? Now substitute 0 for s, so we have f prime of 0 times g of 0 plus 2 minus g prime of 0 times f of 0 over g of 0 plus 2 altogether square, right? F prime of 0 is negative 2, right? Times g of 0 is going to be negative 3 plus 2 minus g prime of 0 is going to be 4 times f of 0 is going to be negative 1 over g of 0 is going to be negative 3 plus 2 square. Now we're going to simplify this one. Negative 3 plus 1, negative 1 times negative 2 is going to be 2 plus 4, right? Divided by negative 3 plus 1 is going to be negative 1 square is going to be 1. So the answer should be 6, right? Now let's move on to the last question. The graph of the function f prime, the derivative of f is shown for negative 2 to 7, and f prime is defined for all s on the interval negative 2 to 7. What are all values of s for which the function f has a horizontal tangent line on -2 to 7. Alright, so remember the Christmas tree trick. The tangent line going this way, the slope is positive. Tangent line going this way, the slope is negative. Tangent line is horizontal, the slope is 0. Tangent line is vertical, the slope is undefined. Right? Now the question tells us that the function has a horizontal tangent line, which means the slope is 0. Right? So this guy is the function f prime of s, right? So the 0 of the function f prime of s actually the slope of the tangent line, right? So we have this guy, this guy, this guy, and this guy. But you need to be careful. It say the interval -2 to 7 exclusive, right? So we don't include -2, right? We don't have equal sign here. So we just count 0, 2, and 4, right? So the answer is C. We're going to review Unit 3 of AP, Calculus AB, and BC differentiation. Question 1, we need to find the derivative of y equals s cubed times square root of s plus 1. Alright, so basically, we need to use the product rule, right? So, remember, we have u times v prime is to be u prime v plus v prime u, right? So this guy right here can be written as s q times s plus 1 power 1/2, right? So then I'm gonna use the product rule. So I have y prime equals 3s squared times s plus 1 power 1/2, right? Plus, bring 1/2 to the front, times s plus 1 power 1/2 minus 1 is going to be -1/2 times s cubed, right? Remember the power rule, s to the n prime is going to be n times s to the n minus 1, right? Now I'm going to simplify this one. So this guy turns out to be, remember y prime is actually dy over dx, right? This guy turns out to be 3s squared square root of s plus 1, right? And this guy turns out to be s cubed over 2 square root of s plus 1, right? Now question 2, we need to find f prime of this one. So basically, this one can be written as cosine of 4s all together power 5, right? So we're going to use the power rule. U to the n prime is going to be n times u to the n minus 1 times u prime, right? Because this guy is the composite function, right? So we have f prime of s equals u, which means the whole thing right here, right? So we have n, which means 5 right here. So we have 5 times cosine of 4s all together to the 4, right? Times u prime, which means cosine of 4s prime, right? Now this guy turns out to be 5 cosine of 4s to the 4. Now this one, we need to apply the formula cosine u prime, right? It's going to be negative sine u times u prime. Alright, so u in this expression it could be 4s, right? So u prime, which means 4, right? So we have 4 times negative sine 4u, right? Now we're going to combine these guys, so 5 times 4, it could be 20, and you have negative side here. So negative 20, right? Sine 4s, right? 4. Sorry, this one should be s times cosine to the 4 of for s, right? Now let's move on to question 3. We need to find derivative of this function, right? So this one can be written as sine of 2 theta all together power 1/2, right? So we need to use the power rule, right? U to the n, where u equals this guy right here, right? So it's to be f prime of theta equals 1/2 times sine of 2 theta power of negative 1/2, right? Times u prime, which means sine 2 theta, right? So it could be 2 cosine 2 theta, right? We need to apply the formula right here. Sine u prime is going to be u prime times cosine u, right? So I'm going to simplify this one. So it's going to be 2 right here and 2 right here cancel out, right? And sine 2 theta raised to the negative 1/2, I bring it to the bottom, right? So I have cosine 2 theta over square root of sine 2 theta, right? Now question 4, we need to use the product rule, right? So we have f prime of s equals u times 3, right? U prime, which means 2s times v, which means 2s minus 5 squared, right? Plus v prime, which means this guy derivative. This guy derivative, we're going to use the formula right here, right? So we're going to bring 2 to the front times 2s minus 5 power of 2 subtract 1 is going to be 1. And then times u prime here. So u prime, which means 2, right? Derivative of this one equal 2. And then times this guy right here, s squared. Now we're going to simplify. It could be 2s times 2s minus 5 squared plus, now 2 times 2 equals 4, right? 4s squared. 4s squared times 2s minus 5, right? We're going to factor 2s minus 5 out, right? So this guy only have 2s minus 5 left, right? So I'm going to distribute 2s right here, so it could be 4s squared, right? And then 2s times negative 5, it could be negative 10s, right? Plus 4s squared, right? Now simplify further, so it could be 2s minus 5 times 4s plus 4s could be 8s squared minus 10s, right? Now for this guy right here, I just factor 2s out, right? So I have 2s times 2s minus 5 times, factor 2s out is going to be 4s left, right? And it's going to be minus 5 right here, right? Now let's move on to question 5. We need to find the second derivative of this function with respect to s, right? We take the derivative both sides with respect to s, right? So we have dy over ds of this one, and this one dy over ds, right? Now derivative of s squared is going to be 2s, right? Remember, this guy and this guy agrees, right? So when we take the derivative, you don't have dy over ds anymore, right? So we have 2s, that's it. Now for this guy right here, we need to use the product rule, right? We take the derivative of s, it's going to be 1, so we have y left, right? So plus y. Now we take the derivative of y, which means dy over ds, right? And you have s left right here, so s times dy over ds. Now y squared right here, we take the derivative with respect to s, so it will be 2y dy over ds, right? And the derivative of this one should be 0, right? Now we need to factor dy over ds out, right? So we have dy over ds is going to be s plus 2y equals, I'm going to subtract 2s and y both sides, right? So I have minus 2s plus y like that, right? So I divide both sides by s plus 2y, so dy over ds equals negative 2s plus y over s plus 2y, right? Alright, so second derivative turns out to be, we're going to use the quotient rule, right? So we have u over v prime is going to be u prime v minus v prime u over v squared, right? Now, derivative of negative 2s is going to be negative 2, right? Derivative of y is going to be dy over dx, so minus dy over ds, right? Times v, which means s plus 2y, right? Minus v prime, which means the derivative of this one is going to be 1 plus 2 dy over ds, right? This one right here. Times u, which means this guy right here, right? Times negative 2s minus y. So negative 2s minus y, I factor negative 1 out. So I combine with this guy becomes positive. So I only need to write 2s plus y, that's it, right? Over v squared, which means s plus 2y all together squared, right? Now I need to replace dy over ds with this guy, right? So I have negative 2 minus this guy, right? So you have negative side here, it becomes positive, right? So I have 2s plus y over s plus 2y, right? Times s plus 2y plus 1 plus 2 times negative 2s minus y over s plus 2y, right? Times 2s plus y, right? Over s plus 2y squared. That's it. Now let's move on to example number 6. Find the second derivative of this one, right? So this one can be written as 1/2 cosecant s, right? So we have the first derivative y prime equals 1/2 times negative cosecant s cotangent s. Now the second derivative is going to be, we use the product rule, right? So I have 1/2 right here, put the bracket. Now u prime times v plus v prime times u, right? So the derivative of this one is going to be negative of negative cosecant s cotangent s, right? Times cotangent s. Now derivative of cotangent s is going to be negative cosecant square of s, right? So it's going to be minus cosecant square of s times cosecant s, right? Now we're going to simplify, so it's going to be. Now let's move on to question 7. Find y prime of this guy, right? So before we're going to find y prime, we need to use the logarithmic properties to rewrite this one, right? So I have y equals natural log of s squared minus 4s minus 7 raised to the 1/2, right? So I can bring 1/2 to the front, right? So it will be 1/2 natural log of s squared minus 4s minus 7, right? Remember, we have log base 8 of b power k. You can bring k to the front. So it could be k log base 8 of b, right? Natural log of u prime equal u prime over u, right? So u in this expression is going to be this guy right here, right? So we have y prime equals 1/2 times derivative of this one is going to be 2s minus 4 over s squared minus 4s minus 7, right? Now on the top we just factor 2 out and we cancel out this one. So the final answer should be s minus 2 over s squared minus 4s minus 7, right? Now let's move on to question 8. Find the derivative of natural log of this guy. Now if we just leave it like this and we consider this one as u, and we're going to use the formula right here, we're going to get stuck, right? We need to use the logarithmic properties to expand this one first, right? So we have h of s equals, remember we have log base a of b times c. It's going to be log base a of b plus log base A of C, right? If you have log base A of B over C, it's going to be log base A of B minus log base A of C, right? This one turns out to be natural log of S plus natural log of S minus 1 power of 3 subtract natural log of square root of S minus 2, right? Then I rewrite natural log of S, bring 3 to the front, right? So you have plus 3 natural log of S minus 1, right? Now this one right here can be written as S minus 2 power of 1 half, right? So you can bring 1 half to the front, right? So it can be minus 1 half natural log of S minus 2, right? Now you can take derivative of this one, so we have h prime of S equals derivative of this one is to be 1 over S. Derivative of this one is to be 1 over S minus 1, so it will be plus 3 over S minus 1. And then times u prime, which means 1, right? Same thing, you have minus derivative of this one is to be 1 over S minus 2, right? So we have 1 over 2 times S minus 2, right? Now let's move on to question 9. We need to find the derivative of this one, so we need to use the formula e to the u prime is going to be u prime times e to the u. U in this expression it could be secant s, right? So we have y prime is going to be negative 4 times e to the secant s times secant s prime. Secant s prime is going to be secant s tangent s, right? Now question 10. We have the formula a to the u prime. Remember a is a constant, right? So it could be a to the u times natural log of a times u prime, right? Now u in this expression is 5s, right? So we have y prime equals 3 to the 5s times natural log of 3, right? Times u prime, this is u. So u prime, which means times 5, right? So you need to rewrite this one as 5 natural log of 3 times 3 raised to the 5s. Be careful, you're not going to multiply 3 by 5, right? Remember. Now let's move on to question 11. Suppose that h of s equals this guy. Now you have g of 14 equals 12, g prime of 14 equals 5, f prime of 14 equals 15, f prime of 2 equals 12. We need to find h prime of 14, right? So we need to check the derivative of this one first, right? So h prime of s equals. Now this one is composite function, right? So it could be f prime of g of s times g prime of s, right? And then you have h prime of 14 equals f prime of g of 14 times g prime of 14, right? Substitute value, g of 14 is 2, so you have f prime of 2, right? G prime of 14 is 5 right here, right? So f prime of 2 is 12 right here. Times 5 equals 60, right? Now let's move on to question 12. We need to find the derivative of this one. So before we find the derivative of this one, we need to rewrite this one, right? So we have s to the 4 times s plus 1 power of 1 half, right? We need to use the product rule, right? So we have dy over ds equals derivative of s to the 4 is going to be 4s cubed, right? Times s plus 1 power 1 half, right? Derivative of this one is going to be 1 half times s plus 1 power of negative 1 half times s to the 4, right? So we just simplify this one. It's going to be 4s cubed square root of s plus 1, right? Plus, bring this one to the bottom, right? So we have s to the 4 over 2 square root of s plus 1, right? Now we need to find the LCD of this guy and this guy. The LCD should be this one right here, right? So I need to multiply the top and bottom of this one by 2 square root of s plus 1, right? So it could be 4s cubed times 2 is going to be 8, right? Square root of s plus 1 times square root of s plus 1 is going to be s plus 1, right? Plus s to the 4 over 2 square root of s plus 1, right? Now distribute this one and simplify, so we have 8s to the 4 plus this one is going to be 9s to the 4, right? Plus 8s cubed over 2 square root of s plus 1, right? We just factor s cubed out, right? So we have s cubed here, 9s plus 8 over 2 square root of s plus 1, right? Alright, let's move on to question 13. Given the table right here and given the value right here. Now we need to evaluate the first derivative of each of the following combination of LS and GLS. So we have derivative of this one, it could be G prime of f of s times f prime of s, right? So we need to evaluate this one as s minus 1, right? So we have G prime of f of negative 1 times f prime of negative 1, right? So f of negative 1 is 0 right here. So we have g prime of 0 times f prime of negative 1 is 2 right here, right? Now g prime of 0, 4, right? So 4 times 2 equals 8. Now question B. F prime of g of s times g prime of s, right? So substitute negative 1, right? So I have f prime of g of negative 1 times g prime of negative 1, right? So g of negative 1 is negative 1, right? So you have f prime of negative 1 times g prime of negative 1 is 1 right here, right? Now f prime of negative 1 is 2 right here. So we have 2 times 1 equals 2. Now question C. Derivative of this one is going to be g prime of s plus f of s times derivative of this one right here. So it could be 1 plus f prime of s, right? So we have g prime of 0 plus f of 0 times 1 plus f prime of 0, right? Now we're going to simplify. F of 0 is going to be negative 1, right? So we have g prime of negative 1 times 1 plus f prime of 0. F prime of 0 equals negative 2. Negative 2 plus 1 is going to be negative 1, right? Now g prime of negative 1 is 1 right here. So you have 1 times negative 1 equals negative 1, right? Now let's move on to question 14. Find f the program of LOS equals tangent phi s plus s squared. Remember, tangent u prime equals secant square of u times u prime, right? Where u equals phi s, right? So we have f prime of s equals secant square of phi s, right? And then times derivative of phi s is going to be phi, I put phi in the front, right? Now plus derivative of this one should be 2s, right? Next, we need to find the second derivative, right? And derivative of secant square of phi s, we need to use the power rule, right? So we have u to the n prime is going to be n times u to the n minus 1 times u prime, right? Where u equals secant phi s, right? Now this guy becomes phi, right? Apply the formula right here. 2 bring to the front, so it could be 2 times secant of phi s, right? Times u prime. U in this expression is secant phi s, right? So the derivative of this one is going to be secant u prime. It's going to be secant u times tangent u times u prime, right? So this one turns out to be secant phi s times tangent phi s times phi s prime. It could be phi, right? And the derivative of this guy right here becomes 2, right? So the final answer is 5 times 2, it could be 10 times 5, it could be 50. Now secant square of 5s, right? And then tangent 5s plus 2, right? So the answer is D, right? Now question 15. If h of s equals sine of ls, write an equation of the tangent line of h at the point where s equals 1, right? So first we need to find the slope, right? Remember we have the equation of the tangent line to be y minus y1 equals m times s minus s1, right? So we need to find the slope. It's going to be h prime of s equals, right? In this situation, we need to use the formula sine u prime. It's going to be cosine u times u prime, right? U in this situation is f of s, right? So we have f prime of s times cosine of f of s, right? Now we substitute 1 for s, so we have h prime of 1. This one actually the slope, right? It's going to be f prime of 1 times cosine of f of 1, right? Now we're going to simplify. F prime of 1 is root 2, right? Times cosine of f of 1 is 3 pi over 4, right? Now cosine of 3 pi over 4 is negative root 2 over 2, right? So we have square root of 2 times negative root 2 over 2, right? So the answer is negative 1, right? Now we need to find the order pair x1 and y1, which means we need to find the y value when s equals 1, right? So we have h of 1 equals sine of f of 1, right? So to be sine of f of 1 is 3 pi over 4, so sine of 3 pi over 4, right? It's going to be root 2 over 2. So we have the order pair 1 comma root 2 over 2. Now the equation of the tangent line is y minus y1, which means root 2 over 2 equals the slope is to be negative 1, right? Right here. Times s minus s1 is right here. Right? Question B. So basically we need to rewrite r of s as g of 2s all together power of negative 1/2, right? So we need to take the derivative of this one, r prime of s equals. Now remember we need to use the formula right here, right? So we have negative 1/2, right? G of 2s negative 1/2 minus 1 is to be negative 3/2, right? Times u prime, which means derivative of g of 2s, right? We just rewrite negative 1/2 g of 2s power of negative 3/2. Now for this one right here, right? This one is g of u. If you take the derivative of this one, it's going to be g prime of 2s. And then you need to take the derivative of the inner function right here, right? Because this is a composite function. So it could be 2, right? Now substitute 2 for s. It's going to be r prime of 2 equals negative 1/2 g of 4 power of negative 3/2, right? Times g prime of 4 times 2, right? So r prime of 2 is negative 1/2 times g of 4. G of 4 is 9 right here, right? So we have 9 to the negative 3/2, right? Times g prime of 4 is actually 3 right here, right? 3 times 2 equals 6, right? Now 6 divided by 2, it could be 3, so I have negative 3 on the top. I bring 9 to the negative 3/2 to the bottom, so it could be 3/2 like that, right? So it's going to be negative 3 over square root of 9 power of 3, right? So it could be negative 3 over square root of 9 equals 3. 3 cubed, it could be 27, right? So it could be negative 1 over 9, right? Now question C, find the values of A. If the tangent lines to the function f of g of s and g of ls are perpendicular at s squared 3, we need to find the slope of this guy first, right? So we take the derivative of this one. This guy turns out to be f prime of g of s times g prime of s, right? Now substitute 3 for s, right? So we have f prime of g of 3 times g prime of 3. Now g of 3 is 4, right? So we have f prime of 4 times g prime of 3 is 1/2. Now f prime of 4 is 2a squared, right? And then multiply by 1/2, it could be a squared, right? This is the slope of the first tangent line over here. Now similarly, you have g prime of f of s times f prime of s, right? So we have g prime of f of 3 times f prime of 3, right? So it will be f of 3 is 1, right? And g prime of 1 is 1 over 8, right? So this one is g prime of 1, right? Times f prime of 3. F prime of 3 is 5 right here. Now, remember we just say g prime of 1 equals 1 over 8, right? So it could be 5 over 8, right? Now, if two lines are perpendicular, their slopes are opposite and reciprocal. In other words, their slope product must be equals -1, right? So we have a squared times 5 over 8 equals -1, right? Remember, a must be different from 0, because if a equals 0, this guy is undefined, right? So because a not equal to 0, I can cancel out this guy and this guy. So I have 5a equals -1. A equals -1 over 5. This one is the answer. Now question number 16, we need to take the derivative of this one with respect to s, right? So we have product rule right here, right? So we have derivative of y should be dy over ds, right? So e to the s dy over ds, right? And then derivative of e to the s is e to the s, right? So times y is going to be the same, right? So y times e to the s. Now derivative of s is going to be -1, right? Derivative of this one should be 2y dy over ds, right? Now we need to bring dy over ds to the left and factor them out, right? So we have e to the s. Bring this one to the left, it should be 2y, and you factor dy over ds out, right? Equals. Bring this one to the right hand side, this one to the right hand side, right? So it could be 1 minus y e to the s, right? And divide both sides by this guy over here, right? So dy over ds equals 1 minus y e to the s divided by e to the s minus 2y, right? Now question 17, we need to find the derivative of this one with respect to s, right? So we have dy over ds equals 4s, right? Plus 2y dy over ds, right? Minus, use the product rule, right? Derivative of s equals 1, right? So I only have -y, right? Derivative of y equals dy over ds, right? And then times s, right? So minus s dy over ds. Derivative of this one equals 0, right? So we factor dy over ds, and so we have dy over ds times 2y minus s, right? And then I'm going to move this one to the right, move this one to the right. I need to change the side, right? So I have y minus 4s, right? Divide both sides by this guy, so dy over ds equals y minus 4s divided by 2y minus s, right? Now, question B, write the equation of the tangent lines when x equals 1. So you need to find the slope, right? So dy over ds, evaluate this one as x equals 1. Substitute 1 for x into this one right here. Right? So we have, and don't forget to find y. Substitute this one back to original one right here to solve for y first, right? So I have 2 plus y squared minus y equals 4. So y squared minus y minus 2 equals 0. So it will be y minus 2 times y plus 1 equals 0. So y equals 2 and y equals negative 1, right? So you have two tangent points right here. The first order pair should be 1, 2. The second one should be 1, negative 1, right? So x equals 1, y equals 2. Substitute over here, so you have 2 minus 4 over 2 times 2 minus 1. So it's going to be negative 2 over 3, right? And the second one is dy over ds as x equals 1 and y equals negative 1. X equals 1, y equals negative 1, so it will be negative 1 minus 4 times 1 over 2 times negative 1 minus 1, right? So it will be negative 5 over negative 3, so it should be 5 over 3, right? So you have two tangent lines. Now, for the first one right here, I have the equation x to be y minus y1 is 2 right here, equals the slope negative 2 over 3 times s minus s1, which means 1 right here. Now the second one, y minus y1 is to be right here, negative 1, so it should be plus 1, equals the slope is 5 over 3 times s minus this one, right? Now question C, find the y values of each point on the curve where the tangent line is vertical. So remember, we need to use the Christmas tree trick. Alright, the lines go this way, the slope is positive. Tangent line go this way, slope is negative. Tangent line is horizontal, the slope is 0. Tangent line is vertical, the slope is undefined. Right? So we go back over here, the slope is right here. Now the slope is undefined when denominator equal to 0. Right? dy over ds is undefined. Right? So it's going to be 2y minus s equals 0, right? So then s equals 2y, right? Now we substitute 2y for s back to original function right here, right? So we have 2 times 2y squared plus y squared minus 2y times y equals 4, right? Actually, this is 4, this is a typo. Alright, so we have 8y squared plus y squared minus 2y squared equals 4, right? So it should be 7y squared equals 4, right? So y equals square root of 4 over 7, don't forget plus and minus, so it will be plus and minus 2 over square root of 7, right? So you have two values of y. Now let's move on to question 18. Find an expression for dy over dx in terms of x and y, right? So very simple, you check the derivative of this one with respect to x, right? So we have 2x plus derivative of this one should be y plus s dy over dx plus 2y dy over ds equals 0, right? Factor dy over dx out, so we have s plus 2y times dy over ds equals, bring this one to the right hand side and change the sign, right? So I have minus 2x plus y, right? So then dy over ds equals negative of 2x plus y divided by x plus 2y, right? Now question B. Find all points on the curve where the tangent line is parallel to the line of this one. So when two lines are parallel, the slope should be the same. So the slope is right here, and the slope of this guy is -2. So we have -2x minus y over x plus 2y equals -2, right? So I'm going to multiply both sides by x plus 2y, so this guy turns out to be -2x minus y equals -2x minus 4y, right? So then I'm going to simplify this one. Both sides have -2x, this guy gone, right? So I have -y plus 4y equals 0. So it turns out to be 3y equals 0 and y equals 0, right? Now substitute 0 for y back to the original function right here to solve for s, right? So we have s squared plus 0 equals 1, right? So s equals plus and minus 1. So you have two order pairs. The first one s equals 1, y equals 0. The second one x equals -1, y equals 0, right? Now question C, find all x values on the curve where the tangent line is horizontal, right? So remember, we have the Christmas tree trick right here. The line is horizontal, the slope equals 0, right? So which means dy over dx equals 0 when the top equals 0 and the bottom must be different from 0, right? So you have a system of two equations. You have -2x minus y equal to 0, right? And x plus 2y must be different from 0, right? So I just solve the top, so I have y equals -2x, right? So then I substitute -2x for y back to the original function right here to solve for x, right? So I have x squared plus x times -2x plus -2x squared equals 1, right? So to be x squared minus 2x squared plus 4x squared equals 1, right? So to be 3x squared equals 1. So x equals plus and minus root 3 over 3, right? Alright, so we substitute this guy back over here to solve for y. So y equals minus and plus 2 root 3 over 3. So basically, you have the order pair root 3 over 3, comma, -2 root 3 over 3, and -root 3 over 3, and 2 root 3 over 3. Of course, when you substitute these two guys back to this guy right here, right, this guy must be different from 0, right? So you have two solutions right here. Now let's move on to question number 19. Given this guy, this guy, this guy, and this guy, we need to find the derivative of the inverse function at s equals 10. So remember, we have the formula. Alright, so we have f inverse of 10 prime equals 1 over f prime of inverse function of s at s equals 10, right? If two functions are inverse of each other, the domain of this function will be the range of the other function. Or, in other words, the input of this function will be the output of the other function, right? So you have inverse of f of 10, right? So this guy is the input of the inverse, becomes the output of the original function, which means output right here. So it should be 6, right? So we have 1 over f prime of 6, right? Now f prime of 6 is -5, so the answer is -1 over 5, right? Now question 20. We need to find this one given this guy, right? So basically, we have the same formula right here, right? So remember, this one is the input of this guy, and it becomes the output of this guy right here, right? So you have, I'm going to simplify this one, so it turns out to be SQ plus 5S plus 42 equals 0, right? Now I'm going to use the rational root theorem to solve for this one. 42 divided by 1 equals 42. So I need to find the factor of this one, so it should be plus and minus 2, right? Plus and minus 3, right? plus and minus 6 plus and minus 7 and plus and minus 14, right? Plus and minus 21 and plus and minus 42 plus and minus 1, right? By using mental math and substitute negative 3 for s, I know that both sides equals 0, right? So I'm going to use synthetic division to divide, right? So I have negative 3 right here. Coefficient of SQ is 1, coefficient of SY is 0, and then 5 and 42. Bring 1 down, negative 3 times 1 plus 0, it could be negative 3. Negative 3 times negative 3 equals 9. 9 plus 5 should be 14. Negative 3 times 14 equals negative 42 plus this one equals 0, right? So, SQ plus 5S plus 42 equals 0 can be written as S plus 3 times S coefficient right here square minus 3 S right here plus 14 equal to 0, right? So each of this one must be equal to 0, right? So S plus 3 equal to 0, and then S squared minus 3S plus 14 equal to 0, right? This guy right here has no solution because discriminant is less than 0, right? So we only have one solution right here, S equals negative 3, right? So we substitute negative 3 for S back over here, right here. So we have F inverse prime of negative 12 is 1 over F prime of negative 3, right? Now, in order to find F prime of negative 3, we need to take the derivative of this function and substitute negative 3 for S, right? So I have F prime of S equals plus 5 over 3, right? So F prime of negative 3 is 9 plus 5 over 3 equals 32 over 3, right? Now go back over here, so we have F prime of F inverse of negative 12 equals 1 over F prime of negative 3, which means 32 over 3. So it will be 3 over 32. This one is the final answer. Now let's move on to question 21. Let F equal this one and let G be the inverse of the function f. Given f of 0 equal 3, what is the value of G prime of 3, right? So we have G prime of 3 is actually f inverse prime of 3, right? Because f and g are inverse, right? So, but this one equals 1 over f prime of f inverse of 3, right? 3 is the input of this one, and it's actually the output of original function right here, right? So you have f of s right here must be equals 3, right? Square both sides, you have e to the s plus 3s plus 8 equals 9. So you have e to the s plus 3s minus 1 equal to 0. So by mental math, you observe that s equal to 0 is the solution. You have f inverse prime of 3 equals 1 over f prime of 0, right? Now, in order to find f prime of 0, you need to take the derivative of this one, right? So we have f prime of s equals, convert this one to exponent, and then you need to use the power rule, right? So I'm going to bring 1/2 to the front of e to the s plus 3s plus 8 to the negative 1/2, right? Times u prime, which means this one derivative, so it could be e to the s plus 3, right? So we have f prime of 0 is 1/2 times e to the 0 equals 1, and then this guy for 0 plus 8 power of negative 1/2, right? Times 1 plus 3, right? Then it's going to be 1 over 2 square root of 9 times 4, right? 4 divided by 2, it could be 2. And then square root of 9 equals 3, so it could be 2 over 3, right? Now bring this one back over here. So it could be f inverse prime of 3 equals 1 over 2 over 3, which means 3 over 2. This one is the final answer, right? Now let's move on to question 25. Find the derivative of the function f of s equal cosine 3x squared minus 1. Now remember, we have the formula derivative of cosine of s equals negative 1 over square root of 1 minus s squared, right? Now this one is not s, this one is u, right? So this is composite function. D over d u cosine of u equals negative u prime over square root of 1 minus u squared, right? Where u is this guy right here, right? So we just plug in, so it could be negative u prime, which means derivative of this one, it could be negative 6s, right, over square root of 1 minus 3s squared minus 1 altogether square, like that, right? So the answer should be D. Now let's move on to question 23. Remember, we have the derivative of tangent s equals 1 over 1 plus s squared, right? Now, in this situation, it could be derivative with respect to use of tangent u. It could be u prime over 1 plus u squared, right? Where u equals 5s, this one is the composite function, right? So basically, we have f prime of s. We need to use the product rule, right? So it could be 2s tangent of 5s plus derivative of this one. We use the formula right here. So it could be 5 over 1 plus 5s altogether square, right? And then times s squared right here. Now we're going to simplify, so it could be 2s tangent 5s, right? Plus 5s squared over 1 plus 25s squared, right? So the answer must be C. Now let's move on to question 24. Let f of s equal this one, find f prime. So f prime equals 1 over square root of 1 minus s squared, right? Derivative of this one should be negative 2, like that. Now question B, find the equation of the tangent line to the function f of s at a point where s was 0, right? So substitute 0 for s over here to find the slope, right? So the slope is f prime of 0 is going to be 1 minus 2 equals negative 1, right? And then you need to find the order pair, right? So you have x for 0, substitute 0 for s back over here to find the y value, right? So I have f of 0 equals sine of 0 minus 2 times 0, right? Sine of 0 equals 0, so this guy equals 0, right? So we have the order pair 0 and 0, and you have the slope right here, right? So you have the equation y minus y1 equals m times s minus s1, right? So the order pair right here 0 0, right? So you have y minus 0 equals negative 1 times s minus 0, right? So you just simplify this one, so it will be y equals negative s. This one is the final answer. Now let's move on to the question 25. Now pause A and B refer to the following situation. The position of the particle moving along the x-axis for any time t greater than or equal to 0 is given by this equation, where s of t is measured in inches and t is measured in seconds. Find the velocity of the particle at t equals 2 seconds. Alright, so basically you need to find v to actually s prime of 2, right? So you're gonna bring up the calculator. Now you need to store the function, right? You're gonna press Control and the button right here. Alright, so you just input this one, so then press enter, done. Now we need to evaluate the velocity of this function as t equals 2, right? So basically, you're gonna press this button right here, go to the derivative right here, okay? So right here, you just put the variable t, and this one right here, you just input as of t, right? And then right here, you just put the line. You're gonna press Control equals right here, put a line right here, right? So right here, you just put t equals 2, and then you press Enter. It's going to give you exact value right here, but you need decimal number. So you just press Control Enter, negative 0.855. Now question B, find the acceleration of the particle at t equals 6. We do exactly the same thing, right? So we take the second derivative of this guy and evaluate this guy as t equals 6, right? So we're going to press the button right here, the second derivative right here. Right, so we put t right here and s of t, right? And then press Control equals, put a line right here, and input t equals 6, and then press Control Enter. It's going to be negative 0.27, right? Now let's move on to question C and D. The graph of the relation for values y such that y from negative 1 to 11 is shown to the right. It's known that the y over the x equals this one. Verify this is true. So basically, you just take derivative of this one, both sides with respect to s, right? Derivative of this one is going to be 2s, right? Because this one agrees, so we don't need dy over dx anymore, right? Derivative of negative 2 equals 0. Derivative of this one should be dy over dx. Derivative of this one should be negative 5 sine y dy over ds, right? Now you're going to factor dy over ds out, right? So it's going to be 1 minus 5 sine y, right? Equals 2s, right? Divide both sides by this one, so dy over ds equals 2s divided by 1 minus 5 sine y, right? Now let's move on to the last one. Question D, for y less than equal to 11. The graph possesses three different vertical tangent lines. What is the equation of the vertical tangent lines that has the smallest positive s value, right? So you know that the vertical tangent line occurs when the slope is undefined, right? Remember Christmas tree trick. Now when the slope is undefined, which means the denominator is equal to 0, right? So we just let f of y equals 1 minus 5 sine y, right? And equal to 0, right? So basically, we just use the calculator, graph this one. Now, remember, we need to restrict the domain from negative 1 to 11, right? So we bring up the calculator, go to the home screen, and graph right here. Put 1 minus 5 sine s, right? Press enter. It's going to be like this. Now you need to go to the menu number 4. You need to set the window, right? So the window should be from negative 1 to 11, right? And then you press enter. Now we need to find the 0, right? So we need to press menu number 6, 0 right here. Move to the left, move to the right of 0, we get the first one, right? Same thing, menu number 6, 0, move to the left, move to the right, we get the second one right here. Third one, menu, analyze graph, 0, this guy, the first one. And menu, analyze graph, 0, the last one right here. After you found the 4 values of y, you substitute these 4 values back to the original equation right here to solve for s, right? And this one is the vertical tangent line, s, equals 1.525. We're going to review Unit 4 for AB, calculus, AB, and BC. Alright, question number 1. If a rock fans enter a line to buy tickets to see the renowned band Sir Isaac and the Newtons at a rate modeled by the function e of t equals 512.7 e to the negative 0.173t, where et is measured in people per minute and t is measured in minutes for the interval 0 to 30. Find e prime of 22. So basically, we need to calculate the derivative of this one, and then we substitute 22 for t, right? This one is the calculator active problem. So we're going to bring up the calculator, right? Now we need to store the function, right? So in order to store the function, we need to enter e of t, right? So I have e right here of t. And then you press Control and put the next to number 9. And then you enter 512.7 times e to the negative 0.173, right? And then press Enter, done. Now we need to calculate e prime of 22, right? So we just press the button right here, derivative right here. So we take derivative of this one with respect to t, right? And this one should be e of t. Then press Control equal sign, put a line right here, and then type t equals 22. And then press Enter. The answer is negative 1.97235, right? Now, be careful with the unit. The unit should be people per minute and per minute, right? Because this one is the rate of this one, right? So you need to say people per minute, or you just say people per minute square, right? Now, we need to interpret its meaning in the context of the problem. So we need to say the rate at which people entering the line to buy tickets is decreasing by 1.972 people per minute, right? Now let's move on to question 2. The graph below shows the velocity v of t of a particle moving along the x-axis can be defined by a continuous linear piecewise defined function over the interval 0 to 9. Note that v prime of t equals 0 on the interval 3, 4. So 3 right here and 4 right here. You see the horizontal line, which means the slope equals 0. Right? Remember, we have the Christmas tree trick. If the line is going this way, the slope is positive. If the line is going this way, the slope is negative. If the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Alright, so we go back over here. Question A. Over which time intervals does the particle move to the left? So keep in mind, when the particle moves to the left, v of t must be less than 0. Alright, move to the right, v of t must be greater than 0. Right? Now, this is the function v of t. So v of t less than 0, which means it's below the axis, right? So it's going to be this guy right here, below the axis, and this guy right here. Right? So the interval should be 0 to 2, right? Union 6 to 9, right? Because v of t less than 0 on those intervals. Now question B. Over which time intervals is the particle speeding up? Alright, so when the particle speeding up, v, t, and at should have the same sign, right? So which means vt greater than 0, at t greater than 0 or vt less than 0, at less than 0. Or you can combine these two guys as one inequality. That's equal vt times at always greater than 0, right? First, we need to check where vt greater than 0. So vt greater than 0, which means it's above the axis, right? So it's going to be from here to here, greater than 0, right? And then at must be greater than 0, yes, because at is the derivative of vt, right? Which is the slope of vt, right? The slope right here is positive. Look at the Christmas tree trick right here, right? So it should be from 2 to 3, right? So I'm going to write over here 2 to 3 union. Now this guy is above the axis, but at is less than 0, right? Because the slope right here is less than 0, right? Look at the Christmas tree trick right here, right? Now next one, vt less than 0 and at less than 0, right? So vt right here is less than 0, but at is greater than 0, right? Because the slope right here is positive, right? This guy less than 0, right? And at less than 0, right? So this one was from 6 to 8. Now this is vt less than 0, but at greater than 0, right? So you know 6 to 8 only. Because vt and at have the same sign. Now let's move on to question C. Over which time intervals is the particle's speed decreasing? Now, you need to be careful. Speed decreasing is different from velocity decreasing, okay? Speed is the absolute value of velocity, so be careful. Now, speed decreasing is the same thing as slowing down, right? It means velocity and acceleration have the opposite sign. In other words, vt times at less than 0, right? Now, vt and at have opposite side when t from 0 to 2 right here, right? Because on this interval, vt less than 0, right? Because it's below the axis and at is greater than 0, right? Because the slope right here is positive. And then this one right here, vt is greater than 0, but at less than 0, right? Because the slope is negative. And this interval right here, from 8 to 9, vt is less than 0, at is positive, right? So you have three intervals. It's going to be 0 to 2, union 4 to 6, union 8 to 9, right? Now let's move on to question 3. If square root of x plus y equals 6, dy over dt equals 2, find dx over dt when x equals 4. Now let's move on to question 3. If square root of x plus y equals 6, dy over dt equals 2, dx over dt equals how much when x equals 4. Okay, so first we need to take derivative both sides with respect to t, right? So derivative of square root of x is 1 over 2 square root of x. Alright, I'm going to show you the faster way to calculate the derivative of square root of x. Is going to be square root of x prime equals 1 over 2 square root of x. Square root of u prime equals u prime over 2 square root of u, where u is a composite function, so keep that in mind. Alright, so this guy turns out to be ds over dt, right? Now, plus derivative of y is going to be 1, right? So dy over dt left, right? Equals derivative of it equals 0, right? Now you just plug in values. S equals 4, substitute over here. So 2 square root of 4 is going to be 4, right? So it could be 1 over 4 ds over dt, right? Plus dy over dt equals 2 right here. Equals 0, right? Now subtract 2 both sides and then multiply both sides by 4, right? So we have ds over dt equals negative 8. This one is the final answer, right? Now let's move on to example number 4. A kite is flying at a height of 40 feet, right? So this one is the height, 40 feet right here. A child is flying it so that it's moving horizontally at a rate of 3 feet per second. Horizontally is right here, right? And this one should be ds over dt equals 3, right? ds over dt. Now, if the string is taut, at what rate is the string being let out when the length of the string release is 50 feet? So this one is z, right? Z right here is the string, right? The question asks you at what rate is the string being let out, which means dz over dt equals how much, right? Now look at this one. This is a right triangle. We're going to use the Pythagorean theorem, right? So we have z squared equals s squared plus h squared, right? Now we're going to take the derivative both sides with respect to t, right? So the question asks you what is the dc over dt, right? Now look, z equal 50 right here. You're not going to substitute 50 directly over here, because if you substitute 50 over here, when you set the derivative, it's going to be 0, right? But we need dc over dt, right? So we just leave this one as variable. So we have 2z dz over dt, right? Equals. Same thing. We given ds over dt equal 3. We need to use this one, right? So check the derivative of this one with respect to t is going to be 2s ds over dt, right? Now the height right here is given right here 40, right? We substitute 40 for h right here, and then when we take the derivative, it's going to be 0, right? Now we given z equals 50 right here, right? So we have 2 times 50 times dz over dt equals 2 times s, but s is not given, right? Now we're gonna calculate s on the side, right? So we have z squared equals s squared plus h squared, right? Z equal 50, right? So we have 50 squared equals s squared plus 40 squared, right? So s squared equals 50 squared subtract 40 squared, right? And it's going to be 2500 subtract 1600 is going to be 900. Take square root both sides, so s equals 30, right? Substitute 30 over here, right? So we have 2 times 30 times ds over dt equals 3, right? So times 3 right here. Then dz over dt equals 2 times 3 equals 6 times 30 is going to be 180, right? Divide by 100, right? So it's going to be 18 divided by 10, and it's going to be 9 over 5, right? Now don't forget to include the unit. It's going to be feet per second, right? Now let's move on to question 5. A spherical snowball is being made so that its volume is increasing at the rate of 8 cubic feet per minute, right? So increasing, which means positive, right? The rate, so which means dv over dt equals 8, right? Now find the rate of change at which the radius is increasing when the snowball is 4 feet in diameter, right? So we have diameter equals 4, and then radius equals 2, right? Now the question wants you to find the rate of change at which the radius is increasing, which means you need to find dr over dt equals how much, right? So we're going to use this formula right here. Check the derivative both sides with respect to t, right? So we have dv over dt equals, bring 3 to the front, it's going to be 4 pi r squared, right? Don't forget dr over dt, right? So this is what we need to find, right? dv over dt equals 8 right here, right? So substitute 8 equals 4 pi. The radius is 2, so square is going to be 4 dr over dt, right? And then dr over dt equals 8 divided by 16 pi, right? So it will be 1 over 2 pi, right? Don't forget the unit feet per minute, right? Let's move on to example number 6. Sand is being dropped onto a conical pipe at a rate of 10 cubic meters per minute. So this guy in sand, so it should be dV over dt equals 10, right? If the height of the pipe is always twice the base of the radius, right? So this is the height right here and the base right here, right? So this is the radius. This guy, the height should be 2 times r, right? So we connect this one to make the right triangle right here, right? At what rate is the height increasing when the pile is 8 meter high, right? So the height is 8. Then the radius must be 4, right? And they ask you to find dh over dt. Now, we're going to take the derivative of both sides with respect to t. But keep in mind, dr over dt is not given, right? So if we leave it like this, and when we take the derivative both sides with respect to t, we get dr over dt, right? Look, we have dv over dt equals 1/3 times 2rh dr over dt plus dh over dt times r squared, right? So we have dr over dt right here, but it's not given, so we stop right here, right? So don't do this way. We need to use the information right here, right? The height is double radius, right? So we need to convert every single thing in terms of height, right? So this means radius equals the height divided by 2, right? So we have v equals 1/3 pi times height divided by 2, and then square, right? Times h. Now we're going to simplify, so it will be v equals 1 over 12, right? Pi times h cubed, right? Now we're going to take the derivative both sides with respect to t. So we have dv over dt equals 1 over 12 times pi, right? Bring 3 to the front. So it turns out to be 1 over 4, right? Times pi times h squared times dh over dt, right? And then we just substitute values. dv over dt equals 10 equals pi over 4 times h right here is 8. h squared equals 64, right? Times dh over dt, right? Now 64 divided by 4, it could be 16, right? So dh over dt equals 10 divided by 16 pi, right? Or 5 over 8 pi, right? Don't forget, unit, it should be meter per minute. Now let's move on to question 7. The volume of a cube is increasing by 10 cubic centimeter per minute. So this one actually dV over dt, right? Find the rate of the surface area, which means dA over dt, right? Is increasing when the size of the cube is 5 centimeter, right? So I call the size of the cube as b, right? So b right here is 5. This one still b, this one still b, right? Now remember, we need to calculate dA over dt. We know that the surface area is the area of one side multiplied by 6, right? So the area of one side should be b squared, right? Then you multiply by 6, right? Now to calculate dA over dt, check the derivative both sides with respect to t, right? So we have dA over dt equals 12b dB over dt, right? But dB over dt is not given, right? We have it right here. So we need to use the volume formula to calculate dB over dt, right? The volume of the cube equals b cubed, right? Take the derivative both sides with respect to t. So we have dV over dt equals 3b squared dB over dt. Now we substitute value dV over dt equals 10 right here. So we have 10 equals 3 times b equals 5, right? So it will be 5 squared times dB over dt, right? Then dP over dt equals 10 divided by 75, right? If you simplify, it's going to be 2 over 15. Then we substitute 2 over 15 for dB over dt right here, right? So we have dA over dt equals 12 times B equals 5, right? And then times 2 over 15, right? Now, if you simplify 5 and 15 right here, it's going to be 3. 12 divided by 3 is going to be 4. 4 times 2 is going to be 8, right? So, dA over dt equals 8 square centimeter per minute, right? Now, let's move on to question 8. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate 2000 cubic centimeters per minute, right? So we have dV over dt equals 2000, right? The oil slick takes the form of right circular cylinder with both its radius and height changing with time, right? So we just draw the cylinder at the instant when the radius of the oil slick is 100 centimeters and the height is 0.5 centimeters, right? So this is the radius right here. This is 100, right? And the height right here is 0.5. The radius is increasing at the rate 2.5 centimeters per minute. So we have dr over dt equals 2.5, right? At this instant, what is the rate of change of the height of the oil slick with respect to time in centimeters per minute? So we need to calculate dH over dt, right? Now we need to use the volume formula right here. This is the volume formula of the cylinder, right? So we need to take the derivative side with respect to t. So we have dV over dt equals pi. Now we need to use the product rule, right? So we have 2r times h dr over dt plus r squared dh over dt, right? Now we just substitute values. dV over dt is given by right here, right? So it could be 2000 equals pi times 2r. R equals 100, right? So we have 2 times 100 times 0.5. dr over dt is going to be 2.5, right? Plus 100 square times dh over dt. We don't know it. We need to find, right? So we put dh over dt here. Now we need to simplify. We have 2000 here equals pi. Now 2 times 0.5 is going to be 1, right? So 1 times 100 is going to be 100 times this one is going to be 250, right? So we have 250 times pi, right? Plus 100 square is going to be 10,000 pi dh over dt, right? So dh over dt equals 2000 subtract 250 pi divided by 10,000 pi, right? Now we're going to simplify this one. So we just divide the top and bottom by 10. So we have 200 subtract 25 pi divided by 1000 pi, right? And then we just divide the top and bottom by 25, right? So it should be 8 minus pi divided by 40 pi centimeter per minute, right? Now let's move on to question B. A recovery device arrives on the scene and begins removing oil. The rate at which oil is removed is given by this function, cubic centimeters per minute, where t is the time in minutes since the device began working. Oil continues to leak at a rate of 2000 cubic centimeters per minute. Find the time t when the oil slick is not changing the volume. Alright, so the rate of change of the volume of the oil is leak rate subtract removal rate. Find the time t when the oil slick is not changing the volume. It means this guy subtract this guy equals 0, right? Now we have leak rate, it's going to be right here. 2000 subtract 400 square root of t equals 0, right? And then it's going to be 400 square root of t equals 2000, right? And then square root of t equals, divide both sides by 400, it's going to be 5, right? Square both sides, so t equals 25 minutes, right? Now let's move on to question 9. Meanwhile, Mr. Julio decides to get some punch from the freshman table. The punch is being served from the conical punch bowl with a spigot at the bottom. The volume is given by 1/3 pi r square each. Mr. Julio notes that the punch bowl has a diameter of 18 inches and the height of 12 inches, right? So the diameter is the distance from here to here, right? As he serves himself punch from the spigot, he notes that the height of the punch in the bowl is decreasing at a rate of 1/2 inches per second, right? So d little h over dt equals negative 1/2, right? Decreasing, which means negative. And the height of the punch at this moment is 6 inches, right? So this one is 6. How fast is the volume of the punch in the bowl decreasing at the moment? So we need to calculate dv of dt equals how much? Now remember, dr over dt is not given. So when you take derivative both sides with respect to t, you're gonna get stuck because you have dr over dt right here, right? So you need to use the similar triangle you learn in geometry to calculate r in terms of h, right? So remember, we have this triangle right here and the bigger triangle right here, similar, right? So we have the little r over 9 is the same thing as the little h right here over 12, right? And then r equals 9 over 12 times h is going to be 3h divided by 4, right? The volume formula can be written as v equals 1/3 pi r squared times h, but r equals 3h over 4, right? So we have v equals 1/3 pi times 3h over 4 square times h, right? And then v equals 3 square equals 9 divided by 3, it could be 3. So we have 3 pi over 16h cubed. Now you can take derivative both sides with respect to t, right? So we have dv over dt equals 3 pi over 16. Bring 3 to the front, so this guy becomes 9, right? H squared dh over dt. dv over dt is what we need to find, right? Equals 9 pi over 16. H equals 6 right here, right? So it could be 36 times dh over dt, it could be negative 1/2, right? So if you simplify this one, it turns out to be 36 divided by 2, it could be 18, right? 18 divided by 2, it could be 9, and this guy divided by 2, it could be 8, right? So we have 81 pi over 8. Don't forget negative sign, right? And the unit should be cubic inches per second, right? So you need to conclude that the volume is decreasing at 81 pi over 8 cubic inches per second, right? Now question B. How fast the circumference of the surface of the punch decreasing at the moment? It's actually the circumference of this circle right here, right? So we have circumference is given by c equals 2 pi r, right? But r equals 3 over 4 times h, we calculate above, right? So it's going to be 3.5 pi times h, right? Now we need to take derivative both sides with respect to t. So we have dc over dt equals 3 over 2 pi dh over dt, right? And it's going to be 3 over 2 pi dh over dt is given by this one right here, right? Negative 1/2 is going to be right here. So times negative 1/2. So it's going to be negative 3 over 4 pi, right? Don't forget to include the unit. It's going to be inches per second. So we need to conclude that the circumference is decreasing at 3 over 4 pi inches per second. Now question C. Mr. Julio is serving the punch into the cylindrical paper cup with the radius of 4 inches and the height of 5 inches. How fast is the height of the punch in his cup increasing at this moment, right? So this one right here, the radius is 4, right? The height is 5, right? You need to find dh over dt of this cylinder right here, right? Now remember, the volume of the cylinder is given by V equals pi r squared times h, right? And then remember, you have dv over dt is negative 81 pi over 8 from this guy right here, right? So if this guy leaking, does that mean this guy right here gaining, right? So basically, negative 81 pi over 8 becomes positive for this guy right here, right? So I'm going to use the formula V equals pi r squared times h, right? And then it's going to be pi times 4 squared times h, right? Now remember, you need to calculate dh over dt. So you're not going to substitute 5 for h over here, because if you do like that, you take the derivative both sides, it's going to be 0, right? So be careful, you need to keep that one. So you need to calculate dh over dt right here. Alright, so we just substitute 4 for r, right? So now you're going to take the derivative both sides with respect to t. So dv over dt equals 16 pi dh over dt. Now remember, dv over dt is 81 over 8 pi, right? Equals 16 pi times dh over dt. Now dh over dt equals 81 pi divided by 8 times 16 pi right here, right? So pi and pi cancel out, right? And I have 81 divided by 128, right? And don't forget the unit is going to be inches per second, right? Now let's move on to question 10. Use the tangent line approximation for f of s equals square root of s at s equals 64 to approximate square root of 65 minus square root of 63. Alright, so first we need to take derivative of this one, right? Derivative of f of s equals 1 over 2 square root of s, right? Now you need to calculate f of 64. Substitute 64 over here is going to be square root of 64, and it's going to be 8. Also, you need to calculate f prime of 64 to find the slope, right? So it will be 1 over 2 square root of 64, right? So it will be 1 over 16, right? Now remember, the equation of the tangent line is given by the formula y minus y1 equals m times s minus s1, right? M is right here, the slope, right? So we have equation is going to be y minus 8, right? This one right here, y1 equals, the slope is 1 over 16 times s minus s1. S1 is given by right here, right? 64. Remember, the order of pair should be 64, 8. So keep that in mind. So I need to rewrite this one in the slope intercept form, right? And I have y equals 8 plus 1 over 16 times s minus 64, right? So I name y as L of s, right? Equals. So I have f of square root of 65 minus f of square root of 63, right, is, so actually s equals 65 and 63, right? Substitute 65 and 63 for s into this expression right here. So you have 8 plus 1 over 16 times 65 minus 64, right? Minus the second one, 8 plus 1 over 16, 63 minus 64, right? So we have 8 plus 1 over 16, right? Negative 8 plus 1 over 16, right? So it's going to be 2 over 16 and it's going to be 1 over 8, right? Now question 11. Let g be a function given by g of s equals this. F of negative 1 equals 3, f prime of negative 1 equals negative 2. Use the tangent line to g at s equals negative 1 to approximate g of negative 0.9, right? So we need to calculate g prime of s, right, to find the slope first, right? So we're going to use the product rule, right? So it could be f of s plus s times f prime of s, right? And then you need to calculate g prime of negative 1, right? Look at s equals negative 1. So it could be f of negative 1 minus 1 times f prime of negative 1, right? So it's going to be f of negative 1 is 3 right here, minus f prime of negative 1 is negative 2, right? So minus negative 2 is going to be 5, right? Now you need to find the order pair, right? So we have g of negative 1 is substitute over here. So we have negative 1 times f of negative 1, right? So it could be negative 1 times 3 is going to be negative 3. So the order pair should be negative 1, comma, negative 3. Now we're going to use the equation y minus y1 equals m times s minus s1, right? M is 5 right here, right? So we substitute, so we have y equals 5 times s minus s1, which means negative 1 right here, right? And then you add y1 both sides, right? Which means negative 3. So we simplify, it's going to be 5s, right? Plus 2. Now you can replace y with L of s, right? G of negative 0.9 is the same thing as L of negative 0.9, right? It's going to be 5 times negative 0.9 plus 2, right? So it's going to be negative 4.5 plus 2, and it's going to be negative 2.5, right? Let's move on to question 12. Given a function f of s, the linear approximation for this one is given by what, right? So we have the linear approximation, then the line should be y minus y1 equals m times s minus s1, right? Or y equals m times s minus s1 plus y1, right? Now, suppose s equals a right here, right? So in order to find y, doesn't mean we need to calculate f of a, right? And in order to find the slope of the tangent line at s equals a, doesn't mean we need to calculate f prime of a. And this guy actually the slope, right? So substitute this guy right here s1, this guy y1, but o right here. So we have y actually L of s, right, equals m, which means f prime of a times s minus a plus f of a, right? So f of a plus 0.1 is right here, right? Is the same thing as L of a plus 0.1, right? So substitute a plus 0.1 for s, right? So it's going to be f prime of a times a plus 0.1 minus a, right? Plus f of a, right? So it's going to be f prime of a times 0.1, right? Plus f of a. Now 0.1, which means 1 over 10, right? So we have f prime of a divided by 10 plus f of a, right? So the answer must be B. Now let's move on to question 13. Find the error using the linear approximation of Fs equal this one at s square 1 to approximate this one, right? So first we need to find the equation of the tangent lines, right? So we have f prime of s equals 2 times 1 minus 2s times negative 2, right? So we have negative 4 times 1 minus 2s, right? So we have f prime of 1, right? Because the equation of the tangent line at this point. So it could be negative 4 times negative 1. So the answer is 4, right? Now we need to find the order pair, right? So we need to calculate f of 1. It's going to be substitute 1 minus 2 square equals 1, right? So the order pair x1, y1 equals 1 comma 1, and the slope is right here, right? So the equation of the tangent line is y minus y1. y1 is 1 equals m, which is 4 times s minus s1, which is 1, right? So if I simplify this one, it's going to be 4s minus 4, and then you add 1, it's going to be minus 3, and replace y with L of s, right? Now we need to approximate this one, right? So the estimate is L of 0.9. It's going to be 4 times 0.9 minus 3, right? So it's going to be 3.6 minus 3 is going to be 0.6. Now we need to find the actual value, right? The actual value is, we substitute 0.9 into this equation here, right? So we have f of 0.9 equals 1 minus 2 times 0.9 altogether square, right? So it could be 1 minus 1.8 altogether square, right? So it could be negative 0.8 square, so it could be 0.64, right? Now the error is absolute value of actual subtract estimate, right? Remember, you have a trick to memorize. It should be E, A, E, right? A between 2E, right? So the be absolute value of 0.64 subtract 0.6, right? So it could be 0.04. So the answer must be A. Now let's move on to question 14. We need to find the limit of this one, right? So we need to find the limit of the numerator first. When s approaches 1, it's going to be e times 1 minus e to the first, right? So it could be 0. Now the bottom limit when s approaches 1 equals 1 minus 1 equals 0. So you have the indeterminate form 0 over 0. We need to use the last below rule, right? So we have limit when s approaches 1, take the derivative of this one should be e. Derivative of this one should be e to the s, right? Derivative of this one should be 2s, and derivative of 1 should be 0, right? Now substitute 1 for s, so the answer is e minus e over 2 times 1, right? So the answer is 0. The answer must be D. Now question 15. The function f is continuous and twice differentiable for all s value. And given this one, what is the following limit? Alright, so again, we need to split the top. Limit when s approaches 0, right? Substitute over here, so we have f of 0 minus 1, right? Now f of 0 equals 1, so 1 minus 1 equals 0. Limit when s approaches 0, sine of 0, right? Minus 0, right? So the answer is 0, right? So this one is the indeterminate form, right? So we need to use the last below rule, right? So we have limit when s approaches 0, derivative at the top should be f prime of s minus 1 over the bottom should be, we need to use the chain rule, right? Sine of u prime equals u prime times cosine of u, right? Now u is 2s, right? So we have 2 times cosine of 2s minus derivative of this one is 2s. Derivative of this one should be negative 2, right? We check to see if this one still in the determinate form, right? Substitute 0 for s, so the top should be what? F prime of 0 minus 1 is f prime of 0 equal 1, so it will be 0 again. The bottom, cosine of 0 equal 1, so we have 2 times 1 minus 0 minus 2 equals 0 again, right? So the L'Hospital rule applies again. So we have limit when s approaches 0. Derivative of this one should be the second derivative, right? Derivative of negative 1 is 0 over derivative of this one, use the chain rule, right? It's going to be u prime sine u, right? Don't forget the negative side right here. So it's going to be negative 2 times 2 will be negative 4 sine 2s, right? Minus 2 for this one, right? This one equals 0, right? Now substitute 0 for s, we have f prime of 0. Now substitute 0 for s, so we have f double prime of 0 is actually right here equal to the bottom. We have negative 4 times 0 equals 0 because sine of 0 equals 0. So negative 2 right here. So the answer is negative 1. The answer must be A. Now let's move on to the last one. Find the following limit. Limit of e to the 2t minus 1 over sine t when t approaches 0. Alright, so find the limit on the top right. E to the 2t minus 1 when t approaches 0. It's going to be e to the 0 minus 1 equals 0. Limit of sine t when t approaches 0. Sine of 0 equals 0. So this one is the indeterminate form, right? So we need to use the L'Hospital rule, right? So we need to say L'Hospital rule applies. So it's going to be limit when t approaches 0 of derivative of e to the u prime is going to be u prime times e to the u. Or you can apply the formula right here. E to the a s plus b prime is going to be a times e to the a s plus b, right? So this guy turns out to be 2 e to the 2t over cosine t, right? Substitute 0 for t, the top should be 2, the bottom should be 1. The answer is 2, right? We're going to review Unit 5 of AB, Calculus AB, and BC. Analytical applications of differentiation. Question 1. The graph of the choice differentiable function f is shown in the figure. Which of the following correctly orders f of 2, f prime of 2, and f double prime of 2? Alright, so this is the function f. Now, function f has f of 2 equals 0, right? Now, at s equals 2, we draw the tangent line. We see that the tangent line is going down, which means the slope of the tangent line is negative, right? Remember Christmas tree trick. This one, slope positive, slope negative, slope is 0, and slope is undefined, right? So, f prime of 2 less than 0, right? Right at s equals 2, the function is concave up, right? So it tells us that f double prime of 2 greater than 0, right? So the answer must be C, right? Now let's move on to question 2. A rectangle is bounded by the x and y-axis and the graph of y equals 6 minus x over 2 as in the figure below. What length and width should the rectangle have so that its area is a maximum? Alright. Now, this guy actually the optimization problem. In order to solve this problem, you need two equations. The first one is called secondary equation. The second one is called primary equation. Now, secondary equation is what given. Alright, so given is right here, right? It's going to be y equals 6 minus s over 2. Primary equation is what the question asks you to find, right? So this one is right here. We tell you the primary equation, right? What length and width should a rectangle have so that its area is maximum? So the area is, I'm going to call the length of the rectangle is s, and the width right here is y, right? So a equals s times y, right? Now we're going to substitute 6 minus s over 2 for y into the primary equation. So we're going to have s times 6 minus s over 2, right? And we need to maximize this one, right? So we're going to distribute this one. So a equals 6s minus s squared over 2, right? Now we're going to simplify this one. So I'm going to write this one as negative 1 over 2 s squared plus 3s, right? And then I'm going to take the derivative of this one, right? So it could be negative s plus 3, right? Now I'm going to let the derivative equal 0 to find the critical number, right? So a prime equals 0 is the same thing as negative s plus 3 equal to 0. And then s equals 3. Now let's find the second derivative, right? So it will be f the program equals negative 1 less than 0, right? So from this information, we can conclude that a is maximum when s equals 3, right? So we substitute 3 for s into the function right here to solve for y, right? So we have y equals 6 minus 3 divided by 2. This could be 3.5, right? So finally we have s equals 3, y equals 3.5. Now let's move on to question 3. Let f of s be a strictly increasing function such that f of s less than 0 for all values of s. Let g be a strictly decreasing function such that g of s greater than 0 for all values of s. Now, given h of s equals f of s times g of s, which statement is true? A. H of s greater than 0 and strictly increasing. B. H of s greater than 0 and strictly decreasing. C. H of s less than 0 and strictly increasing. D. H of s less than 0 and strictly decreasing. Alright, so we need to take the first derivative of the function h of s, right? So we have the product rule, right? So it could be f prime of s times g of s plus g prime of s times f of s, right? Now we're going to use the information right here. Since the function f of s is strictly increasing, it tells us that f prime of s greater than 0, right? The function g of s is strictly decreasing. It tells us that g prime of s less than 0, right? So we have f prime of s is positive, right? G of s is positive, right? And g prime of s is negative. F of s is negative, right? So positive times positive is positive, plus negative times negative is going to be positive. The final answer is a positive number, right? So we can conclude that h prime of s is greater than 0, right? It tells us that the function h of s is increasing, right? If we look at this one right here, h of s equals f of s times g of s, but f of s is less than 0 right here, right? And g of s is greater than 0 right here, right? So this one should be negative, right? Which is less than 0, right? So h of s less than 0, we need to eliminate a and b, right? And then h of s should be increasing, right? Less than 0 and increasing, the answer must be C. Now let's move on to question for a right circular cylinder can is to be designed to hold 20 cubic inches of a liquid. The cost for the material for the top and the bottom of the can is 0.02 per square inch. The cost of the material of the side of the can is 0.01 per square inch. Let R represent the radius and H the height of the cylinder. Alright, so we just get the figure right here. The lateral area of a cylinder is A equal to pi R. The area of the circle is pi R square. The volume of the cylinder is pi R square times H. Which of the following represent the correct primary and secondary equation in order to maximize the total cost of manufacturing the can? Alright, so remember the secondary equation is what's given. Alright, so given right here, 22 cubic inches. Right? Now, this guy is the same thing that V equals pi R squared times H equals 22. Now, primary equation is what we need to find, right? The primary equation is the cost, right? The cost equals the lateral surface area, right? So it could be 2 pi R times H plus the area of the base is pi R squared, right? Since we have two bases, so we need to multiply by 2. Now, the cost for the material of the side of the can is 0.01 per square inch, right? So we need to multiply this guy by 0.01, right? And the cost for the material for the top and the bottom of the can is 0.02, right? So we need to multiply this guy by 0.02, right? And this one is the primary equation, right? So we look at the answer choice. It should be C, right? Now let's move on to question 5. The graph of the function y equals h of s is shown above. Which of the following could be the graph of the function h prime of s? Alright, so we look at this one right here. We see the maximum right here, right? This one is the relative maximum. This one is the relative minimum. We will check down to the axis, and this is actually the zero of the function h prime of s, right? So we have 0 right here. Now we look at the answer choice right here. We see that 1, 2, 0, 1, 2, 0, and 1, 2, 0. This guy only have 1, 0 right here, so this one is wrong, right? Now next one, we draw the tangent line right here. So we see that the tangent line goes in this way, which means the slope is positive, right? Remember the Christmas tree trick, positive, negative, 0, undefined, right? So it tells us that the function h prime of s greater than 0, right? And then if h prime of s greater than 0, the function h prime of s should be above the axis, right? So this guy is above, right? This guy is below, right? So we need to eliminate this one, right? Similarly, the slope of the tangent line of this one is positive, right? And then this one should be above the axis, so it could be above the axis right here, right? This one is still above. Now observe that this one is the cubic function, right? Derivative of the cubic function should be the quadratic function, right? So the first derivative graph of this function should be quadratic. The answer must be D. Now let's move on to question 6. The figure below shows the graph f prime, the derivative of the function f for the interval -7 to 7. The graph of f prime has horizontal tangent line s equals -3, right? It's right here. And s equals 2 is going to be right here. S equals 5 is going to be right here, right? And the vertical tangent line s equals 3. Question 8. For all value of s, for s from -7 to 7, at which f attains a relative minimum. Alright, so first we need to find the 0 of the function f prime of s first, right? So we have 1, 0 right here, the second 0 right here, right? And the third 0 right here, right? Now we look at this one right here. The function f prime is above the axis right here, right? So it could be positive. And then negative, right? From here to here, it's positive, right? And from here to here, it's going to be negative. From here to here, is positive, right? And this one is positive. This one is positive, right? So we look at the side chains, right? This is positive, this is negative. This is negative, and this one is positive, right? We know that the function f attains a relative minimum when f prime of s changes sign from negative to positive, right? It's going to be like this. So this one is the minimum, right? If it changes sign from positive to negative like this one is the maximum, right? So we see that the function f attains a relative minimum as s equals -1, right? Because f prime of -1 equals 0 and f prime of s changes sign from negative to positive at s equals -1, right? Now let's move on to question B. Find all value of s for s from -7 to 7 at which f attains a relative maximum, right? So similar to question A, the relative maximum is at s equals -5, right? So we do exactly the same thing. The graph of Ls has a relative maximum at s equals -5 because f prime of -5 equals 0 and f prime of s changes sign from positive to negative at s equals -5, right? Now let's move on to question C. Find all intervals for which f double prime of s less than 0. Now if f double prime of s less than 0, it tells us that the function f prime of s is decreasing, right? Now we just look at the graph to find the interval where f prime of s is decreasing. Now f prime of s is decreasing on this interval -7 to -3, right? And from 2 to 3, right? And from 3 to 5, right? Now we're not gonna count 3 because the graph of f prime has a vertical tangent line here, right? Now let's move on to question D. Find all values of s for s from -7 to 7, where the function fs has a point of inflection. Now, point of inflection means f the prime of s equals to 0, right? So we need to find the value of s where f the prime of s equal to 0, right? So we go back over here. F the prime equal to 0 is right here. Horizontal tangent line right here. -3. 2, right? And 5 right here. Now you need to be careful. The point of inflection occurs when f the program changes sign. So we draw the tangent line right here. We see that the slope of the tangent line is negative. And draw the tangent line right here. The slope of the tangent line is positive, right? So which means the sign of f the program changes from negative to positive. Similarly, this one right here positive, this one right here is negative, right? Now for this one right here, it's gonna be negative, and this one right here is gonna be positive, right? So the sign of f the program changes as s equals -3, 2, and 5, right? Now we need to conclude that the graph of LS has a point of inflection at s equals -3, s equals 2, and s equals 5 because f the program of -3, f the program of 2, and f the program of 5 equal to 0, right? And f the program of s changes sign at each of those values, right? Now let's move on to question 7. The graph of the second derivative of the function fs is shown below, right? So this one is f the prime of s. Which of the following is true? The graph of fs has a point of inflection as s equals -1. So we need to check f the prime of -1 equals 0 or not. And f the prime of s changes sign at s equals -1, right? So we check it. Yes, right here. -1 is the 0 of this function, right? And Add the program change the sign from positive to negative, right? This one is positive because it's above the axis. This one is negative because it's below the axis, right? So one is correct. Now 2. The graph of LS is concave down on the interval negative 1 to 3. So negative 1 to 3 is going to be from here to here, right? Within this interval, f the program of s is less than 0, right? Because it's below the axis, right? So if f the program of s less than 0, the function f of s is concave down, right? So this one true. Now, number 3, the graph of f prime of s is increasing at s equal 2. S equal 2, we have f the program of 2 is less than 0, right? Right here. So it tells us that the function f prime of s is decreasing at s equal 2. So this one is wrong, right? So only 1 and 2 correct. It's going to be C. Now let's move on to question 8. Given the graph of the derivative f prime of s, which of the following would correctly depict possible graph of f of s, right? So we need to reconstruct the function f of s from the function f prime of s, right? So we look at this one right here, we see that the function f prime right here has the vertical asymptote as s equals 3. So we observe that this one has the vertical asymptote as equals 3. This one has the vertical asymptote as equals 3. This one has the vertical asymptote as equals 3, right? This one doesn't have, so the answer C should be wrong, right? Now observe that the function f prime of s is less than 0 because it's below the axis from the interval negative infinity to 3, right? So it tells us that the function f of s must be decreasing on this interval, right? So we look at this one right here, we see that the function f of s is increasing, right? So this one is wrong. Now this one is increasing, so this one is wrong. Only B correct, right? Now let's move on to question 9. Use the graph of f on the right to estimate the value of c that justify the mean value theorem for the interval 0 to 7. Right? So 0 which means A, 7 which means B. The mean value theorem is f prime of c equals f of b minus f of a over b minus a. This one is the slope of the secant line, and this one is the slope of the tangent line. So if these two slopes are equals, two lines must be parallel, right? Now a equals 0 is, and then f of a should be right here. B equals 7, f of b should be right here. We connect these 2 points. And the slope of the secant line is f of b minus f of a over b minus a, right? This one is a, this one is b. Now we look at the answer choice right here: 3.7, 4.3, 5.5, and 7. So we're gonna sketch the tangent line at s equal 3.7, 4.3, 5.5, and 7, right? So it could be something like this, and 4.3 is going to be something like this, and the last one is right here. Now among these 4 values right here, only these values give 2 lines parallels, right? So the value right here should be 3.7, right? So the answer must be A. Now question 10. Engineers are designing a box-shaped aquarium with a square bottom and an open top. The aquarium must hold 500 cubic feet of water. Which of the following represent the correct primary and the secondary equations? In order to find the dimension they should use to create an aquarium with the least amount of glass. Alright, remember the primary equation is what you need to find, right? The secondary equation is what's given, right? So given right here, 500 cubic feet of water, right? So cubic feet tells us that this one is the volume, right? Now the volume of the rectangular prism right here, right? It's gonna be length times width times height, right? So length times width times height is going to be s squared times y. And this guy actually 500, right? And this one is the secondary equation, right? So we check the answer choice right here. This one could be right? This one wrong, right? Because 500 equal this one, so this one is wrong. This one could be right? This one is wrong because this is as y, so wrong. Only C and B. Now we check the primary equation, right? So we need to find the surface error, right? The surface error is the lateral error plus the error of the base, right? Now because this one is open top, so we don't need to count this one, right? We just count the bottom. The bottom should be s squared, right? The lateral surface error is the perimeter of the base times the height, right? So the base is the square, right? So it could be 4 times s and then times the height, which means y. So this one is the surface error and this one is the primary equation, right? So the answer must be B. Now question 11. Identify the open interval on which the function LS is s squared minus s minus 12 is increasing, right? So we just check the derivative of this one. It's going to be 2s minus 1, right? And then we're going to let f prime of s equal to 0. It's the same thing as 2s minus 1 equal to 0, right? And s equals 1/2, right? Now we're going to get the side charts. We're going to put negative infinity right here, positive infinity right here, 1/2 right here, right? We're going to pick the number 1. Substitute number 1 into f prime of s right here, right? So it's going to be 2 times 1 equals 2 minus 1 is going to be 1. So this guy is positive. If this guy is positive, this guy must be negative, right? Now, we need increasing, right? Which means this guy right here, right? F prime of s greater than 0, right? From 1/2 to infinity, right? So the answer must be D. Now question 12. Suppose LS is differentiable everywhere and f of negative 2 equals negative 5. F prime of s less than equal to 5 for all value of s. Use the mean value theorem. What is the largest possible value of f of 8? Now we know that the mean value theorem is given by the formula f prime of c equals f of b minus f of a over b minus 8, right? So f of a is right here, f of b is right here. So we substitute. We have f of 8 minus f of negative 2 over 8 minus negative 2, right? And this one is f prime of c, right? But f prime of c is less than equal to 5 right here, right? So we need this one less than equal to 5, right? So we substitute value f of 8, we don't know, right? So we just rewrite f of 8 minus f of negative 2 equals negative 5. So it turns out to be plus 5 over 8 plus 2 is going to be 10 less than equal to 5, right? Multiply both sides by 10. We have f of 8 less than equal to 50 minus 5 is going to be 45. So f of 8 is at most 45, which means the largest number is 45. The answer must be B. Now let's move on to question 13. For all value of s in the closed interval 2 and 5, right? The function f is a positive first derivative and a negative second derivative, right? So which means f prime of s is greater than 0. F double prime of s is less than 0. Which of the following could be a table of the function f? Alright, so we see that if the function f prime of s greater than 0, which means the function f of s is increasing on the closed interval 2 and 5, right? So we look at the f of s right here, right? If s1 greater than s2, then f of s1 must be greater than f of s2 by definition of increasing function, right? So we see that s is increasing right here. The y value is increasing right here. So a right here could be right. B right here could be right? Because s increasing and y is increasing, right? Now C. FRS decreasing, right? So this one is wrong. D, FRS decreasing, so this one is wrong, right? Now, at double prime of S less than 0, it tells us that f prime of S is decreasing. Now, we need to find the average rate of change for this one right here, right? Now, 9 minus 7 divided by 3 minus 2 is going to be 2, right? Now, 12 minus 9 divided by 4 minus 3 is going to be 3, right? 16 minus 12 divided by 5 minus 4 is going to be 4, right? This one, 11 minus 7 divided by 3 minus 2 is going to be 4. 14 minus 11 divided by 4 minus 3 is going to be 3. 16 minus 14 divided by 5 minus 4 is going to be 2. And observe that f prime of S right here is increasing, right? And f prime of S right here is decreasing, right? So we need f prime of S is decreasing, right? So the answer must be B. Now question 14. On the closed interval 0 to 2 pi, the absolute minimum of f of S is e to the sine S occurs at one of these values, right? So we need to take the derivative, right? So f prime of S equals, we're going to use the formula e to the u prime. It's going to be u prime times e to the u, right? So u in this situation is sine S, right? So sine S prime is going to be cosine S times e to the sine S, right? Let f prime of S equal to 0 is the same thing as cosine S times e to the sine S equal to 0. So this one is the 0 product, right? Cosine S equal to 0 and e to the sine S equal to 0. Cosine S equal to 0 within this interval, S must be equals pi over 2 and 3 pi over 2. Now this one right here has no solution, right? Because e to the sine S right here always greater than 0, right? We're going to use the candidate test because this one is the closed interval, right? Now substitute 0 for S into the original function right here. So we have e to the sine of 0 is going to be e to the 0 equals 1. E to the sine of pi over 2 is going to be e to the first and it's going to be e. This is e to the sine of 3 pi over 2, right? So it could be e to the negative 1, and it's going to be 1 over e. And the last one, e to the sine of 2 pi, right? So it could be e to the 0, and it's going to be 1, right? Now we need the absolute minimum, right? So absolute minimum is 1 over e right here, right? So S equals 3 pi over 2, the answer must be C. Now let's move on to question 15. Let g be the function given by g of s equals s squared times e to the ks, where k is a constant. For what value of k does the function g has critical point s equals 2 over 3, right? So we need to find the first derivative, right? So g prime of s equals, we need to use the product rule, right? U times v prime equals u prime v plus v prime u, right? So it's going to be 2s times e to the ks plus e to the ks. So we have e to the u. It's going to be u prime times e to the u, right? So this one turns out to be k times e to the ks times s squared, right? Now since the function g has a critical point s equals 2 over 3, right? So which means g prime of 2 over 3 right here must be equal to 0, right? So we have 2 times 2 over 3 times e to the 2 over 3k plus k times e to the 2 over 3k times 2 over 3 squared equal to 0, right? And then it's going to be 4 over 3 e to the 2 over 3k plus k times e to the 2 over 3k, right? And this one turned out to be 4 over 9, so I put 4 over 9 right here equal to 0. Now I'm going to factor 4 times e to the 2 over 3k out. So it could be 1/3 plus 1 9k equal to 0, right? This one is the zero product, so each of them must be equal to 0. So we have 4e to the 2/3k equal to 0, and 1/3 plus 1/9k equal to 0. The top right here has no solution because this one always greater than 0, right? Now the bottom, 1/9k equals -1/3, k equals -1/3, divide by 1/9, which means multiply by 9/1, right? So it could be -3, right? So the answer must be A. Now let's move on to question 16. The maximum value of the function f(s) on the closed interval 0 for is. Again, we need to find the critical values, and then we're going to use the candidate test, right? So we have f(prime of s) is 6s squared minus 30s plus 36, right? And then we let 6s squared minus 30s plus 30 equal to 0. Oh, this one is 36. Now divide both sides by 6, so we have s squared minus 5s plus 6 equal to 0. Now we're going to factor this one using s method. Right, this one 6, this one is -5, 5 two number multiply equal 6 add up to -5, which is -2 and -3. So s minus 2 times s minus 3 equal to 0. So s equals 2 and s equals 3. So we have 0 right here. Next one is 2, 3, and 4, right? This one and these two guys right here. Now f of 0 is 0, right? F of 2, substitute over here. You have 2 times 2 cubed minus 15 times 2 squared plus 36 times 2. The answer is 28. Now this one, 2 times 3 cubed minus 15 times 3 squared plus 36 times 3. The answer is 27. And the last one, the answer must be 32. Alright, now we need the maximum, right? So maximum is 32 right here. The answer must be C. Now let's move on to question 17. Consider the function f divided by fs equals s squared over s squared plus 3. Question A. Find any critical numbers if possible. Alright, so in order to find the critical numbers, we need to find the first derivative, right? So we have f prime of s equals. Now we're going to use the quotient rule, right? We have u over v prime. It's going to be u prime v minus v prime u over v squared, right? So it's going to be 2s times s squared plus 3 minus 2s times s squared over s squared plus 3, right? Now distribute this one and simplify. The answer must be 6s over s squared plus 3, right? So we need to have 6s over s squared plus 3 equal to 0. It's the same thing as 6s equal to 0, right? And then s equal to 0, right? Now in this situation, we don't need the denominator equal to 0 because denominator always different from 0, right? So we don't need to find the value of s squared. F prime of s is undefined because denominator right here always positive, right? So the critical number is s equal to 0, right? Alright, so we're gonna sketch the side chart. Negative, infinitive, positive, infinitive, 0 right here. Alright, so we just pick a values 1 right here. We substitute 1 for s into the first derivative right here. Right? It's going to be 6 over 4. It's going to be positive, right? So this interval is positive. If this one positive, this one must be negative. We need to identify the intervals where the function is increasing and decreasing, right? And then we need to say the location of any extrema, right? So this one is decreasing, this one is increasing, and this one is the minimum, right? Now we need to conclude that the function fs is decreasing on the interval negative infinity to 0, right? Because f prime of s is less than 0, right? And the function fs is increasing on the interval 0 to infinity because f prime of s is positive on this interval, right? Now there is a relative minimum at s equals 0 because f prime of s changes sign from negative to positive at s equals 0, right? Now let's move on to question C. Solve f the prime of s equal to 0. So previously we have f prime of s equals 6s over s squared plus 3 altogether square. Oh, so I'm gonna go back over here. I need to fix this one. This one must be square, right? Sorry, I missed this one. Right? Alright, now we need to take the second derivative of this one. So we have f the prime of s equals. Again, we're going to use the quotient rule, right? So u prime is going to be 6 times s squared plus 3 altogether square minus derivative of this one. We're going to use the power rule, right? It's going to be bring 2 to the front, right? And then s squared plus 3 power up 1, right? And then times derivative of the inner function right here, it could be 2s, right? So I'm going to put it over here, it should be 4s times s squared plus 3, right? Over s squared plus 3 altogether square, and then square is going to be power 4, right? Now I'm going to factor s squared plus 3 out. So it's going to be 6s squared plus 18, right? And then if I factor this one out, I have negative 24s squared left, right? Over s squared plus 3 to the 4, right? Now this guy cancel out. So the top is negative 18s squared plus 18 over s squared plus 3 cube, right? Now we just let this one equal to 0 is the same thing as the numerator equal to 0, right? So it's going to be negative 18s squared plus 18 equal to 0, and then s squared equals 1, right? And then s equals plus and minus 1, right? Now let's move on to question D. Construct a chart on number line and use the test for concavity to determine the intervals of concavity and state any points of inflection, right? So we're gonna use the number line. Negative infinity, positive infinity, negative 1, and 1, right? This one is the second derivative. Keep that in mind after the program. Alright, now you're gonna test a number. So I'm gonna pick a number 0 right here, right? I substitute 0 for s into the second derivative to test the sign, right? Substitute this one over here, right? So it's going to be positive, right? So this one positive. If this one positive, this one must be negative. This one must be negative. So that f the program is negative on these two intervals, right? So the function f must be concave downward, right? And this one is concave upward, right? Because f the program is greater than 0 on this interval, right? Now there are points of inflection at s were negative 1 and 1 because f the program of negative 1 and f the program of 1 is 0, and f the program of s changes sign from negative to positive and positive to negative, right? Let's move on to the last question. Construct the graph of f on the coordinate plane below. Alright, so we're gonna go back to the function fs. It could be s squared over s squared plus 3, right? So we have the function f of s equals s squared over s squared plus 3. Now observe that the degree on the numerator and degree on the denominator are the same. So the function has the horizontal asymptote y equals 1, right? Coefficient right here is 1, coefficient right here is 1, so 1 divided by 1. Or you can find limit of the function f of s when s approaches positive and negative infinity equals 1, right? So the horizontal asymptote is right here. Now, the function has the critical number s equal 0 right here, right? And at s equal 0, the function obtains the minimum value, right? And you know that the function has two points of inflection at s equal plus and minus 1, right? So it's going to be something like this. We're going to review unit set of AB, calculus, AB, and BC. Question 1. Alright, consider the function y equals 4s minus s squared. Question A. Sketch the curve y equals 4s minus s squared. Alright, so this one actually the quadratic equation, right? So we're going to rewrite this one as negative s squared plus 4s, right? And you see that a is negative 1 less than 0. The quadratic function is concave double, right? And the axial symmetry is s equals negative b over 2a, right? So it could be negative 4 over 2, negative 1, and it's going to be 2, right? So this one is the axial symmetry. Now we need to find the vertex, right? So substitute 2 for s back to the equation right here, right? So we have y of 2 equals 4, right? So it's going to be right here is the vertex. Now we need to find the 0, right? So we're going to let y equals 0 to solve for s, right? So we have 4s minus s squared equals 0, right? Factor s out, so it could be 4 minus s equals 0, right? So s equals to 0 and s equals to 4, right? So it could be right here and right here. Now we just connect this guy and it's going to be parabola. Now question B. Show the regions that represent the area of the regions enclosed by y equal 4s minus s squared and the x-axis. So it's going to be something like this. Question C. Write the definite interval that represents the area of the region enclosed by y equal 4s minus s squared and the x-axis. So it could be the interval from 0 to 4, right? From here to here. Of 4s minus s squared ds. That's it, right? Now question D. Use the left sums to approximate the interval found in part C on the interval 0 to 4 using 4 subintervals, right? So we need to find the width, right? The width is going to be delta S equals B minus A over N. This one is A, this one is B, and N equals 4. So it's going to be 1, right? The error using the left remain sum is going to be the interval from 0 to 4 of 4s minus s squared ds is. Now we're going to sketch the number line. This one is 0, this one is 4, right? And you have 4 subintervals, right? So this one is 2, this one is 1, and this one is 3, right? Now since you're going to use left remain sum, so you're going to use this guy, this guy, this guy, and this guy only. And delta S is right here. It's going to be 1, right? So you have 4 times 0 minus 0 squared. This one is the height, right? Substitute 0 for S over here to find the height, right? Times the width is going to be 1. We finished the first one. Plus the second height right here. Substitute 1 for s into this expression right here. So you have 4 times 1 minus 1 squared times 1, right? The third one is going to be 4 times 2 minus 2 squared times 1, right? And the last one plus 4 times 3 minus 3 squared altogether times 1, right? Now if you simplify this one, it turns out to be 10. This one is the final answer, right? Question E. Use the midpoint rule to approximate the interval from 0 to set up this guy using 3 subintervals, right? Now we're going to sketch the number line. This one is 0, this one is set. we need 3 subintervals only, right? So we're going to split this one into 3 subintervals, 1, 2, and 3, right? So this guy should be 2, and this guy should be 4, right? And delta S actually 2, right? It's going to be 6 minus 0 divided by 3. It's going to be 2, right? This one is B. This one is A. And N equals 3. Substitute into this formula right here. We get delta S equals 2, right? Now, since this one is the midpoint, right? The midpoint right here, this one should be 1. This one should be 3, and this one should be 5. So we're going to use these values of S right here, right? So we have A midpoint equals the interval from 0 to 6 of 4S minus S squared ds, right? Equals. Now substitute 1 for S into this expression right here to find the height, right? So we have 4 times 1 minus 1 squared, right? Times the width is 2 right here, plus the second one, 4 times 3 minus 3 squared times 2, plus 4 times 5 minus 5 squared times 2, right? Now if you simplify this one, the answer must be 2. Question 2. The rate at which a wheel is turning is given by a differential function or revolutions per minute, right? Because this one is the rate, so you have per minute of time t minutes. The table to the right shows the rate as measured every 3 minutes for 12-minute period. Use a right sum width for intervals to approximate the interval from 0 to 12 of rt dt. Using correct units, specifically explain the meaning of your answer in terms of the motion of the wheel, right? We see that we have 4 subintervals, right? So this one is the first interval, this one is the second interval, this one is the third, and this one is the last one, right? The width is 3, the width is 3, and 3, and 3, right? Now, using the right? So we're gonna pick the right one, which is this guy right here, right? So we have the interval from 0 to 12 r of t dt equals, now length times width, right? So we have r of 3, right? This one is the height, and then times the width is 3 right here. So times 3 plus r of 6 times 3 plus r of 9 times 3 plus r of 12 times 3, right? Now I'm going to factor 3 out, right? So I have 3 times r of 3 equals 5 right here, right? Plus r of 6 equals 5 plus r of 9 equals 10. And the last one, r of 12 equals 20, right? And the final answer must be 120. Now, since this one is the rate, when you take antiderivative of the rate, there's no more per minute. The unit should be revolution only, so keep that in mind. Now, let's move on to question 3. If f of s equals the antiderivative of f of s ds, and given this guy and this guy, we need to find the interval from 5 to 5 of f of s ds. Now keep in mind, when we see the lower limit and upper limit are the same, the answer must be 0, right? Now question B. If you see the lower limit is greater than upper limit, you need to flip the upper and lower bounds, right? So it turns out to be interval from 4 to 5 of f of s ds. Don't forget to put the negative sign in front, right? Now interval from 4 to 5, it turns out to be 14 right here, so the answer must be negative 14, right? Now question C. The interval from 2 to 4 of f of s ds. Now look at this one, it's not given, right? So we have 225 and 425, right? So we can rewrite this one as the integral form 225 of f of s ds equals, we're going to put 4 in the middle right here, right? So we have the integral form 224 of f of s ds plus the integral form 425 of f of s ds, right? Now, the integral form 224 equals this guy right here, subtract this guy, right? So it's going to be the integral form 225 of f of s ds subtract integral form 425 of f of s ds, right? Now we just substitute value. This guy equals 6 and this guy equals 14, right? So the answer is -8, right? Now question D. The integral form 225 of 3 times f of s ds, so it will be 3 times the integral form 225 of f of s ds, right? It's going to be 3 times 6 right here. It's going to be 18, right? Now question E, we can split this guy, right? So it turns out to be the integral form 225 of f of s ds plus the integral form 225 of 2 ds, right? So this guy turns out to be 6 plus, now this guy right here, actually, if you write this one, it's going to be like this. Y equal 2 right here, right? This is from 2 to 5, right? So you have the width right here is 3, right? The height right here is 2, right? So actually this one is the area of the rectangle right here. 2 times 3, right? So it will be 2 times 3 and the answer is 12. Now question 7. So it turns out to be the integral form 7 minus 2 and this is 4 minus 2, right? And then this guy turns out to be f of s ds, right? So it's going to be integral form 2 to 5 of f of s ds, right? And it's going to be 6. Now question 4. The table below lists the measurements of a lot bounded by a stream and 2 straight roads that meet a right angle. So we're going to sketch this one. It's going to be something like this, right? This one is the road and this one is the another road, right? And you have the stream. It's going to be something like this. This one is the stream, right? Now estimate the area of the lot using left endpoint sum square n equals 6, right? So we have this one is A, this one is B. So we see that every single width equals 50, right? Now we have the area using the left remain sum. It's gonna be, we're gonna use this guy, this guy, this guy, this guy, this guy, and this guy, right? N equals 6, and then left remain sum, right? So we have the height is 450 right here, times the width is going to be 50, right? Plus the second height right here, 362 times 50. The width doesn't change, right? Next one, plus 305 times 50, plus 268 times 50, right? Plus 245 times 50, and the last one plus 156 times 50, right? If you use a calculator, the answer must be 89,300 square feet, right? Now question B. Estimate the area of the lot using the right endpoint somewhere n equals 6. Now we do exactly the same thing, right? So the area using the right remain sum, right? So in this situation, we're going to use 50, 100, 150, 200, and 250, right? So we have the height is going to be 362 plus 305 plus 268 plus 245 plus 156, and the last one should be 0, right? And then all together multiply by width. The width is going to be 50, right? Now the answer must be 66,800 square feet. Now let's move on to question C. Estimate the error of the lot using the midpoint rule where n equals 3. So you see that we have 3 subintervals. It's going to be from here to here, right? And this one from here to here. And this one from here to here, right? Now you're going to use the midpoint, so it's going to be this guy right here, right? So you have the error using the midpoint. It's going to be the height is 362 plus 268 plus 156, and then multiply by the width is going to be 100. They are the same width, right? So the answer must be 78,600 square feet. Now let's move on to question 5. The graph of f is given in the figure to the right. Evaluate the interval from 1 to 7 of fs ds. Alright, so we're going to use the geometric figures to calculate the error, right? So it's going to be from 1 to 7 right here, right? And you know that this one is the trapezoid, this one is the another trapezoid, this one is another trapezoid, and the last one should be rectangle, right? So the trapezoid here has the height 1, right? And the base is going to be 1 and 3 right here, right? So you have base 1 is going to be 1 plus base 2 is going to be 3 times the height is going to be 1 divided by 2. Now the second one, the height is 1, right? And the base is 1 and 2, right? So it could be plus 1 plus 2 times 1 divided by 2. The first one, the height is 1. The base is still 1 right here, and the base still 2 right here, right? So this guy and this guy technically the same, right? So I just multiply by 2. And the last one, this one, the length is 7, subtract 4 is going to be 3. The width is going to be 1, right? So it could be plus 3 times 1, right? So if you simplify, the answer must be 8. Now question B. Determine the answer if FRS is translated 2 units upward. Alright, so it's the same thing as the interval from 1 to 7 of f of s plus 2 ds, right? Turns out to be the interval from 1 to 7 of f of s ds plus the interval from 1 to 7 of 2 ds, right? Now this one already calculated above, it's going to be 8, right? Plus, now for this one, it's actually the error of rectangle from 1 to 7, right? So the length is going to be 7 minus 1 is going to be 6. The width is going to be 2, right? So it's going to be 2 times 6, right? And it's going to be 20. Now question 6. Use the trapezoid rule to approximate the following definite interval. Write the answer to the nearest thousands, right? This one is the trapezoid, right? So remember, the area of the trapezoid is base 1 plus base 2 times height divided by 2, right? Now we have 4 subintervals, right? So we have delta s equals b minus a, b equals 5, a equals 1, right? So 5 minus 1 divided by 4 is going to be 1. So delta s equals 1, which is the height. So we have the interval from 1 to 5 of s square root of 2s plus 1 ds equals. Now we're going to draw the number line. This one is 1, this one is 5, right? You have 4 subintervals right here, and each subinterval has the width 1, right? So the first two base is f of 1 and f of 2, right? So you substitute 1 for s right here. It's going to be 1 square root of 2 times 1 plus 1, right? And the base 2 is going to be 2 right here. So it will be 2 square root of 2 times 2 plus 1, right? All together times the height, which is 1, divided by 2, right? The second one is going to be from 2 to 3, right? So you have 2 square root of 2 times 2 plus 1 plus 3 square root of 2 times 3 plus 1 times the height is going to be 1 divided by 2, right? Next one from 3 to 4. So you have plus the first height is going to be 3 square root of 2 times 3 plus 1 plus 4 square root of 2 times 4 plus 1 times the height is going to be 1 divided by 2. And the last one from 4 to 5, right? So it's going to be plus 4 square root of 2 times 4 plus 1 plus 5 square root of 2 times 5 plus 1 times height divided by 2, right? Now, if you simplify this one, the answer should be approximately 33.567. Now let's move on to question 7. For the following measurements, each are in feet made across the leg shown. Use the trapezoid rule to approximate the area of the leg. Write the answer to the nearest square foot. Alright, so the error using the trapezoid rule is going to be base 1 plus base 2 times the height divided by 2. You see that the height always equals 25, right? This one right here, the height always 25. Now we start from here. So we have 0 plus 22, right? Divided by 2. All together, I'm going to multiply by the height outside because we have the same height with just factor 25 out, right? Plus the second one, 22 plus 32 divided by 2, right? The second height right here and the third height right here, right? Now the third height and the fourth height right here, plus 32 plus 30 divided by 2, right? And that's 30 and 42, right? Plus 30 plus 42 divided by 2 plus 42 plus 36 divided by 2. And finally, 36 plus 0, right? Divided by 2, right? Altogether multiplied by 25. If you use a calculator, the answer must be approximately 4,050 square feet. Now question 8. Consider the graph of a continuous function ls given to the right. Approximate the interval from 0 to 10 of ls ds using trapezoid rule with n equals 5, right? So we start from here, we end right here. N equals 5, we use the delta s, it could be b minus a divided by n, right? So it could be 10 minus 0 divided by 5, it could be 2, right? So it could be 2, 4, 6, 8, right? Now this one is a trapezoid, right? So you have the error using the trapezoid is going to be base 1 right here, it's going to be 5, and base 2 right here is going to be 8. 5 plus 8 divided by 2 times the height should be 2, right? So I'm going to put 2 outside, right? I factor 2 outside. Plus, next one, the base is right here and right here. So this is about 9.5, right? So you have 8 plus 9.5 divided by 2. Next one, 9.5 plus 7 right here, right? 9.5 plus 7 divided by 2. Next, 7 plus this guy 1, right? 7 plus 1 divided by 2. And the last one, 1 plus 2, right? 1 plus 2 divided by 2. And altogether multiplied by 2. Now if you use a calculator, it's approximately 57. Question B. Approximate the interval from 0 to 8 using the midpoint rule where n equals 4. So you have delta s is going to be 8 subtract 0 divided by 4 is going to be 2, right? So 0 right here and 8 right here. The width is 2, so it could be 1, 2, 3, and 4, right? So you have 4 subinterval. Now, this one is the midpoint, right? So you have, remember, we're going to use the midpoint rule. Make sure the midpoint should be on the graph. So it could be right here, 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 and here. Now we're going to have the error using the midpoint, right? It's going to be length times width, right? The width always 2, right? The length is going to be the height right here, right? So it could be f of 1, f of 3, f of 5, and f of 7, right? So it could be f of 1 equals 6 right here, right? So you have 6 times 2 plus f of 3 equals 9 right here. 9 times 2 plus f of 5 equals 9. So it's going to be 9 times 2 plus f of 7 equals 4 right here. So 4 times 2 equals 56. Now let's move on to question C. Approximate the interval from 0 to 10 of FSDS using the left side rectangles with n equals 5. So we have delta S equals 10 minus 0 divided by 5 is going to be 2, right? So we have, alright, so the error using the left side rectangles is going to be length times width, right? The length is 5 right here. Times width is going to be 2, right? Next one, the length right here is going to be 8. Plus 8 times 2 plus the next one right here, so it could be 9.5 times 2 plus this guy right here, it should be 7. 7 times 2, and this guy right here, it should be 1, right? 1 times 2 equals 61. Now let's move on to question 9. Due to a bad storm on a low-lying road, a large circular puddle of a water forms. The area of the puddle increases as a storm intensifies. The radius of the puddle in feet is modeled by the twice differentiable function R of t, where t is measured in minutes. For t from 0 to 15, the graph of R is concave up. The table below gives selected values of the rate of change of prime of t of the radius of the puddle over the time interval from 0 to 15. The radius of the puddle is 7 feet when t equals 6. Now question 8. Use a right remain sum with 6 intervals, which means n equals 6. Alright, so since n equals 6, right, so we need to find the width. It's going to be 3, right? This one should be 3. This guy should be 2. This guy should be 3. This guy should be 1. And this guy should be 3, right? Now the right remains sum, which means we're going to pick the height. It's going to be right here, right? So we have the error using the right remain sum. It's going to be length times width, right? So we have 2.3 times 3 right here, plus 3.4 times 3, plus 4.3 times 2, plus 4.9 times 3, plus 5 times 1 right here, and the last one plus 6.2 times 3. So the answer must be 54 feet. Question B. We do exactly the same thing, but we're going to use the left remain sum, right? So we have A left equals. So left remain sum, we're going to use this guy right here. 1.2, 2.3, 3.4, 4.3, 4.9, and 5 only, right? So we have 1.2 times 3 plus 2.3 times 3 plus 3.4 times 2 plus 4.3 times 3 plus 4.9 times 1 plus 5.0 times 3. And the answer is 50.1 feet. Now, question C, we do exactly the same thing, but we're going to use the trapezoidal sum, right? So remember, trapezoid error is going to be base 1 plus base 2 times height divided by 2, right? Now, we go back over here. Base 1 is 1.2 and 2.3, and the height should be 3, right? Base 1 is 2.3 and 3.4, and the height should be 3, right? The next trapezoid, base 1 is 3.4 and base 2 is 4.3, the height should be 2. Next one, base 1 is 4.3, base 2 is 4.9, and the height should be 3, right? Next, base 1 is 4.9, base 2 is 5, and the height should be 1. The last one, base 1 is 5, base 2 is 6.2, and the height should be 3, right? And the answer is approximately 57.05 feet. Now let's move on to question D. Use a midpoint sum with 3 intervals. Alright, so we're gonna go back over here. The midpoint sum with 3 intervals. So the first interval is going to be from 0 to 6. Second interval should be from 6 to 11. And the third one should be from 11 to 15. Now the width is going to be 6. This guy should be 5. And this guy should be 4. Right? Now since we use the midpoint, so we need to use this guy right here. 2.3, 4.3, and 5. Right? So it will be length times width. That's it. Right? 2.3 times 6, 4.3 times 5, and 5 times 4. And the answer is 55.3 feet. Now question E. Use correct units explain the meaning of this interval in the context of the problem situation. So we need to say that the interval from 0 to 15 r prime of t dt gives the total amount, the radius of the pedal changes from time t equals 0 to t equals 15 minutes. Now let's move on to the second part of the unit set. We need to find the integration of logarithmic, exponential, and inverse trigonometric functions. Now question 1, we need to find the antiderivative of 1 over s ln s squared ds. Alright, so we look at this one, we have two expressions right here. The first one is going to be ln s squared, and the second one is going to be s, right? This one is more complicated, so we're going to let this one be u, right? So we'll let u be ln s squared, right? And we use the formula derivative of ln of u. It's going to be u prime over u, right? So we have du equals 2s over s squared ds, right? And then if we simplify, it's going to be 2 over s ds, right? So we look at this one, we see that 1 over s right here, we need to multiply the top and bottom by 2, like that, right? So we're going to replace 2 over s ds with du, right? So this turns out to be the antiderivative of du over u. Don't forget to multiply by 1/2, right? Then the antiderivative of du over u is going to be ln absolute value of u, right? Plus c. Don't forget 1/2 here. Now we need to replace u with s, right? Because we need to go back to the original one, right? So it can be 1/2 ln of absolute value of u, but u equal this one right here, right? So it can be ln of s squared plus c, right? Now question 2. We see that we have two expressions right here, 1 and 2 right here. This one more complicated, right? So we're going to let this one be u, right? So we have u equals 1 plus cube root of s, right? And this guy turns out to be u equals 1 plus s power 1/3, right? Now we take the derivative, we use the power rule, right? So du equals 1 over 3 s power -2/3, right? ds. And this guy turns out to be 3 du equals ds over s power 2/3, right? So we replace this guy right here with 3 du, right? So this guy turns out to be the antiderivative of 3 du over u, right? So it could be 3 ln absolute value of u plus c, and it's going to be 3 ln of absolute value of 1 plus q root of s plus c, right? Now question 3, we look at this one right here, we see that the variable is theta, this one is phi theta, right? So we let this one be u, right? So we have u equals phi theta, and then du equals phi d theta, right? Now we only have d theta right here, so we need to multiply by phi and divide by phi, right? Like that. So this guy turns out to be 1 over phi antiderivative of cosecant u du, right? And it's going to be negative 1 over phi natural log of absolute value of cosecant u plus cotangent u plus c using the formula, right? Now we substitute as best, so it can be negative 1 over phi ln absolute value of cosecant phi theta plus cotangent phi theta plus c, right? Now let's move on to question 4. We look at this one, we see that there's a two expression right here, right? This one more complicated, we let u be this one, right? So we have u equals ln cosine s, and then du is going to be, we're going to use the formula ln of u prime is going to be u prime over u, right? So u prime, which means cosine prime, is going to be negative sine s over cosine s ds, right? But negative sine s over cosine s is going to be negative tangent s ds, right? So I'm going to multiply both sides by negative 1, so it can be negative du equal positive this one, right? So this guy turns out to be 2 times negative du, right? So I put du right here and I put negative side right here, right? And I have u right here because u equal this one, right? So this guy turns out to be negative 2 times u squared over 2 plus c, right? And negative 2 and 2 cancel out, right? So I have negative u squared, but u equal this one, so it can be ln square of cosine s plus c, right? Now question 5. This one is the rational function where degree on the numerator is greater than degree on the denominator. We need to do long division, right? We're going to take s cubed minus 3s divided by s squared minus 1, right? So s cubed divided by s squared is going to be s multiplied by is going to be s cubed minus s subtract is going to be negative 2s, right? So this guy can be written as antiderivative of s minus 2s over s squared minus 1 ds, right? Now antiderivative of s is going to be s squared over 2, right? If you take derivative of the bottom and you get the top, so we have the formula antiderivative of u prime over u du. It's going to be ln absolute value of the bottom, which means u right here plus c, right? So this one turns out to be negative ln absolute value of s squared minus 1 plus c, right? Now question 6, we have two expressions right here, right? So we let u be this one right here, right? So u equals square root of s, and then du equals 1 over 2 square root of s ds, right? So I don't have 1/2 right here, right? So I multiply both sides by 2. So this guy turns out to be 2 du equals ds over square root of s, right? Now this guy turns out to be 2 antiderivative of e to the u du, right? And it could be 2 e to the u plus c, and it could be 2 e to the square root of s plus c, right? Now let's move on to question 7. We're gonna let u be s squared, then du equals 2s ds, right? Then we divide both sides by 2, we have 1/2 du equals s ds, right? Substitute back over here, so we have this guy turns out to be 1/2 antiderivative of 3 to the u du, right? Now we're going to use the formula, the antiderivative of a to the s. This one is not power rule, so be careful. It's going to be a to the s over ln of a plus c. So keep that in mind. So this guy turns out to be 1/2 3 to the u over ln 3 plus c. Substitute s squared for u, so it could be 1 over 2 ln 3 times 3 to the s squared plus c, right? Now question 8, we're gonna rewrite this one as antiderivative of ds over square root of 1 minus 2s all together square, keep that in mind. So we're gonna apply the formula antiderivative of 1 over square root of 1 minus u square du. It's gonna be sine u plus c, right? Now we're gonna let u be 2s, right? Then du equals 2 ds, right? So right here I just multiply the top and bottom by 2, right? So I substitute over here. I have 1/2 antiderivative of du over square root of 1 minus u square. Now I can apply the formula right here, so it could be 1/2 sine u, but u equals 2s, right? So I have 2s plus c. This one is the final answer, right? Now question 9. This guy actually antiderivative of ds over s square root of 9s squared minus 1, right? We can rewrite this one as antiderivative of ds over s square root of 3s all together square, keep in mind, right? So then we can apply the formula antiderivative of du over u square root of u square minus 1 equals a secant of absolute value of u plus c, right? So we let u be 3s, right? Then du equals 3 ds, right? So right here I just multiply the top and bottom by 3. So this guy turns out to be antiderivative of 3ds actually du, right? Now 3 and s right here actually u, right? Square root of u square minus 1. Now I apply the formula right here, so it could be secant of absolute value of u, but u equals 3s right here, so absolute value of 3s plus c, right? Now let's move on to question 10. Observe that if you take derivative of the numerator, it's actually denominator, right? So I'm gonna let u equals tangent s, and then du equals ds over 1 plus s squared, right? This guy right here turns out to be antiderivative of u du, right? And it's gonna be u squared over 2 plus c. And substitute tangent s for u, so it could be tangent square of s over 2 plus c, right? Now let's move on to question 11. Observe that the numerator has the degree less than the denominator, right? So we need to separate this guy. So this guy turns out to be antiderivative of s over s squared plus 9 ds plus antiderivative of 3 over s squared plus 9 ds, right? Now for the first one, observe that if you take derivative of this one, it turns out to be 2s ds, right? So the top is going to be s ds. I just multiply by 2 and I divide by 2, right? So then I'm going to apply the formula antiderivative of u prime over u du. It's going to be ln absolute value of the bottom plus c, right? So this guy turns out to be 1/2. I rewrite it, right? ln absolute value of s squared plus 9, right? Now the second one right here plus I rewrite 3. Now for this one right here, remember we have the formula antiderivative of ds over s squared plus a squared equals 1 over a tangent s over a plus c, right? A in this relation is 3 because 3 squared equals 9, right? So it could be 3 times 1 over 3. Remember this 3 right here and right here are the same, right? And 1 over 3 right here comes from the formula right here, right? Because this one is 3 square, right? Tangent of S over 3 plus C, right? Now, if I simplify, it's going to be 1/2 ln absolute value of S squared plus 9 plus tangent S over 3 plus C, right? Now, question 12. Look at the bottom. We need to make this one as a complete square, right? So I just rewrite this one as antiderivative of ds over square root of negative, factor negative out. So it could be s squared minus 2s minus 8, right? Now I need to make this one as a complete square, right? So this guy turns out to be antiderivative of ds over square root of negative of s square minus 2s. I'm going to add and subtract 1, right? So I'm going to add 1 right here and subtract 1 and subtract 8. It could be 9, right? So it's going to be antiderivative of ds over square root of negative s minus 1 altogether square minus 9, right? And it's going to be antiderivative of ds over square root of 9 minus s minus 1 altogether square, right? Antiderivative of du over square root of a square minus u square. It's going to be a sine of u over a plus c, right? Now u in this rotation is s minus 1, right? And a in this rotation is 3, right? Because 3 squared equals 9, right? So this guy turns out to be a sine of s minus 1 over 3 plus c. Now let's move on to question 13. Observe that if you take derivative of the denominator right here, it's going to be becomes the numerator right here, right? So we're going to let u equals square root of s squared minus 2s, right? And then I'm going to square both sides, so I have u squared equals s squared minus 2s, right? Take derivative both sides, so it could be 2u du equals 2s minus 2 ds, right? Now I'm going to factor 2 out and divide both sides by 2, so I have u du equals s minus 1 ds, right? Now this guy turns out to be antiderivative of u du over u, right? So it could be antiderivative of du, and this could be u plus c, but u equal this one, so it could be square root of s squared minus 2s plus c, right? Now question 14. Again, I'm going to let u be the bottom, right? So u equals s squared plus 5. And then du equals 2s ds, right? I'm going to divide both sides by 2. So I have 1/2 du equals s ds, right? So I go back over here. This guy turns out to be, I bring 3 to the front, right? Antiderivative of s ds, actually 1/2 du, right? So it could be divided by 2 right here, I put du right here, right? The bottom actually u, right? So it could be 3/2 ln absolute value of u plus c. But u equals s squared plus 5, so it could be 3/2 ln absolute value of s squared plus 5 plus c, right? Now question 15. Observe that if you take derivative of the bottom, it turns out to be 2s plus 2, right? On the top, I don't have 2s plus 2, so I need to add and subtract 2, like that, right? So this guy turns out to be 2s plus 2 minus 7, right? So I just separate this in row. It's going to be antiderivative of 2s plus 2 over s squared plus 2s plus 2 ds, right? Minus antiderivative of 7 over s squared plus 2s plus 2 ds, right? Now, we have the formula u prime over u. It's actually ln absolute value of u plus c, right? So this guy turns out to be ln absolute value of s squared plus 2s plus 2, right? Now this guy right here, we just make a complete square, right? So negative 7 antiderivative of ds over, I'm going to separate 2s 1 plus 1, right? So I have s plus 1 all together square plus 1, right? And then this guy turns out to be ln absolute value of s squared plus 2s plus 2, right? Minus 7 tangent of s plus 1 and then c, right? Now question 16. Observe that if you take derivative of the bottom, it turns out to be 2s plus 6, right? The top is just s plus 3. So if you double this one, right, it turns out to be 2s plus 6. And then when you multiply the top by 2, you need to divide by 2, right? So this guy turns out to be 1/2 antiderivative of 2s plus 6 over s squared plus 6s ds, right? And then it's going to be 1/2 ln of s squared plus 6s. Now since this one is the definite interval from 1 to 3, right? So we put 1 right here, we put 3 right here, and this one should be evaluated from 1 to 3, right? So it's going to be 1/2 ln of, substitute 3 for s, it could be 9 plus 18, it could be 27. Subtract ln of 1 plus 6, it could be 7, right? Now if we simplify this one further, it could be 1/2 ln of 27 divided by 7, right? Observe that this angle is theta over 3. This one is theta, right? So we're gonna let u equals theta over 3. And then du equals 1/3 d theta, right? And then 3 du equals theta. Now we need to change the lower bound and upper bound to the new lower bound and upper bound, right? Since we have u equals theta over 3, but theta is from 0 to pi, then u should be from, substitute 0 for theta over here, it's going to be 0. Substitute pi over here, it's going to be pi over 3, right? So the new interval becomes the interval from 0 to pi over 3, tangent of u times 3 du, right? So I put du right here, put 3 in the front, right? Now antiderivative of tangent u is going to be negative ln absolute value of cosine u, evaluated from 0 to pi over 3. And don't forget to multiply by 3, right? So it's going to be negative 3 times ln of cosine pi over 3 minus ln of absolute value of cosine 0, right? So it could be negative 3. Cosine of pi over 3 is, now cosine of pi over 3 equals 1/2, right? So it could be ln 1/2 minus ln 1, right? Because cosine of 0 equals 1. Negative 3 ln 1/2, right? Because ln 1 equals 0, right? So this guy turns out to be negative 3 ln 1 minus ln 2, right? ln 1 equals 0, right? So the answer should be 3 ln 2. Now let's move on to question 18. We need to use complete square formula, right? So this guy turns out to be the integral from negative 3 to negative 1 ds over s squared plus 6s divided by 2 and square. It's going to be 9, right? So plus 9 and subtract 9. 13 subtract 9, it should be 4, right? So this guy turns out to be the integral from negative 3 to negative 1 ds over s plus 3 all together square for the first 3 terms right here, right? Plus 4, right? Now remember we have the formula antiderivative of du over u squared plus a squared. It's going to be 1 over a tangent u over a plus c, right? Now this one actually u, and a right here is 2, right? Because 2 squared equals 4, right? So this guy turns out to be 1 over 2 tangent of s plus 3 over 2, evaluated from negative 3 to negative 1, right? So we substitute over here, so we have 1/2 attention of, substitute -1 over here, so it should be 1, right? Minus, substitute -3 over here, it should be attention of 0, right? So it's going to be 1/2. Attention of 1 is actually pi over 4, right? Attention of 0 is going to be 0. So the answer is pi over 8. Now question 19. Find the error of the region bounded by the graphs of the equation y equals s plus 5 over s, x equals 1, s equals 5, and y equals to 0, right? So we're gonna graph this one. It's actually something like this. So the error is the integral from 1 to 5 of s plus 5 over s ds, right? Now we just separate this one, so it could be the integral from 1 to 5. Divide this guy by s, so it could be 1 ds plus the integral from 1 to 5 of 5 over s ds, right? So this guy turns out to be s evaluated from 1 to 5 plus bring 5 to the front, and then it's going to be ln absolute value of s evaluated from 1 to 5, right? So this guy turns out to be 5 minus 1, and this guy plus 5 times ln of 5 minus ln of 1, right? So it could be 4 plus 5 ln 5, right? Now question 20. Find the error bounded by the function ls equals 2 power of negative s, the x-axis, s equals -2, and s equals 1. Now, if you graph this one, it's going to be something like this. Alright, so the error is the integral from -2 to 1 of 2 to the negative s ds, right? Now, we're going to use u substitution, right? So we're going to let u be negative s, and then du equals negative ds, right? And then we need to change the lower limit and upper limit, right? So we have s equals -2 and s equals 1. We have u equals 2 and u equals -1, right? A becomes negative integral from 2 to -1 of 2 to the u du, right? So it could be integral from -1 to 2 to the u du, right? So it could be 2 to the u over ln of 2, evaluated from -1 to 2, right? 1 over ln of 2 times 2 squared minus 2 power of -1, right? So it could be 1 over ln of 2, 4 minus 1/2, right? So it's going to be 7 over 2 times ln 2. Now let's move on to question 21. Let LS be E plus ln s over s squared. Find the average rate of change of this one from s over 1 to s over e. Average rate of change is given by the formula f of b minus f of a over b minus a, right? Now this one is a, this one is b, right? So we have f of e minus f of 1 over e minus 1, right? So it could be, now f of e substitutes e for s, so we have e plus ln e over e squared minus e plus ln 1 over 1 squared divided by e minus 1, right? So ln e equals 1, so we have e plus 1 over e squared minus ln 1 equals 0, right? So it could be e left over e minus 1. Now we're going to multiply the top bottom by e squared, right? So we have e plus 1 minus e cubed over e squared times e minus 1, right? 22. Find the error of the region by the graphs of the equation LS y equals 0, s for this one, and s for this one, right? So we have the integral form 2 over root 2 of 1 over s square root of s squared minus 1 ds, right? This one actually secant of s, right? Evaluated from 2 over root 2 to 2, right? So it could be secant of 2 minus secant of 2 over root 2, right? Now we're going to simplify, so it could be secant of 2 minus secant of root 2, right? Now question 23. Find the area of the regions by the graphs of the equation f of s, y equals 0, s equals 0, and s equals 1. Alright, so it's going to be the integral from 0 to 1, right here, right? Of 1 over 1 plus s squared ds, right? So it could be tangent of s evaluated from 0 to 1. It's going to be tangent of 1 minus tangent of 0, right? So it could be pi over 4, right? Now question B. Find the average value of the function f on the interval 0 to 1. So we have the formula. This one you're going to learn in unit 8. It's going to be the average value 1 over b minus a times the integral from a to b of f of s ds, right? So we substitute over there, we have 1 over 1 minus 0, right? The integral from 0 to 1 of 1 over 1 plus s squared ds. Now this guy right here we calculated above is actually pi over 4, right? So it's going to be 1 times pi over 4. It's going to be pi over 4, right? Now question C. For what value of s does f of s take on the average value? The average value is pi over 4 right here. And f of s is given by 1 over 1 plus s squared, right? So we just equate this one and this one, right? So we have 1 over 1 plus s squared equals pi over 4, right? Now cross multiply, so this guy turns out to be pi times 1 plus s squared equals 4, right? And 1 plus s squared equals 4 over pi. Then s squared equals 4 over pi minus 1. Take square root both sides, so we have s equals plus and minus square root of 4 over pi minus 1. Since s belongs to the interval 0 to 1, which means s positive, so you only pick s equals square root of 4 over pi minus 1. That's it. Now let's move on to question 24. The number of planktons growing in a controlled research vat is changing at the rate dp over dt equals 1250 over 3 plus 0.15 t. And this guy actually differential equation, right? We're going to learn in unit 7. Where t is measured in weeks. If the initial amount of the plankton t equals 0 is 2400, write an equation that will give the population of the plankton at a time t and use it to find the number of plankton to the nearest whole number after 2 months, which means t equals 8. Because 1 month has 4 weeks, right? So 2 months has 8 weeks, right? T right here is measured in weeks, right? Now we have dB over dt equal this one, right? We just separate the variable, right? So we're going to multiply both sides by dt. So we have dp equals 1250 over 3 plus 0.15 t dt, right? Now we're going to take antiderivative both sides, right? So this guy turns out to be p equals antiderivative of 1250 dt over 3 plus 0.15 t, right? Now we're going to use the u substitution, so we're going to let u be 3 plus 0.15 t. So du equals 0.15 dt, right? So then dt equals du divided by 0.15, right? So I substitute over here, I have p equals 1250 divided by 0.15, the antiderivative of du over u, right? So it's going to be 1250 divided by 0.15 ln absolute value of u plus c. But u is equal to this one, right? So I have p equals 1250 over 0.15 ln absolute value of 3 plus 0.15 t plus c. Now we're going to use the initial condition right here to solve for c, right? So we have p right here equals 2400, right? So 2400 equals 1250 divided by 0.15 ln of 3 plus c, right? C equals 2400 subtract 1250 divided by 0.15 ln 3, right? So finally, the formula P is 1250 over 0.15 ln of absolute value of 3 plus 0.15 t plus 2400 minus 1250 over 0.15 ln 3, right? Now we need to calculate value of p when t equals 8. So I have p of 8 equals 1250 over 0.15 ln of 3 plus 0.15 times 8, right? Plus 2400 minus 1250 over 0.15 ln 3, right? Now I'm going to bring up the calculator. I'm going to add calculator, so I'm going to hit the button right here, put a fraction 1250 over 0.15, right, times ln of 3 plus 0.15 times 8 plus 2400 minus fraction 1250 divided by 0.15 times control and button natural log right here 3, and then press enter. The answer is 5203.94, right? But the question wants you to round to the nearest whole number, right? So it could be this number right here, right? So it's going to be 5024, right? Now let's move on to the next one. Let FRS be an antiderivative of FRS, and f of 1 equals 2. Use the fundamental theorem of calculus and your calculator to find f of 5. Alright, so we have the integral form 1 right here, 2, 5. Alright, so remember the fundamental theorem of calculus is given by the integral form a to b of f of s ds equals capital F of b minus capital F of a, right? Now, this one right. Now, in this situation, a is 1 and b is 5, right? So we have the antiderivative. So we have the integral form 1 to 5 of 2 ln s all together square over e to the s equals f of 5 minus f of 1, right? So we have f of 5 is f of 1 plus the integral from 1 to 5 2 ln s all together square over e to the s, right? So we're gonna bring up the calculator. So we're gonna press f of 1 is 2, right? So you have 2 plus, put in right here, pick the interval right here, from 1 to 5 of, pick the fraction right here, 2 ln of s, altogether square, over e to the s ds, and then press enter. The answer is 2.348, right? Now let's move on to the last one, the review problems from the 2014 AP Calculus AB exams. The following the function f is defined on the closed interval and it's good time to stop. Now let's move on to the AP Calculus AB review problems. This question appeared on the 2014 AP Calculus AB exam. Question 1. The function f is defined on the closed interval -5, 4. The graph of the function f consists of 3 line segments and shown in the figure above. Let the function g be the function defined by g of s equals the integral from -3 to s f of t dt. Find g of 3. Alright, so substitute 3 for s into this equation. We have the integral from -3 to 3 f of t dt, right? So we look at the graph right here, -3 is right here, and 3 is right here. Alright, so actually the error of this triangle right here, subtract the error of this triangle right here, right? So the error of this triangle, we have the base is 5, right? The height is 1, 2, 3, 4, right? So 4 times 5 divided by 2, right? And this one, the base is 1, the height is 2, right? Subtract 1 times 2 divided by 2, right? So it could be 10 subtract 1 is going to be 9, right? Question B. On what open intervals contained in -5 to 4 is the graph of G both increasing and concave up? Increasing means G prime of S greater than 0, right? And concave up, which means G double prime of S greater than 0, right? So we're gonna take the derivative of this guy right here, right? So we have G prime of S is, we just substitute S for T into this expression. It's actually f of S, right? And we need this one to be greater than 0, right? So we look at the graph right here. This is the function f, right? So if it's greater than 0, it should be above the x-axis, right? So it should be from -5 to this one right here, 2, right? This guy right here above the axis. So we have the interval from -5 to 2, right? Now, next one, G double prime of S is actually f prime of S greater than 0, right? So we look at this interval, f prime of S greater than 0, which means the slope of the line should be positive, right? So we only have this one has a positive slope right here, right? It means from -3 to 0, right? So we have the interval from -3 to 0, right? Now we need to combine this guy and this guy. The final solution should be -3, 0, right? Question C. The function h of s is defined by h of s equals g of s over phi s. We need to find h prime of 3. So we need to take derivative of this one using the quotient rule, right? So h prime of s equals g prime of s times phi s minus phi times g of s over phi s altogether square, right? So then h prime of 3 is g prime of 3 times 5 times 3 is going to be 15, so I put 15 in the front, right? Minus 5 times g of 3, right? Over 5 times 3 equals 15 square is going to be 225, right? So we're going to find the value g prime of 3. Go back over here. G prime of s equals f of s, right? So g prime of 3 is actually f of 3, right? Minus 5 g of 3. G of 3 we just calculate right here, right? It's going to be 9. So times 9 over 225, right? So it could be 15 times f of 3. We look at the graph right here. 3 right here, f of 3 equals -2, right? So it could be minus 2 minus 45 over 225, right? So the answer is -75 over 225, and then it's going to be -1/3, right? Now let's move on to the next question. This one appears on the AP Calculus AP exam 2012. So question 2. Let f be the continuous function defined on the closed interval -4, 3, whose graph consisting of 3 line segments and a semicircle center at the origin is given above. Let g be the function given by g of s equals this one. Find the values of g of 2 and g of -2, right? So we have g of 2 equals the interval from 1 to 2 f of t dt, right? Now the interval from 1 to 2, this one is 1, this one is 2, right? So the error it should be this right triangle, right? But this right triangle is below the axis, so it should be negative, right? So it's going to be negative base times height divided by 2. The base right here is 1. The height right here is 1/2, right? So we have 1 times 1/2 divided by 2, right? So it's going to be -1/4, right? Now g of -2 equals the interval from 1 to -2 of f of t dt, right? So we need to switch this one, so it could be negative interval from -2 to 1 of f of t dt, right? Now -2 to 1, this is -2, 1 right here, right? So it could be the error of the right triangle right here. Subtract the error of the semicircle right here, right? So this one, the base is 1, the height is 1, 2, and 3, right? And this one, the radius is 1, right? So we have minus 1 times 3 divided by 2. And the radius of the semicircle is going to be 1, right? So it could be minus pi r, which means 1 squared divided by 2, right? So it's going to be -3.5 plus pi over 2, and it's going to be pi minus 3 divided by 2. Now question B. We need to find g prime of -3. Alright, so the formula is right here. We have g prime of s actually f of s, right? So g prime of -3 actually f of -3. F of -3 is gonna be right here. It's 2, right? equals 2. Now G double prime of negative 3 is f prime of negative 3, right? F prime of negative 3, which means the slope of the line at s equals negative 3, the slope is positive, right? So we calculate the slope of this one is going to be rise over run. Rise is 1, 2, run is 1, 2, right? And the slope is positive. It's actually 2 divided by 2, and it's going to be 1, right? Now question C. Find the x-coordinate of each point at which the graph of G has a horizontal tangent line. So if the graph of G has a horizontal tangent line, which means G prime of S must be equal to 0, right? Now we know that G prime of S actually f of S, right? And this guy must be equal to 0, right? So we look at this one right here. It's actually this guy right here and this guy right here, right? This guy is negative 1 and this guy is 1, right? So we have s equals negative 1, s equals 1, right? Then we have g of s has a horizontal tangent line, right? Now for each of these points, determine whether g has a relative minimum, relative maximum, or neither a minimum nor a maximum at the point. Now remember, the function g has a relative minimum when g prime changes sign from negative to positive at this critical number, right? Similarly, relative maximum when g prime changes sign from positive to negative at these critical numbers, right? Now we're going to check s equals negative 1. So s equals negative 1 right here. We see that the function f of s changes sign from positive to negative, which means going up and then going down. This one is the maximum, right? Similarly, 1 right here, the function does not change sign, right? It's in negative and it's still negative, right? So we only have s equals negative 1. The function g of s has a relative maximum because the function g prime of s changes sign from positive to negative at s equals negative 1, right? At s equals 1, g prime of s does not change sign, right? So the function g of s does not have the relative maximum nor minimum at this point. Now let's move on to the last question, question D. For the interval from negative 4 to 3, find all values of s for which the graph of g has a point of inflection. Alright, so g has a point of inflection when g double prime of s equals 0 or undefined, right? And g double prime of s must change sign, right? So we have g double prime of s is actually f prime of s, right? Now we need to find the value of s where f prime of s equals to 0, right? Now f prime of s is actually the slope of the tangent line of the function f of s, right? So we look at this one is the function f of s, right? Now the slope of the tangent line is equal to 0 when s equals to 0 right here, right? S equal to 0, we have the horizontal tangent line. Remember the Christmas tree trick. The line is going up, the slope is positive. Line is going down, slope is negative. Line is horizontal, the slope is 0. Line is vertical, the slope is undefined. Right? Now we have other two values where the function f is not differentiable, right? It's going to be the sharp term right here. This guy and this guy right here, right? So right here, s equals negative 2. And right here, s equals to 1, right? So we have this guy equals 0 when s equals to 0, right? And f-prime of s is undefined when s equals -2 and s equal to 1, right? Now we need to check where g double prime of s changes sign, right? So look at this one right here. The line is going up right here, the slope is positive. The line is going down, the slope is negative. So this one changes sign, right? So s equal -2 works. This guy negative and this guy positive, right? So this one works, right? Now this one positive and this one is negative. So this one works, right? So finally, you have the function g has a point of inflection at s equals -2, s equals 0, and s equals 1 because g double prime of s equals f prime of s changes sign at those values. We're going to review unit set topic 6.11 to 6.14 of AB calculus BC. Actually, 6.14 belongs to AB calculus AB, but I'm going to include it in this review. Now, question 1. We need to find the antiderivative of this one. So basically, we're going to let u equals the one inside right here. And then du equals -2 over -2s, right? ds. And then du equals ds over s, right? So we substitute back over here, we see that ds over s right here, actually du, right? So this guy turns out to be antiderivative of du over square root of 25. Again, we write this one as 5 squared minus u squared, right? So I'm going to apply the formula antiderivative of du over square root of a squared minus u squared equals sine inverse of u over a plus c, right? Now remember, if you have antiderivative of ds over square root of 1 minus s squared, it's going to be sine inverse of s plus c, right? So this guy turns out to be sine of u over 5 plus c. But u equals this guy right here, so the final answer must be sine of ln -2s over 5 plus c. Now let's move on to question 2. So observe that if you take the derivative of s to the 4, you get s cubed, right? So then we're going to use u substitution, right? So let u be 5s to the 4 minus 2, right? So du equals 20s cubed, right? ds. Now 80 right here can be written as 4 times 20, right? So I'm going to multiply both sides by 4. So I have 4 du equals 80 s cubed ds, right? So this guy turns out to be antiderivative of 80 s cubed ds, actually 4 du's, right? So I put 4 in the front and put du right here. And then this guy becomes 3 raised to the u, right? So this guy turns out to be 4 times 3 to the u over ln 3 plus c, right? And then it's going to be 4 times 3, u equals this guy right here, right? So it could be 5s to the 4 minus 2 over ln 3 plus c. This one is the final answer. Now question 3. Observe that if you let u be the one inside parentheses and you take the derivative, it's going to be s cubed right here, right? So I'm going to let u be 4s to the 4 minus 2. Then du equals 16s cubed ds, right? So this guy becomes 16s cubed ds, actually du, right? So I put du right here. Now I have secant square of u, right? Now antiderivative of secant square is going to be tangent, right? So it could be tangent u plus c. But u equals this one, so it could be tangent of 4s to the 4 minus 2 plus c. This one is the final answer. Now question 4, similar to question 1. Alright, so I'm going to leave this one for you to practice. I just give you the answer. Right? So the answer must be 2 ln absolute value of -1 plus ln for s plus c. Now question 5. Observe that you have degree on the numerator is bigger than denominator. You need to do long division, right? Alright, so I have s to the 5th minus 5s to the 4 plus 9s minus 42 divided by s minus 5, right? S to the 5th divided by this one, s to the 4, right? Multiply this one back, it's going to be s to the 5th minus 5s to the 4, right? And when you subtract, it's going to be 0, right? Now I'm going to bring 9s minus 42 down. So 9 divided by 1 by here is going to be plus 9, right? Multiply this one back, it's going to be 9s minus 45. Subtract them, it's going to be 3 left. So this guy can be written as antiderivative of this guy right here, right? S to the 4 plus 9 ds plus antiderivative of the remainder is 3 right here over s minus 5. Now antiderivative of this one is going to be s to the 5th over 5 plus 9s plus 3 times natural log of absolute value of s minus 5 plus c. This one is the final answer. Now question 6, observe that if you let u be this one, when you take the derivative, it's going to be the top, right? So let u be 5s squared plus 5. Then du equals 10s ds, right? So I'm going to multiply both sides by 5. So it will be 5 du equals 50s ds, right? So this guy becomes antiderivative of 5 du over secant u, right? 1 over secant is going to be cosine, right? So it will be antiderivative of 5 cosine u du, right? And then antiderivative of cosine could be sine, right? So it could be 5 sine u plus c, right? And u equal this one right here. So we have 5 sine of 5s squared plus 5 plus c, right? Now let's move on to question 7. Now remember we have a formula antiderivative of du over a squared plus u squared equals 1 over a tangent of u over a plus c, right? So we need to make this guy the same thing as this guy, right? So this guy can be written as antiderivative of the bottom actually 4 squared 5s squared altogether squared, right? Now the top, observe that 10s ds actually derivative of 5s squared, right? Now this guy and this guy the same thing. Look, this is u, this is u. So you can apply this formula directly, right? So this guy turns out to be 1 over 4 tangent of 5s squared over 4 plus c, right? Now let's move on to question 8. Observe that the degree on the numerator is less than the degree on the denominator. We need to do partial fraction decomposition, right? And observe that this guy is the repeating linear factor. So this guy can be written as 2s squared plus s over s minus 2 times s plus 1 squared equals. First, it could be a over s minus 2, the first factor right here, plus the second factor is going to be b over linear factor right here, s plus 1 only. And because this one is repeating, you see that? So you need to add c over s plus 1 altogether square. Alright, keep in mind, don't expand this one. If you expand this one, you're going to get stuck. Now I need to rewrite this one as the common denominator, right? So the common denominator is s minus 2 times s plus 1 altogether square. This one right here, right? Now I'm going to multiply the top bottom by s plus 1 squared, right? So this guy turns out to be 8 times s plus 1 altogether squared, right? Plus the second one right here, I mix s minus 2 and s plus 1, right? So b times s minus 2 times s plus 1, right? And the first one right here, I mix s minus 2, right? So c times s minus 2, right? So I have a times s plus 1 squared plus b times s minus 2 times s plus 1 plus c times s minus 2 equals 2s squared plus s, right? Now I need to solve for a, b, and c. Now in order to solve for a, I'm going to let s equals 2, right? So that b and c disappear, right? So I'm going to let s equals 2. And then substitute 2 for s over here. So I have 2 plus 1 could be 3 squared, it could be 9. So I have 9a. Substitute 2 for s over here, it's gone, right? Equals the right hand side. Substitute 2 over here, I have 8 plus 2, it could be 10. So a equals 10 over 9, right? Now to solve for c, I'm going to let s equals negative 1, right? So then this guy and this guy gone, right? So substitute negative 1 for s into this expression right here. I have negative 3c equals 1, right? Then c equals negative 1, right? Now to solve for b, you can let s be any number, right? So I'm going to let s be 0, right? Substitute over here, I solve for b, right? So I have a plus, substitute 0 for s over here, you have negative 2b, right? Substitute 0 for s over here, you have negative 2c equals 0, right? Now a equals 10 over 9, so I have 10 over 9 minus 2 times b minus 2 times c, but c equals negative 1 third, so it will be plus 2 third equals 0, right? So negative 2b equals negative 16 over 9 right here, right? Then b equals 8 over 9, right? So finally, this guy becomes a equals 10 over 9 times 1 over s minus 2, right? b equals a over 9, so it will be plus 8 over 9 times 1 over s plus 1, right? And c equals negative 1 third, right? So minus 1 third times 1 over s plus 1 altogether squared, right? And then this guy right here becomes entire derivative of this one, right? ds. Remember you have entire derivative of d yield over yield is to be ln absolute value of yield plus c, right? Now observe that ds right here is the same thing as ds minus 2, right? So this one can be written as 10 over 9 entire derivative of d of s minus 2 over s minus 2, right? This guy and this guy must be the same, so that you're going to apply the formula right here, right? So observe that if I take derivative of ds minus 2 is actually ds, right? Because derivative of 2 equals 0, right? Same thing, I have plus 8 over 9 entire derivative of ds plus 1 over s plus 1, right? And then this guy right here is going to be negative 1 third. S plus 1 square, I print it to the top so I can apply the power rule, right? So it will be s plus 1 altogether to the negative 2, right? And then ds is the same thing as ds plus 1, right? So I put d of s plus 1, right? So this guy turns out to be 10 over 9 times ln of absolute value of s minus 2 plus 8 over 9 ln absolute value of s plus 1 minus 1 over 3. This guy, you're going to add 1 over negative 2 plus 1. It's going to be negative 1. So this guy becomes positive, right? S plus 1 on the bottom, right? And then add C. This one is the final answer. Observe that you have the square root of cosine. This is more complicated than this guy, right? So I'm gonna rewrite this one as antiderivative of square root of cosine as times sine to the fifth, right? So I just write sine as ds right here. I have sine to the 4 left, right? So sine to the 4, which means sine square altogether square, right? So this guy is the same thing as antiderivative of square root of cosine s times sine square is going to be 1 minus cosine square of s, right? Altogether square times sine s ds, right? So I'm gonna let u be square root of cosine s, right? I'm gonna square both sides, so I have u squared equals cosine s. Now I'm gonna take the derivative of both sides, so I have 2u du equals negative sine s ds, right? So I'm going to multiply both sides by negative 1, so this guy becomes positive, this guy becomes negative, right? So I'm substitute back over here, so I have antiderivative of this guy, actually u, right? And then this guy right here, actually negative 2u du, right? So I have negative 2u squared, right? And then I have this guy left right here. It's going to be 1 minus, look, u squared equal cosine s. Now this is cosine squared, it's going to be u to the 4, right? Like this. And then square du, right? So I'm going to expand this one, so it's going to be bring negative 2 to the front, so negative 2 antiderivative of u squared times u, so from this square formula to expand this one, it's going to be 1 minus 2u to the 4 plus u to the 8 du, right? So I just distribute this one, so it can be negative antiderivative of u squared minus 2u to the 6 plus u to the 10 du, right? Now take antiderivative of this one, so I have negative 2 times u cubed over 3 minus 2 over 7 u to the 7, right? Plus 1 over 11 u to the 11 plus c. Now I substitute square root cosine for u, right? So finally I have the answer. It's going to be negative 2 times 1/3 square root of cosine s altogether cubed, right? Minus 2 over 7 square root of cosine s altogether to the 7, right? Plus 1 over 11 square root of cosine s to the 11, right? And then plus c. So it's going to be negative 2 times 1/3. Now square root of cosine s cubed can be written as square root of cosine s squared times square root of cosine s, right? So it's going to be cosine s square root of cosine s like that, right? Same thing, negative 2 over 7 square root of cosine s to the 6, right? So it will be cosine s cubed, right? Times square root of cosine s, right? Similarly, at 1 over 11 cosine s to the 5th, right? Times square root of cosine s altogether plus c, right? This one is the final answer. Now let's move on to question 10. For question 10 right here, we need to apply the formula 1 plus tangent square of u equals secant square of u, and derivative of secant u is going to be u prime times tangent u times secant u, right? So this one can be written as antiderivative of tangent square of 2s secant square of 2s altogether square times tangent 2s secant 2s, right? ds. So now we're gonna let u be secant of 2s, then du equals 2 tangent 2s secant 2s ds, right? Now we substitute over here, so we have this guy becomes antiderivative of tangent square of 2s, actually secant square of 2s subtract 1, right? But secant of 2s for u, so I have u square subtract 1, right? Times, and let u equals secant 2s, so this guy becomes u to the 4, right? And then this guy right here actually du divided by 2, right? So I have du over here, and it's going to be 1/2 right here, right? Now I just distribute this one, so it's going to be 1/2 antiderivative of u to the 6 minus u to the 4 du, right? And then it's going to be 1/2 times 1 over 7 u to the 7, right? Minus 1 over 5 u to the 5th, right? Plus c. Substitute secant to s for u, so the final answer must be 1 over 14 secant 2s to the 7, right? Minus 1 over 10 secant 2s to the plus c. This one is the final answer. Now let's move on to question 11. Question 11 similar to question 10 but easier. Alright, so we're gonna let u be the one inside parentheses right here. So we have u equals secant of negative 3s, right? Then du equals negative 3 tangent negative 3s times secant of negative 3s ds, right? So then I will multiply both sides by 3. So this guy turns out to be 3, and this guy turns out to be negative 9, right? Because I have negative 9 right here. So this guy becomes antiderivative of this guy right here, and this guy right here. Actually, 3 du, right? So I put 3 right here and du right here, right? And I have this one secant square left right here, right? And this guy right here actually u, right? So we go like this, right? So this guy becomes 3 tangent u plus c. But u equals this one, so it will be 3 tangent of secant of negative 3s plus c, right? Now let's move on to question 12. I don't have enough space, so I'm right over here. Now you have the exponent and you have the trig. So we're going to use the acronym L, I, A, T, E, right? The best way to memorize this formula is lion 8. Okay? So we're going to check. L stands for log, we don't have log. I stands for inverse trig, we don't have it. A stands for algebraic, we don't have it. T stands for trig, we have trig right here, right? So we're going to let u be cosine s, right? Then du equals negative sine s ds, right? Now dv equals e to the negative s ds, right? Then v equals negative 1/2 e to the negative 2s ds. Remember, you have antiderivative e to the as plus b ds is going to be 1 over a e to the as plus b plus c. Similarly, you have sine of a s plus b ds is going to be negative 1 over a cosine of a s plus b plus c, right? Or cosine, you do exactly the same thing, right? So remember, I have the antiderivative of u dv equals u times 3 minus antiderivative of v du, right? So keep that in mind. Now I use this formula, so this guy turns out to be this y I call this m, right? So I have m equals u times 3, u is this one, v this guy, right? So I have negative 1/2 e to the negative 2s cosine s, right? Minus antiderivative of v du. V is right here and du right here. So you have negative side right here, and negative side right here becomes positive, right? And I bring 1/2 to the front, so I have negative 1/2 e to the negative 2s sine s ds, right? Now, for this one right here, I'm going to use the integration by part again, right? So, I'm going to let u be sine s, and then du equals cosine s ds, right? dv equals e to the negative 2s ds, and then v equals negative 1/2 e to the negative 2s, right? So, m becomes negative 1/2 e to the negative 2s cosine s minus 1/2, I rewrite it, multiplied by u times 3. U is right here and v is right here, right? So I have negative 1/2 e to the negative 2s sine s minus v du, v right here and du right here. So negative and negative right here becomes positive, right? 1/2 antiderivative of e to the negative 2s cosine s ds, right? Now m equals negative 1/2 e to the negative 2s cosine s. Distribute negative 1/2, so it will be plus 1 over 4 e to the negative 2s sine s, right? Minus 1 over 4, right? E to the negative 2s cosine s ds, right? Now this guy actually m, right? So for this one right here becomes negative 1 over 4 m, right? So I'm going to add 1 over 4 m both sides, right? So it's going to be 5 over 4 m equals negative 1/2 e to the negative 2s cosine s plus 1 over 4 e to the negative 2s sine s, right? So I'm going to multiply both sides by 4 over 5. So m equals negative 2 over 5 e to the negative 2s cosine s, right? Plus 1 over 5 e to the negative 2s sine s. Now you can factor 1 over 5 e to the negative 2s out. So it will be e to the negative 2s over 5, right? It's going to be sine s minus 2 cosine s plus c. This one is the final answer. Alright, now we have a shortcut formula to do this one faster. Alright, so better you memorize the formula to do the MCQ. It helps you a lot. Alright, so it will have antiderivative of e to the as sine bs ds. It's going to be e to the as over a squared plus b squared times a sine bs minus b cosine bs plus c. Alright, second one, antiderivative of e to the as cosine bs ds equals e to the as over a squared plus b squared times a cosine bs plus b sine bs plus c. Alright, to memorize this formula, you look at the pattern. Look, this guy always the same, right? It doesn't matter sine bs or cosine bs, right? Now this is sine bs, and then you have a right here times sine bs first. The second one should be b times cosine bs, so you just swap the negative side. Now this one right here, cosine bs, so you have a right here times cosine bs first. And the second one, because this is cosine, so it will be positive, right? b times sine bs right here, right? So keep in mind, if cosine ps right here, then you should have the positive pairs right here, right? If sine ps right here, and then you should have negative side right here, squared plus 2 minus, right? Now I'm going to give you two examples for you to practice. You're going to use integration by parts and you're going to use direct formula right here. Make sure they both have the same answer, right? Now, number one, antiderivative of e to the negative 2s sine 3s ds. The second one, antiderivative of e to the 3s cosine 2s ds. Now let's move on to question 13. So we need to use the trig identity to do this problem. We have sine 2s equals 2 sine s cosine s, right? And then you have sine 4s. Remember this angle right here always double this angle. You see that? So sine 4s should be 2 sine 2s cosine 2s, right? So I'm going to replace this one right here with sine 4s, so it will be antiderivative of sine 4s ds, right? So it will be negative 1 over 4 cosine 4s plus c. This one is the final answer. Remember, we have antiderivative of sine as plus b equals negative 1 over a cosine of as plus b plus c, right? Similarly, you have cosine of as plus b ds equals 1 over a sine of as plus b plus c. So keep that in mind. Now let's move on to question 14. We just manipulate this one a little bit. So it could be antiderivative of 20, 25. Cotangent s, it could be cosine s over sine s, right? And then cosecant s, it could be 1 over sine s, right? ds. So this guy turns out to be 20, 25 antiderivative of cosine s over sine square of s ds, right? So we're going to use u substitution, right? So we're going to let u be sine s, and then du equals cosine s ds, right? So we substitute back over here, so we have this guy becomes 20, 25 antiderivative of du over u squared, right? So it's going to be 20, 25. Now we're going to use the power rule, so it should be negative 1 over u plus c, right? So it could be 20, 25 over u equals sine s, right? So it could be sine s right here. Don't forget negative side right here and plus c. This one is the final answer. Another way to do this problem is to memorize the formula. Remember, we have derivative of cosecant s is going to be negative cosecant s cotangent s plus c, right? So then antiderivative of cosecant s cotangent s ds is going to be negative cosecant s, right? So this guy right here becomes 20, 25 antiderivative of cotangent s cosecant s ds, and it's going to be negative 20, 25 cosecant s plus c. And then it's going to be negative 20, 25 over sine s plus c, right? Now, question 15, observe that this one actually the product rule. So if you have f of s times g of s altogether prime, right? So it could be f prime of s times g of s plus g prime of s times f of s, right? Now, if you take antiderivative of this one, it's go back to this one, right? So the final answer must be f of s times g of s plus c, right? This one is the trig substitution. Observe that this guy is the even power and this one is the odd power. You need to write the one with the odd power in terms of the one with the even power. So keep that in mind. So this guy turns out to be the integral form pi over 4 to pi over 2, right? Sine square of s times cosine square of s times cosine s ds, right? Now cosine square of s, I can rewrite this one as 1 minus sine square of s, right? Now I'm going to do u substitution, right? So I have u equals sine s, right? So then du equals cosine s ds, right? Now I need to change the upper bound and lower bounds, right? So u equals, because u equals sine s, right? So s over pi over 4, it could be sine of pi over 4, it could be root 2 over 2. Sine of pi over 2, it could be 1, right? So this guy right here becomes the integral form root 2 over 2, right? 2, 1. Now sine square of s actually u square, right? Times 1 minus u square, right? And this one right here actually du, right? So it's going to be u square minus u to the 4 du, right? So it's going to be 1/3 u cubed minus 1/5 u to the 5th, evaluated from root 2 over 2 to 1, right? So you substitute 1 for u. So it's going to be 1 over 3 minus 1 over 5. Subtract. Substitute root 2 over 2 for u. So it could be 1/3 times root 2 over 2 cubed, right? Minus 1/5 times root 2 over 2 to the 5th, right? Now we're going to simplify this one. So the first one right here becomes 2 over 15 minus the second one right here. Root 2 cubed, it could be 2 root 2, right? Divide by 8. So it could be root 2 over 4, right? And then have 3 right here. So it could be root 2 over 12, right? Similarly, it's going to be 4 root 2 over 32. So it could be root 2 over 8. So it could be minus root 2 over 40. Now to simplify this one further, we need to find the LCD of 15, 12, and 40, actually 120. So the final answer must be 16 minus 7 root 2 over 120. Now let's move on to question 17. Alright, we're going to use the half angle formula, right? Remember we have cosine square of s equals 1 plus cosine 2s over 2. Sine square of s equals 1 minus cosine 2s over 2. Alright, so this guy turns out to be the integral from 0 to pi of 1 minus cosine of 2s over 2 ds, right? So it could be integral from 0 to pi of 1/2 minus 1/2 cosine 2s ds, right? So it's going to be 1/2 s minus 1 over 4 sine 2s evaluated from 0 to pi, right? So it's going to be, substitute pi for s, so it could be pi over 2 minus sine pi equals 0, right? So the final answer should be pi over 2. Now let's move on to question 18. Now we're going to use acronym L, I, A, T, E, right? We're going to check the log. Yes, the log right here. So we'll let u equals ln 2s, and then du equals 2 over 2s ds, right? Or du equals 1 over s ds, right? Then dv should be the remaining one, which means 1 over s squared ds, right? So v equals negative 1 over s, right? So this guy right here, I call this m, right? So m becomes, remember, the antiderivative of u dv equals u times v minus antiderivative of v du, right? So we have u times v, u is right here and v is right here, right? So you have negative ln 2s over s, right? Evaluated from 1 to 3 minus the integral from 1 to 3 of v du. V right here and du is right here, right? So if you multiply this one, it's going to be negative 1 over s squared ds, right? So we're going to calculate this one, so it's going to be negative parenthesis ln of 6, right, over 3 minus ln of 2, right? And this minus and minus right here becomes positive, right? So plus. Now entire derivative of 1 over s squared is going to be negative 1 over s, right? So this guy becomes negative side again, right? So the be 1 over s evaluated from 1 to 3, right? So this guy becomes ln 2 minus ln 6 over 3. Substitute 3 for s, it could be negative 1/3. Substitute 1 for s, so it could be negative 1, and then negative it becomes positive, right? So final answer should be, I'm going to simplify this guy, right? So it should be 2/3 plus ln 2 minus 1/3 ln 6. This one is the final answer. Now let's move on to question 19. A tank contains 120 gallons of oil at time t equals 0 hours. So suppose you have a tank right here. At t equals 0, you already have 120 gallons, right? And then you're going to pump additional oils, right? So make sure you're going to add 120, right? Now, question A, we need to use the trapezoidal rule with 4 subintervals to estimate the number of gallons of oil in the tank at t equals 12 hours, right here, right? So 4 subintervals, so you have the first interval right here, second, third, and 4. The width right here is 3, 2, 4, and 3, right? And this one is the trapezoidal rule. Remember, the area of the trapezoid is given by the formula base 1 plus base 2 times the height divided by 2. So I'm going to multiply by 1/2, right? So the approximation is 120. This one is initial value plus 1/2. Base 1 is right here, base 2 is right here, and this one is the height. So keep that in mind. So it could be 8.9 plus 6.8 times 3, right? Plus 1/2. Base 1 is 6.8, base 2 is 6.4, right? Times the height right here is 2, right? Plus 1/2. Base 1 is 6.4, base 2 is 5.9 times the height right here 4, right? Plus the last one, 1/2. Base 1 is 5.9 plus base 2 is 5.7 times the height 3, right? And if you use a calculator, your answer should be approximately 198.75 gallons. Now question B. A model for the rate at which oil is being pumped into the tank is given by the function g of t equal this one, where g of t is measured in gallons per hour and t measured in hours. Use the model to find the number of gallons of oil in the tank at t equals 12 hours. So you're going to use the fundamental theorem of calculus, right? Remember the integral from a to b of f of s ds equals capital F of b minus capital F of a, right? So then you have f of b equals capital F of a plus the integral from a to b of f of s ds right here, right? This one is the initial value. Initial value is given by 120 right here, right? So you have 120 plus the integral from 0 to 12, right? This one is 12 of g of t, but g of t is 3 plus 10 over 1 plus ln of t plus 2 dt, right? Now we're going to bring up the calculator. The answer must be 197.975, right? Now let's move on to question 20. Water is flowing into the tank over 24-hour period. The rate at which water is flowing into the tank at various times is measured and the result given in the table below, where RT is measured in gallons per hour and T is measured in hours. The tank contains 150 gallons of water when T equals 0. So this one is the initial values, right? Now, question A. Estimate the number of gallons of water that have flowed into the tank over the 24-hour interval by using the midpoint remaining sum with 3 subintervals and values from the table. Alright, so 3 subintervals is going to be from here to here, from here to here, and the last one from here to here. Now, the width right here is 8. This one, 8, and this one is 8, right? Now, you have the midpoint remaining sum, right? So the midpoint should be this guy right here, this guy, and this guy, right? So the value is 150 plus, right? Because this one initial value, right? You need to add this guy. Now you need to calculate the area of the rectangle using the midpoint, right? So rectangle right here, the midpoint right here, right? The height of the midpoint is 8.8 right here. And the width right here is actually 8, right? This one is 8.8, right? So you have 8 times 8.8 plus the second one, 8 times 9.2. And the first one, 8 times 8.1, right? Now we're going to print up the calculator. So we have 150 plus, I'm going to factor 8 out. So I multiply by 8.8 plus 9.2 plus 8.1, right? And then press enter. The answer is 358.8 gallons, right? Now question B. Estimate the number of gallons of water in the tank at the end of 24 hours by using the trapezoidal sum with 3 subintervals and values from the table. Now this one similar to the question 19a, right? So I'm going to leave this one for you to practice, right? The answer for this question is 354.4 gallons. Now question C. A model for this function is given by Wt equals 1 over 75 600 plus 20t minus t squared. Use the model to find the number of gallons of water in the tank at the end of 24 hours. Question C, similar to question 19b. I'm going to leave this one for you to practice. The answer should be 357.36 gallons. Question D. Use the model given in the question C to find the average rate of water flow over the 24-hour period, right? So remember, we have the average formula. It's going to be 1 over B minus A integral from A to B of F of S ds. This one is the formula, right? So we're going to use this one. So we look at the table right here. It should be from 0 to 24, right? So it will be 1 over 24 minus 0 integral from 0 to 24, right? The model in question C is right here, right? So it will be, the answer is 8.64, right? Now, since this one is the average rate, so it should be gallon per hour, right? Now let's move on to question E. dt equals 2 times e to the 0.08 t models the rate at which water is draining out of the tank. At what time does the total water in the tank begin to decrease? So the total water in the tank at time t is modeled by A of T equals initial water plus the amount of water pumped into the tank, which means the interval from 0 to T of R of S ds minus the amount of water draining at time t. So it can be interval from 0 to T of D of S ds, right? So we're going to substitute initial values is 150, right? Plus the interval from 0 to T. R of S, actually, this value here, W S ds minus the interval from 0 to T of ds equal this one right here, right? Now to find the times when the total water in the tank begin to decrease, we need to take derivative both sides, right? So we have a prime of T equals derivative of this one is 0. Derivative of this one you just substitute T for S, right? So it could be W of T minus substitute T for S over here, right? So it could be D of T, right? Now you need to find the critical number of this one. So basically you need to let this one equal to 0. It's the same thing as W of T equals D of T, right? So you solve for T, right? So we're going to use the calculator to solve this problem, right? So I'm going to print up the calculator. You're going to go to the home screen graph right here. We're going to put the first graph, WT is going to be right here, right? So F1 of S is going to be right. And then you just press enter. You have the graph right here. Now go ahead, adjust the window. Make sure you go to the number 4 right here, window zoom, and choose zoom fit, and it's going to be right here. Alright. The second one, you're going to go back to the graph, so you're going to hit tab right here. F2 of S is 2 times e to the 0.08 S, right? And you press enter, it's going to be right here. Within the interval 0 to 24, you see that one intersection right here. So you're going to press menu, analyze graph, intersection, this one right here, right? So go to the left, go to the right. The answer is 18. So you have T equals about 18 hours, right? Now if you use decimals, it's going to give you more accurate values. It's going to be right here. The answer is 18.043, right? So you have T equals 18.043 hours, right? Now you're going to substitute 18.043 for T into original one right here, right? To solve for this one, right? So I'm going to print up the calculator. Go to the home screen and calculate, right? So it's going to be 150 plus ds. Then you're going to subtract. I'm going to copy this one. Interval from 0 to 18.043 of 2 times e to the 0.08 s. Then the s right here, press enter. The answer is 230.763 gallons, right? Now let's move on to question 21. A hot cup of coffee is taken into a classroom and set on a desk to cool. The table shows the range of T's at which temperature of the coffee is dropping at various times over an 8-minute period, where R T is measured in degrees Fahrenheit per minute, and T is measured in minutes. When T equals 0, the temperature of the coffee is 113 degrees, right? Now, question A. Estimate the temperature of the coffee at T equals 8 minutes by using the lab remain sum with 3 subintervals and values from the table, right? So n right here equals 3, right? Now the first interval right here, the second interval is right here, and the third interval right here, right? So you have the width is going to be 3. This one should be 2, and this one should be 3, right? Now the lab remains sum, so I have the temperatures. Initial one is 113, right? So you have 113 right here, and it's getting cooler, right? You need to subtract, right? So subtract what? The left remains sum, right? So the left should be this guy, and this guy. Multiply by the width right here. So you have 5.5 times 3, right? Plus 2.7 times 2, right? Plus 1.6 times 3, right? And then if you use a calculator, it's approximately 86.3 Fahrenheit, right? Now question B. Use values from the table to estimate the average rate of change of RTs over 8 minutes. So you have average rate of change. Remember, you need to know the difference between average rate of change and average value of the function. Okay, they are completely different. So it can be F of B, which means R of B minus R of A over B minus A, right? Now R of B is going to be 8 minutes, right? Right here. 0.8 subtract 5.5, right? Over 8 subtract 0, right? So you have 0.8 subtract 5.5 over 8 subtract 0, right? So this one is approximately negative 0.588 degree, right? Per minute squared, right? Because the rate unit is degree per minute right here. So when you calculate the average rate of change, it's going to be per minute one more time. So it will be minute squared. Keep that in mind. Question C. A model for the rate at which the temperature of the coffee is dropping is given by the function right here, where y of t is measured in degrees Fahrenheit per minute and t is measured in minutes. Use the model to find the temperature of the coffee at t equals 8 minutes, right? So the temperatures at 8 minutes equals initial value is 113, right? And then you need to subtract the interval from 0 to 8 of this one right here. 7 e to the negative 0.3 t dt, right? So you're gonna print up the calculator. It's gonna be 113 minus, I'm gonna copy this one down over here. Press enter. The answer is 91.783, right? Now question D. Use the model given in part B to find the average rate at which the temperatures of the coffees is dropping over the 8-minute period. Alright, so again, as I told you, the average rate change is different from the average rate, right? Remember. So the average rate is given by the formula 1 over b minus 8 integral from a to b f of s ds, right? So this guy is the same thing as 1 over 8 minute periods, which means 8 minus 0, the integral from 0 to 8, right? The temperatures of the coffees is dropping, so we're going to use the model right here. So I'm going to bring up the calculator, right? So I copy this one down over here, and then I need to multiply this one by 1 over 8, right? And then press enter. The answer is 2.652 degree per minute, right? So it could be 2.652 degree per minute. Now let's move on to question 22. This question comes from AB Calculus Exam 2001. AB Calculus AB question 2 and BC question 2. This question is similar to the question 19, 20, and 21 we just did, right? So I'm going to leave this one for you to practice. I'm going to give you the answer key for this one, right? So question over here, the answer is about 25.1 degree per day, right? Now question B, we need to find the average values, right? So we're gonna apply the formula 1 over B minus A, the integral from A to B of f of s ds, right? Similar to the one we just did above, right? So I'm gonna give you the answer for this question. It's about 25.757 degree per day, right? Now question 23. This comes from AB Calculus Exam 2004, AB question 3 and BC question 3. This one similar to the previous one, right? I just give you the answer key and then I'm going to leave this one for you to practice. The answer is 229 miles. The answer is 5.916 miles per minute. Now let's move on to question 24. This question comes from AP Calculus Exam 2005, AP 3 and BC 3. A metal wire of a length 8 centimeters is heated at one end. The table below gives selected values of the temperature T of S in degrees Celsius of the wire as centimeters from the heated end. Alright, estimate T prime of 7. Alright, so basically we need to use the mean value theorem, right? So we have the mean value theorem is given by formula f prime of C equals f of B minus f of A over B minus A, where C is between A and B, right? So look at this one, 7 right here between 6 and 8, right? So I have T prime of 7 equals T of 8 minus T of 6 over 8 minus 6, right? T of 8 equals 55 minus T of 6 equals 62 divided by 8 minus 6, right? If you simplify, it's going to be about negative 3.5 degree per centimeter, right? Question B. Write an integral expression in terms of T of S for the average temperature of the wire. Alright, so the formula is going to be, now estimate the average temperatures of the wire using the trapezoidal sum with 4 subintervals. Alright, so basically we have 1 over 8 times. Now the trapezoidal sum 4 subinterval, right? So we go back over here. This one is the first interval, right? Second interval, third interval, and fourth interval right here, right? So we have the height right here is going to be 1. The height right here is 4. The height right here is 1. The height right here is 2, right? Base 1 is 100. Base 2 is 93, right? And base 1 is 93. Base 2 is 70, right? Base 1 is 70. Base 2 is 62, right? And base 1 is 62 and base 2 is 55, right? So we have base 1 is 100 plus base 2 is 93, right? Times the height should be 1, right? Divided by 2. Plus base 1 is 93, base 2 is 70, times the height is going to be 4, divided by 2, right? Plus base 1 is going to be 70, base 2 is 62, times the height is going to be 1 divided by 2. And the last one, base 1 is going to be 62, base 2 is going to be 55, times the height is going to be 2 and divided by 2, right? Now if you use a calculator, the answer must be about 75.688 degrees, right? Question C. Find the integral from 0 to 8 of T prime of S ds and indicate units of measure. Explain the meaning of this one in terms of the temperature of the wire. Alright, so basically we're going to use the fundamental theorem of calculus, right? So the integral from 0 to 8 of T prime of S ds equals T of 8 minus T of 0, right? And then T of 8 equals 55 right here. T of 0 equals 100, right? So you have 55 minus 100 is going to be negative 45 degrees, right? Now you're going to explain the meaning of negative 45 degrees. So you're going to say the temperature drops 45 degrees from the heated end of the Y to the other end of the Y, right? Now let's move on to the last question, question 25. AB calculus exam 20 OSIT AB4 and BC4. A rocket A has a positive velocity v of t after being launched upward from an initial height of 0 feet at time t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval 0 to 80 seconds as shown in the table below. Question A. Using correct units, explain the meaning of this guy in terms of the rocket flight. Alright, so look at the velocity right here. It's going to be positive, right? So you need to say, since the velocity is positive, then you represent the distance in feet traveled by the rocket A from t equals 10 to t equals 70 seconds, right? Because when you take antiderivative of velocity function, it becomes the distance function, right? So keep that in mind. Now question B. Rocket B is launched upward with an acceleration at t equals 3 over square root t plus 1 feet per second per second. At time t equals seconds, the initial height of the rocket is 0 feet and initial velocity is 2 feet per second. Which of the two rockets is traveling faster at t equals 80 seconds? So let VB of t be the velocity of the rocket B at time t, right? So does that mean VB of t is actually the antiderivative of 3 over square root t plus 1 dt, right? Because the derivative of velocity function is actually the acceleration function, right? So when you take antiderivative of this one, it's going to go back to the vt, right? So keep that in mind. So in order to calculate the antiderivative of this one, we just rewrite this one as 3 times antiderivative of t plus 1 power up negative 1 half, right? And then dt right here should be d of t plus 1, right? Because d of t plus 1 is exactly the same thing as this d, right? So then this guy becomes 3 times t plus 1 power up negative 1 half plus 1 is going to be 1 half, right? Over 1 half plus c, right? So then multiply the top bottom by 2. So it could be 6 square root t plus 1 plus c, right? Now at t equals 0 seconds, the velocity is 2 feet per second, right? So we're going to use this initial condition to solve for c, right? So I have this guy right here, actually 2 equals 6 square root of substitutes 0 for t, right? So it'll be 0 plus 1 plus c, right? So c equals negative 4, right? So then you have vb of t equals 6 square root of t plus 1 minus 4, right? Which of the two rockets is traveling faster at t equals 80 seconds? So we substitute 80 for t, so right? So VB of 80 equals 6 square root of 80 plus 1 is going to be 81 minus 4, right? Square root of 81 is 9. 9 times 6 is going to be 54. Subtract 4 is going to be 50, right? Now we need to calculate VA of 80, right? So we go back over here. It's going to be right here, 49, right? So sin 50 greater than 49, we can conclude that the rocket B traveling faster at time t equals 80 seconds than rocket A. We're going to review Unit 7, AB, calculus AB and BC, differential equations. Alright, find the general solution to the differential equation 2x times y plus 1 minus y times y prime equals 0. Alright, so we can rewrite this one as y times y prime which means dy over ds. right, equals 2x times y plus 1, right? Now we're going to separate the variable, right? So we're going to multiply both sides by ds and divide both sides by y plus 1, right? So this guy turns out to be, then we're going to integrate both sides, right? So the left hand side right here, we can do long division, or you can literally add 1 and subtract 1, right? So you can separate this one, it's going to be y plus 1 over y plus 1 is going to be 1 minus 1 over y plus 1, right? dy equals, you're going to integrate this one, it's going to be 2 times x squared over 2 plus c, right? Now, antiderivative of 1 is going to be y, right? dy right here, I can rewrite dy as d of y plus 1, right? So, I can apply the formula 1 over u du. It's going to be ln absolute value of u plus c, right? So, right here you have ln absolute value of y plus 1, right? Equals 2 and 2 cancel out. S squared plus c, right? This one is the final answer, right? You cannot rewrite this one as a single y, right? Now let's move on to question 2. Find the general solution to the differential equation s y prime plus 2y equals 0, right? So this one can be written as dy over ds equals negative 2y, right? Now you're going to separate the variable. Make sure y on the left and x on the right, right? So you're going to multiply both sides by ds over x, right? So this guy turns out to be dy equals negative 2y times ds over s, right? And then divide both sides by y, so it could be dy over y equals negative 2 over s ds, right? Now you're going to integrate both sides, right? So this guy turns out to be ln absolute value of y, right, equals negative 2 ln absolute value of x plus c, right? To solve for y, you need to exponentiate both sides, right? So I have e to this one equals e to the whole thing right here, right? So this guy turns out to be absolute value of y equals negative 2, bring back over here, right? So I have absolute value of x power of negative 2 times e to the c, right? Now I'm going to simplify, so the be absolute value of y equals e to the c over x squared, right? So then this guy becomes y equals plus and minus e to the c over x squared, right? You can leave your answer like this, or you can rewrite this one as y equals c0 s squared. c0 equals plus and minus e to the c, right? And of course, the domain for this one should be s not equal to 0, right? Now question 3. Find the general solution to the differential equation y prime minus 2e to the x equal to 0. So you can rewrite this one as y times dy over dx equals 2e to the x, right? Now you can separate the variable by multiplying both sides by dx, right? So you have y dy equals 2e to the x ds, right? Now you're going to integrate both sides, right? So the left hand side equals y squared over 2, right? The right hand side is going to be 2e to the x plus c, right? So y squared equals 4e to the x plus c. Now you can leave your answer like this, or you can take square root both sides, right? So you have y equals plus and minus square root of 4 e to the x plus c, right? Now let's move on to question 4. Find the particular solution to the differential equation sy prime minus ln(x) equals 0 given the initial condition y arc1 equals 0, right? So this one can be written as sy dy over dx equals ln(x), right? Now we can separate the variable by multiplying both sides by dx over x, right? So it's going to be y dy equals ln x over x dx, right? Now the left hand side is y dy, right? The right hand side right here, I can rewrite this one as ln x, right? dx over x is actually d of ln x, right? Because the derivative of ln x is going to be 1 over x dx, right? So I can integrate both sides, right? And then you just apply the power rule, right? So you have y squared over 2 equals this one right here, actually u du, right? So if you integrate this one, it's going to be u squared over 2 plus c, where u equals ln s, right? So you have ln s over 2 squared plus c, right? Now you're going to use the initial condition right here to solve for c, right? So substitute 1 for s and 0 for y, right? So I have ln arc1 altogether square over 2 plus c equals 0, right? ln arc1 equals 0, right? So the answer is c equal to 0. And then the equation becomes y squared over 2 equals ln s altogether square over 2, right? And then you just multiply both sides by 2, right? So you have y squared equals ln s altogether square, right? This one is the final answer. Now question number 5. Find the particular solution to the differential equation given the initial condition y of 0 equals 1, right? Now first we need to separate this one, right? So we have y squared root 1 minus s squared dy over dx equals s squared root 1 minus y squared, right? So I'm going to bring this guy to the left, I'm going to bring this one to the right, bring the s to the right, right? So I'm going to divide both sides by square root of 1 minus y squared and multiply both sides by dx over square root of 1 minus s squared, right? So I have y over square root of 1 minus y squared dy equals s over square root of 1 minus s squared dx, right? Now I'm gonna integrate both sides, right? Now in order to integrate this one, I'm gonna use u substitution, right? So I'm gonna let u be the bottom right here, right? Now both sides have the same manner, so I just do the left hand side and I'm gonna have the same thing on the right hand side, right? So I let u be square root of 1 minus y squared, right? And then u squared equals 1 minus y squared, right? And then 2u du equals negative 2y dy, right? So on the top I only have y dy, right? So I need to divide both sides by negative 2, right? So I have negative u du equals y dy, right? So this guy becomes y dy is negative u du, right? So I have negative u du, right? Over this one right here, actually u, right? So this guy becomes negative antiderivative of du, and it's going to be negative u plus c, right? But u equal this one, so it turns out to be negative square root of 1 minus y squared plus c, right? The left hand side becomes negative square root of 1 minus y squared equals the right hand side negative square root of 1 minus s squared, right, plus c. Now I'm going to use the initial condition right here, right? So I have negative square root of 1 minus 1 square equals negative square root of 1 minus 0 square plus c, right? So c equals 1, right? Then this guy becomes square root of 1 minus y squared equals square root of 1 minus s squared minus 1, right? Because I substitute 1 over here and I'm going to multiply both sides by negative 1. To solve this one, I just square both sides, right? So I have 1 minus y squared equals this one square. I just use complete square formula for this one right here, right? So remember, complete square formula is going to be a minus b square equals a square minus 2ab plus b squared, right? So it's going to be 1 minus s squared minus 2 square root of 1 minus s squared plus 1, right? So this guy becomes 1 minus y squared equals 2 minus s squared minus 2 square root of 1 minus s squared, right? Now I just subtract 1 both sides, so I have negative y squared equals 1 minus s squared minus 2 square root of 1 minus s squared, right? And then I'm going to multiply both sides by negative 1, so y squared equals s squared plus 2 square root of 1 minus s squared minus 1, right? I'm going to take square root both sides, so I have y equals plus and minus square root of s squared plus 2 square root of 1 minus s squared minus 1, right? Now, since initial condition right here is 1, which is positive, right? So, I'm going to pick the positive values, right? So, y equals positive s squared plus 2 square root of 1 minus s squared minus 1, right? Now, let's move on to question 6. Find the particular solution to the differential equation given the initial condition y of 1 equals 0. Now I need to rewrite this one as 1 plus s squared times 1 plus y squared equals s squared dy over dx, right? Now I will multiply both sides by dx, right? So I have 1 plus s squared times 1 plus y squared dx equals s squared dy, right? So I'm going to divide both sides by s and divide both sides by 1 plus y squared, right? So I have 1 plus s squared over s dx equals y over 1 plus y squared dy, right? Now I'm going to rewrite this one as y over 1 plus y squared dy equals 1 plus s squared over s dx, right? Now I'm going to integrate both sides, right? Now the left hand side, I just multiply the top by 2 and divide by 2, right? So if you take derivative of the bottom right here, it's actually the top, right? So then you can apply the formula antiderivative of u prime du over u. It's going to be ln absolute value of u plus c, right? So the left hand side right here becomes 1/2 ln absolute value of 1 plus y squared, right? Equals the right hand side right here, I can separate this one as antiderivative of 1 over s plus s squared divided by s to be s, like that, ds, right? And I'm going to take antiderivative of each of this one, right? So to be ln absolute value of s, right? Plus s squared over 2 plus c, right? Now I'm going to use initial condition right here to solve for c, right? So I'm going to have substitute 0 for y, right? The left hand side actually 1/2 ln 1 is going to be 0, right? The right hand side substitute 1 for s, ln of 1 equals 0, you have 1/2 right here, right? 1/2 plus c, then c equals negative 1/2, right? Substitute negative 1/2 over here. So you have this one actually negative 1/2, right? Now let's simplify this one further, just in case you're not gonna see the answer join like this on the MCQ portion, right? So I'm gonna multiply both sides by 2. I'm gonna have ln absolute value of 1 plus y squared equals 2 ln s plus s squared minus 1, right? Now I need to solve for y. So I need to exponentiate both sides, right? Before I'm going to exponentiate both sides, I need to print 2 part over here, right? Remember, log base a of b power k. You can print k to the front. Or you can print k back over here to get this one, right? I have ln absolute value of 1 plus y squared equals ln absolute value of s squared plus s squared minus 1, right? Now I'm going to exponentiate both sides, right? So this guy becomes absolute value of 1 plus y squared, right? Remember you have the formula a raised to the log base a of b equals b, right? Now ln, which means log base e, right? So I have e log base e of b equals b, right? Now on the right hand side, you need to be careful. You need to apply the formula a to the m plus n equals a to the m times a to the n, right? So this guy becomes e to the ln absolute value of s squared times e to the s squared minus 1, right? Now I'm going to apply the formula right here. So this guy becomes absolute value of s squared, right? Because s squared always positive, so I don't need absolute value sign anymore, right? So I have s squared right here, right? Times e to the s squared minus 1, right? I have 1 plus y squared equals s squared times e to the s squared minus 1, right? Subtract 1 both sides, so you have y squared equals s squared times e to the s squared minus 1. Subtract 1, right? Now you can take square root both sides, so you have y equals plus and minus square root of s squared e to the s squared minus 1 minus 1. Now let's move on to question 7. Find the general solution to the differential equation. Now we need to separate the variable, right? So before we're going to do that, we need to rewrite this one as e to the 2y dy over ds equals s cubed, right? Multiply both sides by ds, so you have e to the 2y dy equals s cubed ds, right? Now we're going to integrate both sides, right? So the left hand side should be 1/2 e to the 2y equals s to the 4 over 4 plus c, right? Remember you have the formula e to the as plus b ds equals 1 over a e to the as plus b plus c. Keep that in mind. Alright, so I'm gonna multiply both sides by 2. So I have e to the 2y equals s to the 4 over 2 plus 2c, right? Now I'm going to take natural log both sides, right? So this guy becomes 2y equals natural log of s to the 4 over 2 plus 2c, right? And then I'm going to divide both sides by 2. So I have y equals 1/2 of ln of s to the 4 over 2 plus 2c, right? Now I can rewrite 2c as another c, right? So the final answer must be y equals 1/2 ln of s to the 4 over 2 plus c1, like that, where c1 equals 2c, right? And this one is the final answer. Now let's move on to question 8. The rate at which people consume Pringles potato chips in the US is given by P of t equals C times e to the kt, where p is measured in millions of cans per year, and t is measured in years from the beginning of 1990. So which means at this time t equals 0, right? The consumption rate triples, which means you need to multiply by 3, right? Every 4 years, which means t equals 4, right? And the consumption rate at the beginning of 1990 was 8 million cans per year, right? So which means you have the order pair 0,8 millions, right? Find C and K. So you have the equation right here. So P of T equals C e to the K T, right? Now use the initial condition right here, 0.8 million, right? We have 8 million equals C times e to the 0, right? And then C equals 8 million, right? Now substitute back over here, you have equation P of T equals 8 millions e to the kt, right? Now we're going to use the second information right here. The consumption rate triples every 4 years, right? It tells us that P of t equals this guy multiplied by 3, right? So you have 24 millions equals 8 millions times e to the 4k, right? Because t equals 4. Now divide both sides by 8 millions, right? So you have e to the 4k equals 3, right? Take natural log both sides, so you have 4k equals ln 3, right? And then k equals 1 4 ln 3, right? So finally k equals this one and c equals this one, right? Question 9. Consider the differential equation dy over dx equals s minus 1. Create a slope field for this differential equation using 25 points. Now remember, in order to do this question, you need to know the Christmas tree trick. If the line is going up, the slope is positive. If the line is going down, slope is negative. If the line is horizontal, slope is 0. If the line vertical, slope is undefined, right? Now on the left hand side right here, the line is going up. If the slope is bigger, the line is steeper, right? Now, on the right hand side, the line is going down. If the slope is bigger, the line is less steep, right? Alright, now we need to sketch a table. Remember, the slope right here does not depend on the y value, right? So, we just focus on the s value, right? Now the s value is 0, 1, 2, -1, and -2, right? So I have 0 right here, 1, 2, -1, and -2. Alright, substitute 0 for s, the slope should be -1, right? Substitute 1 for s is going to be 0. Substitute 2 for s is going to be 1. Substitute -1 for s is going to be -2. Substitute -2 for s is going to be -3, right? So we look at this one. Alright, use the Christmas tree trick right here. This one should be horizontal, right? Now, 1 right here, upward, right? And -3 right here, downward, right? -2 right here, downward, but less steep, right? -1, downward, but less steep, right? Right, now we're gonna sketch the slope field for this one first, right? So s equals 1, the slope is 0, right? So no matter y value is, you always have the 0 slope right here, right? Now s equals 2, the slope is 1, right? S equals 2, the slope is 1, so which means rise equals 1 and run equals 1, right? Rise over run, right? So it could be 1 over 1, right? So go up by 1, go to the right by 1, right? So it's going to be something like this. So you connect this guy right here. So the slope should be something like this. right? Now next one, the slope is -1, so rise over run, right? So rise is -1 and run is 1, right? Because -1 divided by 1 is going to be -1, right? So s was 0. Rise is -1 and run is 1, so go down by 1, go to the right by 1, right? So it could be something like this. You connect this one. This is the guideline, right? Now next one, -2 when s was -1, right? So rise equals -2 and run equals 1, right? So you have rise at -1 right here, rise equal -2, so go down by 2 and go to the right by 1. So if you use this guideline right here, the slope should be like this, right? And observe that the slope of this guy is bigger than this guy. So the line right here is less steep than this guy, right? Now the last one, s equal -2, so this one right here, the slope is -3, right? So rise is -3, right? So you go down by 3, go to the right by 1, right? 1, 2, and 3 right here. So 1 right here. So if you use the guideline right here, right? So the line should be like this, steeper, right? This guy is steeper than this guy. This guy is steeper than this guy, right? Now, if you use decimals to check your work, it's gonna be something like this. Sketch a solution to the differential equation on the slope field above through the point -1 and 1. So -1 and 1 is gonna be right here, right? So it's gonna be something like this. Question C. Write the equation of the tangent line drawn to FOS that passes through -1 and 1, right? So we have the slope formula. It's going to be dy over dx equals s minus 1, right? Now we need to evaluate this slope at this point right here, right? So we're gonna draw the line and we put -1, 1 right here, right? It's gonna be the same thing right here, -1, 1, right? So substitute -1 over here, the slope is -2, right? And we're gonna use the point slope form formula y minus y1 equals m times s minus s1, right? So the order pair right here actually s1, y1, right? And the slope right here is gonna be -2, right? So the equation should be y minus 1 equals -2 times s plus 1, right? Now you're going to simplify this one. So it's going to be y equals -2s minus 1, right? Question D. Use the tangent lines from part C to estimate f of 0.3. So you have this guy actually f of s, right? So you have f of 0.3 is approximately -2 times 0.3 minus 1. So it will be -0.6 minus 1 is going to be -1.6, right? Now question E. Find the particular solution to the differential equation for the initial point -1 and 1. Alright, so we have dy over dx equals s minus 1. We need to separate the variable by multiplying both sides by dx, right? So you have dy equals s minus 1 ds, right? Now you're gonna integrate both sides, right? So this one becomes y equals s squared over 2 minus s plus c, right? And we're gonna use the initial condition right here. So s1 equals 1, y equals 1 to solve for c, right? So you have 1 equals 1 over 2 plus 1 plus c, right? And then c equals 1 minus 3 over 2, and it's going to be -1 over 2, right? So the equation becomes y equals s squared over 2 minus s minus 1 half, right? Now let's move on to question 10. Consider the differential equation dy over dx equals 1/2 s times y minus 4 cubed. A slope field for the given differential equation is shown below. Scatter solution curve that passes through the point 0, 2. So point 0, 2 is right here, right? If you substitute 0, 2 into this equation, of course, the slope equals 0, right? So right here should be horizontal, right? Now, you just follow the flow of this one right here, right? So it could be something like this. Right. Now question B. Find the particular solution y equals fs to the given differential equation given the initial condition f of 1 equals 0, right? So you have dy over dx equals 1/2 s times y minus 4 cubed. Now you need to separate the variable first, right? So you're going to divide both sides by y minus 4 cubed and multiply both sides by dx, right? So you have dy over y minus 4 cubed equals 1/2 s dx, right? And then you need to integrate both sides, right? Now the left hand side right here, you're going to use the power rule. Before you're going to use the power rule, make sure you need to rewrite dy as d of y minus 4, right? Remember, look, dy actually dy of minus 4, right? And then you can apply the formula antiderivative of u to the n du. It's going to be u to the n plus 1 over n plus 1 plus c, right? So this one right here can be written as, right? Now I can apply the power rule, right? So it could be y minus 4 raised to the negative 3 plus 1 is going to be negative 2 over negative 2, right? Equals 1/2 s squared over 2 plus c, right? Now this one can be written as negative 1 over 2 times y minus 4 squared equals 1 over 4 s squared plus c, right? Now we can use initial condition right here to solve for c. Substitute 1 for s and 0 for y, so it could be negative 1 over 2 times negative 4 squared, it could be 16, right? Equals 1 over 4 plus c, right? So c equals negative 9 over 32. And then you have equation is going to be negative 1/2 times y minus 4 squared equals 1 over 4 s squared minus 9 over 32, right? Now we need to solve for y, so we're going to multiply both sides by negative 2, right? So this guy becomes 1 over y minus 4 squared equals negative s squared over 2 plus 9 over 16, right? And then this becomes 1 over y minus 4 squared equals, I'm going to condense this one, right? So this guy becomes 9 minus 8 s squared over 16, right? So I just flip this one, so it's going to be y minus 4 squared equals 16 over 9 minus 8 s squared, right? Now I'm going to just square root both sides, so y minus 4 equals plus and minus square root of 16 over 9 minus 8 s squared, right? Now I'm going to use the initial condition right here to check for y, right? So x equals 1, y equals 0. Substitute 0 for y over here. So I have 0 minus 4 equals negative 4, which is negative, right? So I'm going to pick the negative side, right? So your solution should be y minus 4 equals negative square root of 16 over 9 minus 8s squared, right? Now I'm going to add 4 both sides. So final solution is y equals 4 minus square root of 16 over 9 minus 8s squared. This one is the final solution. Now let's move on to question 15. If dy over dx equals x plus 2xy and y of 0 equals 1, find y as a function of s, right? So basically we just solve differential equation right here, right? Now we're going to separate the variable, right? So I'm going to factor s out first, right? So I have dy over dx equals 2y plus 1 times s, right? Then I'm going to multiply both sides by ds and divide both sides by 2y plus 1, right? So I have dy over 2y plus 1 equals s ds, right? Now I'm going to integrate both sides, right? Now I'm going to apply the formula antiderivative of u prime over u du. It's going to be ln absolute value of u plus c, right? Now, in order to apply this formula, I need to rewrite the left-hand side, right? So it could be like this, antiderivative of dy. I just rewrite this one as d 2y plus 1, right? So when I take derivative of this one, actually I have 2, right? So I need to divide by 2 right here, so that the things doesn't change, right? Over 2y plus 1, like that, right? Equals antiderivative of s ds. Now the left hand side is going to be 1 over 2 ln absolute value of 2y plus 1. The right hand side is going to be 1 half s squared plus c, right? Now we're going to use the initial condition right here to solve for c, right? So I have 1 half ln of absolute value of substitute 1 for y, so it could be 3 equals substitute 0 for s, it could be c, right? So c equals 1 half ln 3, right? So I substitute back over here. So final, I have 1 over 2 ln absolute value of 2y plus 1 equals 1 half s squared plus 1 half ln 3, right? Now I'm going to multiply both sides by 2. So I have ln absolute value of 2y plus 1 equals s squared plus ln 3, right? Now I'm going to exponentiate both sides, right? So e to this one equal e to this one, right? So it will be absolute value of 2y plus 1 equals e to the s squared times e to the ln 3, right? So it will be absolute value of 2y plus 1 equals e to the s squared times 3, right? Now, since initial condition right here is positive, right? Substitute 1 over here is always positive, right? So I just remove absolute value side, so it could be 2y plus 1 without changing anything, right? Equals 3 e to the s squared. Now I'm going to subtract 1 both sides and divide both sides by 2, so it could be y equals 3.5 e to the s squared minus 1 over 2. This one is the final answer, right? So the answer choice must be C. Now let's move on to question 16. The general solution of the differential equation y dy equals negative s ds is a family of. So basically we just solve this one, right? So I have y dy equals negative s ds, right? Now I'm going to integrate both sides, right? So I have 1 half y squared equals negative 1 half s squared plus c, right? Now I'm going to multiply both sides by 2. So I have y squared equals negative s squared plus c1, right? Because 2c, I can rewrite this one as another c, right? I'm going to add s squared both sides. So I have s squared plus y squared equals c1, right? This one actually the equation of the circle, right? So the answer must be A. Now question 17. The differential equation dt over dt equals 14 minus 0.01 T models the temperature T above room temperatures of an electric burner. T is measured in degrees Fahrenheit and T is greater than or equal to 0 is in seconds. Question A. Find the general solution of the differential equation then solve for T, right? So basically, we're going to separate the variable and we're going to integrate both sides, right? So we have d capital T over dt equals 14 minus 0.01 T, right? Now multiply both sides by dt and divide both sides by this guy, right? So have d capital T over 14 minus 0.01 capital T equals dt, like that, right? Now we're gonna integrate both sides, right? Now the left hand side, we need to apply the formula u prime over u du. It's gonna be ln absolute value of u plus c, right? So in order to apply this one, make sure you take derivative of the bottom. Now if you take derivative of the bottom, it becomes negative 0.01 dt, right? So in order to apply this formula right here, I need to multiply the top by negative 0.01, right? And divide by negative 0.01, right? So this guy becomes 1 over negative 0.01 ln absolute value of the bottom, 14 minus 0.01 t, right? Equals, this one is going to be t plus c, right? Now to remove decimal number, I just multiply the top and bottom by negative 100, right? So this guy becomes negative 100 ln absolute value of 14 minus 0.01 t equals t plus c, right? Now divide both sides by negative 100, so this guy becomes ln absolute value of 14 minus 0.01 t, right? Equals negative t over 100, right? Now if c divided by negative 100, it's going to be another c, right? So I just name this one as c1, something like that, right? Now to solve for capital T, I need to exponentiate both sides, right? So e to this one equals e to this one, right? So it's going to be absolute value of 14 minus 0.01 capital T equals e to the negative t over 100 times e to the c1, right? Now I'm going to remove the absolute value sign, so I have 14 minus 0.01 capital T equals plus and minus e to the negative t over 100 times e to the c1, right? So I'm going to name another c. 2 equals plus and minus e to the c1, right? So this guy becomes 14 minus 0.01 t equals c e to the negative t over 100, right? This one is c1. Subtract 14 both sides, so have negative 0.01 capital T equals negative 14 plus c1 e to the negative t over 100, right? Divide both sides by negative 0.01, so capital T equals 1400 minus c1 divided by 0.01 e to the negative t over 100, right? Now I just name c3 equals negative c1 over 0.01, right? So finally I have capital T equals 1400 plus c3 e to the negative t over 100, right? The constant right here doesn't matter. You can name any letter, right? You can name D, E, F, it's up to you. So this one is the final answer. Now question B. When the burner is turned on, T equals 0 and capital T equals 70, use this fact to find the value of the constant. So we need to find the constant C3 right here, right? So we have 70 equals 1400 plus C3 e to the 0, right? So C3 equals 70 minus 1400, right? So it could be negative 1330, right? Now question C. The safety standards board has determined that this type of burner left on continuously is unsafe if its temperatures can exceed 1500 degrees Fahrenheit. It is burner safe or unsafe? Justify your answer. Alright. So basically, you need to take the limit of this guy right here when the little t approaches infinity equals limit when t approaches infinity of 1400 subtract 1330 e to the negative t over 100, right? And it's going to be limit of 1400 subtract 1330 over e to the t over 100 when t approaches infinity, right? Now when t approaches infinity, this guy right here approaches 0, right? So the answer must be 1400, right? Now 1400 is less than 1500, right? So the burner is safe, right? Hello everyone, in this video we're gonna review Unit 7 IP Calculus BC topic 7.5 Euler's method and 7.9 Logistic models with differential equations. Alright, let's move on to question 1. This question comes from AP Calculus BC exam 2004 question 5. A population is modeled by a function p that satisfies the logistic differential equation. Question A. If p of 0 equals 3, what is limit of p of t when t approaches infinity? If p of 0 equals 20, what is the limit of p of t when t approaches infinity? Alright, so before we're going to do this question, let's review the logistic models with differential equation. Alright, this is 7.9 logistic models with differential equations. So, the logistic model differential equation forms is given by the formula dy over dt equals k times y times 1 minus y over L. Logistic growth equation forms is given by this formula. Alright, in either form, L represents the carrying capacity. This one is extremely important. Right, so L right here and L right here. Or upper limit of the logistic growth equation. A logistic growth curve increases the fastest when the curve reaches half its carrying capacity L. So we look at the graph right here. The horizontal line right here is called the carrying capacity. It looks like a horizontal asymptote, right? And the logistic growth increases fastest when the curve reaches half of carrying capacity, right? So for example, the distance from here to here is the carrying capacity. It's gonna be like 20, alright? So the logistic curve growth increase fastest when it's gonna be 10, right? Half of 20, which means 10, right? Now we're gonna go back over here. So in order to answer question A, we need to rewrite this one, right? So this one can be written as 1 over 5p, right? Times 1 minus p over 12, right? Remember, the logistic model is given by the formula dy over dt equals k times y times 1 minus y over L, right? So in this situation, L equals 12, right? So the limit of p of t when t approaches infinity equals L, which is 12, right? This one is the same thing, 12, right? If p of 0 equals 3, for what value of p is the population growing the fastest, right? So the logistic model's growth increase fastest when it reaches half of carrying capacity, right? So carrying capacity is 12, right? So this guy should be 6, right? Then you can conclude that p equals 6, right? Now let's move on to question C. A different population is modeled by a function y that satisfies the separable differential equation dy over dt equals y over 5 times 1 minus t over 12. Find y of t if y of 0 equals 3. Now, to solve for y of t, we need to separate the variable by multiplying both sides by dt and dividing both sides by y, right? So this guy becomes dy over y equals 1 over 5 times 1 minus t over 12 times dt, right? And then we're gonna integrate both sides, right? So the left hand side turns out to be ln absolute value of y equals. Now the right hand side I just print 1 over 5 to the front, right? Antiderivative of 1, which is t, right? Antiderivative of this one, which is rewrite 1 over 12, right? Multiply by t squared over 2, right? Plus c, right? Now I'm going to simplify this one, so it will be ln absolute value of y equals 1 over 5 t, right? Minus 12 times 2, it could be 24, times 5, it could be 120, right? So it could be negative t squared over 120 plus c, right? Now 1 over 5t, I can write this one as t over 5, right? Now I'm going to exponentiate both sides, right? So this guy becomes e to the this guy and e to this guy, right? So I'm going to apply the formula a to the log base a of b equals b, right? Because ln is going to be log base e, right? So log base e is of absolute value of y, and then this one is e. It's going to be absolute value of y, right? So this guy becomes absolute value of y equals e to the t over 5 minus t squared over 120 times e to the c, right? Remember, you have the formula a power of m plus n. It's going to be a power of m times a power of n, right? Keep that in mind. Now I'm going to name e to the c as a, right? So this guy becomes absolute value of y equals a times e to the t over 5 minus t squared over 120, right? Now I'm going to use initial condition right here. Alright, initial condition is positive, right? So I can remove the absolute value bars right here without changing anything, right? So I have y equals a times e. Now this one right here, I can rewrite this one first and this one next, right? So I can write like this, negative t squared over 120 plus t over 5, right? Now I'm going to use initial condition right here to solve for a, right? So I have 3 equals a times e, 0, right? So a equals 3, right? And the final equation should be y equals 3 times e to the negative t squared over 120 plus t over 5. This one is the final answer, right? Now question D. For the function y found in part C, what is the limit of y of t when t approaches infinity, right? So basically, we just find the limit of this function, right? So limit of y of t when t approaches infinity equals limit of 3 times e to the negative t squared over 120 plus t over 5, right? When t approaches infinity. This guy is the same thing as limit when t approaches infinity of 3. I can bring this one to the bottom. So it could be e to the t squared over 120 minus t over 5, right? So I can rewrite this one as limit when t approaches infinity of 3 over e to the Now I can write this one and this one at the same denominator, right? So denominator is 120, right? And this guy becomes t squared minus 24t, right? Now when t approaches infinity, this guy right here faster than this guy, so we can ignore this guy, right? So this guy becomes 3 over infinity, right? And this could be 0, right? Now let's move on to question 2. This one comes from AP Calculus BC exam 2009 question 4. Consider the differential equation dy over dx equals 6x squared minus x squared y. Let y equals fs be a particular solution to the differential equation with the initial condition f of -1 equals 2. Use the Euler's method with two steps of equal sign starting at s equals -1 to approximate f of 0, right? So in order to do this problem, we need to get the table. Alright, so first you need to calculate delta S, right? It's going to be B minus A divided by N, right? Now B equals 0 right here is the final one, right? And A equals -1 right here, right? And it's going to be two steps of equal sign, so N equals 2, right? So you have 0 minus -1 divided by 2, so it could be 0.5, right? Now we're going to start with the initial value, which is s equals -1 right here, right? And when you keep adding 0.5 each time until you reach the final one, 0 right here, right? So you add 0.5, it's going to be -0.5, right? And add 0.5 is going to be 0 right here, and you stop, right? And then the final value is right here. This is what you need to find, right? So at initial value, s equals -1, y equals 2, you just put 2 over here, right? So you're going to substitute -1 and 2 into differential equation right here to find dy over dx, right? So if you substitute over here, it's going to be 6 minus 2, so it's going to be 4, right? And then equation of the tangent line is going to be y minus y1 equals m times s minus s1, right? S1 is right here, y1 is right here, the slope is right here. You just substitute over here, right? So you're going to have y minus 2 equals 4 times s plus 1, right? Now you need to substitute -0.5 for s into this equation to solve for y right here, right? So if I substitute over there, I will get the new y should be 4, right? So I put 4 right here, right? Now you have the new x, new y, and you need to calculate new dy over dx, right? So substitute -0.5 for x and 4 for y into the differential equation right here, and you get the new dy over dx is actually 0.5, right? And then you apply this formula right here, so it will be y minus 4 equals 0.5 times s plus 0.5, right? And then you substitute 0 for s into this equation right here, so you're gonna get 4.25, right? So finally, the question mark right here should be 4.25. You stop right here. This one is the final answer, right? Question B. At the point -1 and 2, the value of the second derivative is -12. Find the second degree Taylor polynomial for the function f about s equals -1. Alright, so this topic actually you learn in Unit 10, Taylor and Maclaurin series. Question B. Alright, so you have the Taylor series is given by the formula f of s equals sigma notation of f n of a over n factorial times s minus a to the n, when n goes from 0 to infinity. Now we're going to expand this formula. If n equals 0, substitute 0 for n, you only have f of a, right? If n equals 1, you have f prime of a times s minus a, right? Because 0 factorial equals 1 factorial equals 1. So keep that in mind. If n equals 2, you have f double prime over 2 factorial times s minus a square, right? If n equals 3, you're going to have f triple prime of a over 3 factorial times s minus a cube plus etc. Right? Now, the question just want you to find the second degree Taylor polynomial, which is you're going to stop right here. This one, enough. Now, this one is the Taylor series for FRS about S equals A, right? So you have A right here, you have A right here, right? Now, in this situation, S equals -1. Substitute -1 for A into this one right here, right? So you have P2 equals f of -1 plus f prime of -1 times s minus -1, which is plus 1, right? Plus f double prime of -1 over 2 factorial of s minus -1, which is plus 1 altogether square, right? Now, to find the answer, we need to solve for f of -1, right? F of -1 is given right here. It's going to be 2. Plus f prime of -1. We're going to use the order pair right here, right? So we substitute this guy into this equation right here, right? But we already calculated it's right here, actually 4 right here, right? So we have 4 times s plus 1, right? Plus f double prime of -1, right? It's going to be right here, -12. -12 divided by 2 factorial, it's going to be 2 times 1, right? So it could be -6, right? Times s plus 1 square, right? So I just simplify this one. It turns out to be 2 plus 4 times s plus 1 minus 6 times s plus 1 square. This one is the second degree Taylor polynomial, right? Now question C. Find the particular solution y equals fs to the given differential equation with the initial condition f of -1 equals 2. Now we need to separate the variable. In order to separate the variable, you need to factor s squared out first, right? So we have dy over dx equals s squared times 6 minus y, right? So I'm going to multiply both sides by dx and divide both sides by 6 minus y, right? So it could be dy over 6 minus y equals s squared times dx, right? Now I'm going to integrate both sides, right? Now the left hand side right here, I need to apply the formula antiderivative of u prime over u du. It's going to be ln absolute value of u plus c, right? Now, in order to apply this formula, make sure this guy and this guy must be the same, right? So the bottom right here is 6 minus y. The top is just y right here. I need to rewrite this one as 6 minus y, right? So dy right here can be written as d of 6 minus y, right? If you check the derivative of this one, actually negative dy, right? So I put negative side right here and I put negative side in the front, right? So thing doesn't change, right? So right here, I just apply the formula right here, right? So this guy becomes negative of natural log of absolute value of 6 minus y equals. The right hand side, I just use the power rule, right? So it could be 1/3 s q plus c, right? I'm going to use the initial condition right here to solve for c, right? It's going to be right here. So I'm going to substitute -1 for s and 2 for y, right? So I have negative ln of 4 equals 1/3 of -1 cube plus c, right? So c equals 1/3 minus ln 4, right? So then the equation right here becomes negative ln of absolute value of 6 minus y equals 1/3 SQ plus 1/3 minus ln of 4, right? Now I'm going to multiply both sides by -1, so ln of absolute value of 6 minus y equals -1/3 SQ minus 1/3 plus ln 4, right? Now on the right hand side right here, I just combine the first two terms right here. I factor -1 out, right? So I have this guy plus this guy, like that, right? Now I'm going to exponentiate both sides, right? So I have e to this one equals e to this one, right? So this guy becomes absolute value of 6 minus y equals e to the negative of 1/3 s cubed plus 1/3, right? Times e to the ln 4, right? Now e to the ln 4 actually 4, right? So I can bring 4 to the front. Now I need to remove the absolute value sign using the initial condition, right? So my initial condition is going to be f of -1 equals 2, right? I substitute 2 for y into this one, and 6 minus 2 is going to be 4. It is positive, right? So I remove the absolute value box without changing anything, right? So I have 6 minus y equals 4 times e to the negative of 1/3 s cubed plus 1/3, right? So then y equals 6 minus 4 times e to the negative of 1/3 s cubed plus 1/3, right? Now let's move on to question 3. This comes from AP Calculus BC exam 2012, question 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. B of t is the weight of the bird in grams. At time t days after its first weigh, then dB over dt equals 1/5 times 100 minus b. Let y equals b of t be the solution to the differential equation above with initial condition b of 0 equals 20. Question A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Alright, so when it's come to faster or slower, think about the first derivative, right? So we just substitute 40 for b and 70 for b into the differential equation right here. So I have question A. Now you have dB over dt when b equals 40. It's going to be 1/5 times 100 minus 40, right? So 100 minus 40 is going to be 60 divided by 5 is going to be 12, right? dB over dt when b equals 70 is going to be 1/500 subtract 70, right? So it's going to be 6. So you can conclude that the bird is gaining weight faster when it weighs 40 grams, right? Because 12 greater than 6, right? Now let's move on to question B. Find the second derivative in terms of B. Use the second derivative to explain why the graph of B cannot resemble the following graph. Alright. So we have dB over dt equals 1/5 times 100 minus b, right? Now, the second derivative of this one becomes 1/5 times derivative of 100 is going to be 0. Derivative of this one is going to be negative dB over dt, right? But dB over dt equal this one, right? So it's going to be negative 1/5 times 1/5 times 100 minus b, right? Now we're going to simplify this one. It's going to be negative 1/25 times 100 minus b, right? We're gonna look at the graph right here. We see that b is always between 20 to 100, right? So it tells us that 100 minus b must be positive, right? And then a positive number multiplied by negative 1 over 25, which is negative, right? So then the second derivative right here is negative. It tells us that the function is always concave downward, right? But you look at this one right here, original graph right here is concave upward, right? So you can conclude that the graph of B is concave down for B from 20 to 100. A portion of the given graph is concave up, right? Now let's move on to question C. Use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20, right? Alright, so basically you divide both sides by 100 minus b and multiply both sides by dt, right? So we have db over 100 minus b equals 1 over 5 dt, right? Now we're gonna integrate both sides, right? Now remember, we need to make this one the same thing, so that we can apply the formula u prime over u du. It's gonna be ln absolute value of u plus c, right? So on the top right here, I can rewrite this one as d of 100 minus b, right? And if you check the derivative of this one, it's actually negative db, right? So I put negative side right here and negative side right here. So thing doesn't change, right? So this guy becomes negative ln absolute value of 100 minus b, right? Equals 1 over 5t plus c, right? Now we're going to use the initial condition right here to find c, right? So b of 0 equals 20. So substitute over here, you have negative ln absolute value of 100 subtract 20 is going to be 80, right? Equals c. So c equals negative ln of 80, right? So then the equation becomes negative ln of absolute value of 100 minus b equals 1 over 5t minus ln 80, right? Now I'm going to multiply both sides by negative 1. So then this guy becomes ln of absolute value of 100 minus b equals 1 over 5t times negative 1 is going to be negative right here, plus ln of 80, right? And then I'm going to exponentiate both sides, right? So I have e to this one equal e to this one, right? So it can be absolute value of 100 minus b equals e to the negative 1 over 5t times e to the ln of 80. So actually 80, right? Now since b always greater than equal 20, less than 100, so then this guy always positive, right? So I can remove the absolute value side without changing anything, right? So I have 100 minus b equals 80 times e to the negative 1 over 5t, right? So then b equals 100 subtract 80 times e to the negative 1 over 5t. This one is the final answer. Let's move on to question 4. This question comes from AP Calculus BC Exam 2013 question 5. Consider the differential equation dy over dx equals y squared times 2x plus 2. Let y equals FRS be the particular solution to the differential equation with initial condition f0 equals negative 1. Question A. Find the limit of FRS plus 1 over psi s. Show the work that leads to your answer, right? So I have question A right here. To find this limit, we need to find the limit on the top to see what happens, right? Limit of f of s plus 1 when s approaches 0. It's going to be f of 0 plus 1. It's going to be negative 1 plus 1 equals 0. Now limit of psi s when s approaches 0. It's going to be psi of 0. It's going to be 0. So we can conclude that this one is the indeterminate form, right? So we can apply the L'Hospital rule, right? So we have limit of f of s plus 1 over sine s when s approaches 0 equals limit when s approaches 0. Take derivative on the top, it could be f prime of s. Derivative on the bottom, it could be cosine s, right? So you can substitute 0 for s, it could be f prime of 0 over cosine of 0, right? Now f prime of 0 using this one right here, right? So remember y equals -1, right? So substitute 0 for s and -1 for y. You have -1 square times 2 times 0 plus 2, right? Over cosine of 0 equals 1, right? So this one turns out to be 2. Now question B. Use the Euler's method starting at s squared 0 with two steps of equal sign to approximate f of 1/2, right? So we're going to sketch the table. We start at s squared 0, right? So a equals 0, right? And we need to calculate f of 1/2, right? So b equals 1/2, right? Now we have two steps of equal size, so n equals 2, right? So delta s equals b minus a divided by n, right? So it could be 1/2 minus 0 divided by 2, right? So it could be 1 over 4, right? So the step size is 1 over 4, right? So we start at 0, we keep adding 1 over 4 until we get 1 over 2, right? So this one is 0, this one is 1 over 4, and this one is 1 over 2. And we need to find the value of y when s equals 1 over 2. This one is our answer, right? Now, the initial condition is f of 0 equals -1, right? So y equals -1 right here, right? So substitute 0 for s and -1 for y into this equation right here to solve for the slope, right? So the slope should be -1 squared equals 1, right? 0 times 2 equals be 0, right? So the answer should be 2, right? So equation of the tangent line, we're going to use this one right here, right? So we have y minus -1, which is plus 1, equals 2 times s minus 0, so it could be s only, right? Substitute 1 over 4 for s, right? So you have y equals 2 times 1 over 4 minus 1, right? So it could be 1 over 2 minus 1 is going to be -1 over 2, right? So we have -1 over 2 right here, right? Now substitute these two guys into this equation right here. So we have -1 over 2 squared is going to be 1 over 4 times 2 times 1 over 4, right? Plus 2, right? So this guy becomes 1 over 2, right? 1 over 2 plus 2 is going to be 5 over 2. 5 over 2 times 1 over 4 is going to be 5 over 8, right? Now the equation of the tangent line is going to be y plus 1/2 equals, the slope is going to be 5 over 8 times s minus 1 over 4, right? We need to calculate y of 1 over 2. So it's going to be y equals 5 over 8 times 1 over 2 minus 1 over 4, subtract 1 over 2, right? So 1 over 2 minus 1 over 4 is going to be 1 over 4, right? So it's going to be 5 over 8 times 1 over 4 minus 1 over 2. Now 5 over 8 times 1 over 4 is going to be 5 over 32, right? Minus 1 over 2, I can rewrite this one as 16 over 32, right? So the final answer must be -11 over 32, right? So the question mark right here should be -11 over 32. This one is the final answer, right? Now question C. Find y equals f of s, the particular solution to the differential equation with initial condition f of 0 equals -1, right? So now we need to separate the variables, right? So I'm going to divide both sides by y squared and multiply both sides by ds, right? So it could be dy over y squared equals 2x plus 2 times ds, right? Now the left hand side, I can rewrite this one as antiderivative of y to the -2 dy, right? the right hand side is going to be 2 times s squared over 2 plus 2s plus c, right? Now the left hand side, I can use the power rule, right? So I have negative 1 over y equals s squared plus 2s plus c, right? Now I need to use the initial condition. It's going to be f of 0 equals negative 1, right? Substitute over here to solve for c, right? So I have 1 equals c. So c equals 1, right? So substitute back over here. So you have equation negative 1 over y equals s squared plus 2s plus 1, right? Now, s squared plus 2s plus 1, this one actually the complete square formula, right? So we have s plus 1 altogether square equals negative 1 over y, right? Now, I'm going to multiply both sides by negative 1, right? So this guy becomes 1 over y equals negative s plus 1 altogether square, right? And I flip this one, it's going to be y equals negative 1 over s plus 1 altogether square, right? This one is the final answer. Now let's move on to question 5. AP Calculus BC Exam 2015 question number 4. Consider the differential equation dy over dx equals 2x minus y. Question A. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. Alright, so in order to do this one, remember we have the Christmas tree trick. If the line is going up, the slope is positive. The line is going down, the slope is negative. The line is horizontal, the slope is 0. The line is vertical, the slope is undefined. Right? Now on the left hand side, when the line is going up, bigger slope, steeper line, right? On the right hand side, the line is going down, smaller slope, steeper line, right? Alright, so we're gonna check this point first. This point is s equals 0, y equals 1, substitute over here. Right? So we have negative 1. So the slope is negative 1, which means rise over run equals negative 1 over 1, right? So you're going to start from here, going down 1 unit, and go to the right 1 unit. So you get the slope field is going to be follow this guy line right here. So it should be something like this, right? Now, next one, this point right here, x equals 0, y equals 2, you have negative 2, right? So negative 2, which means rise over run equals negative 2 over 1, right? So you're going to go down 2 units, go to the right 1 unit, right? So it could be something like this, right? So the slope field is going to be like this. So you see that this guy right here, less steep than this guy, right? Smaller slope, steeper line, right? Now next one, we're going to check this one, s equals 0, y equals negative 1. So the slope right here equals 1, right? Which means rise over run equals 1 over 1, right? So you're going to go up by 1, go to the right by 1. So you're going to get this one, something like this, right? So you're going to follow this guy line, you draw the slope field like this, right? Now next one, this point right here, s equals 1, y equals negative 1, substitute over here. So you have 2 plus 1 equals 3, right? So it could be rise over run equals 3 over 1, right? So you're going to start from here. You go up 3 units, right? 1, 2, 3, and go to the right 1 unit. So it could be right here, right? So you're going to draw this guy line right here, right? So the slope field is going to be something like this, right? Now this point right here, s equals 1, y equals 1, substitute over here, you have 1, right? So it's going to be rise over run equals 1 over 1, right? So you're going to go to the right 1 unit and go up 1 unit, right? So it could be right here, right? So you're going to follow this guideline, draw the slope field, right? Now we're going to substitute this one over here. You see that the slope is 0, right? So look at the Christmas tree, it's going to be horizontal line, right? So it could be like this. So I'm going to erase this one. Now question B. Find the second derivative in terms of s and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Alright. So we know that the differential equation is given by dy over dx equals 2x minus y, right? Now we need to calculate the second derivative of this one. So we have d squared of y over dx squared equals 2 minus dy over dx, right? So then it's going to be 2 minus, but dy over dx equal this one right here, right? So it could be 2x minus y, right? So it could be 2 minus 2x plus y, right? Now go back over here in second quadrant, right? So we have the x and y coordinate right here. The second quadrant is right here, right? In this quadrant, x is negative, y is positive, right? So if x negative, you have this guy right here, positive, right? And this one right here, positive, right? And this one is already positive, right? So the whole thing right here is positive, right? So if this one positive, the second derivative is positive, right? And then the function is concave up, right? Now let's move on to question C. Let y equals fs be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does the function f have a relative minimum, relative maximum, or neither at s equals 2? Alright, so whenever we talk about the relative minimum, relative maximum, or neither, we need to determine the first derivative, right? And this one right here must be the zero of the first derivative. So we're gonna check it. See, dy over dx equals 2x minus y, right? And then dy over dx, evaluate this one as x equals 2, y equals 3. It's gonna be 2 times 2 minus 3. It's gonna be 1, not equal to 0, right? So you can say that the function f has neither a relative minimum nor a relative maximum at s equals 2. Now let's move on to the question D. Find the values of the constant m and b for which y equals mx plus b is the solution to the differential equation. Alright, so we have y equals mx plus b, right? We need to take derivative both sides with respect to x, right? So we have, and then this guy becomes dy over dx equals, derivative of this one is going to be m, derivative of this one is going to be 0, right? So the final answer must be m, right? Now, dy over dx is given right here, right? It's going to be 2x minus y, right? So we have 2x minus y equals m, right? But y equals mx plus b, right? So we replace y with mx plus b, right? So we have 2x minus mx minus b equals m, right? Then I'm going to subtract m both sides. So we have 2x minus mx minus b minus m equal to 0, right? So the left hand side, I just factor s out. So it will be 2 minus m altogether times s. This one I factor negative 1 out, so it will be b plus m, right? The right hand side right here, I can rewrite this one as 0s plus 0, right? Now I can equate the coefficient both sides, right? This one has s, this one has s, so the coefficient must be the same, right? This one is the constant, this one is the constant, right? So we have a system of two equations. 2 minus m right here must be the same thing as this guy, right? Equal 0. And b plus m right here must be equal to this one, right? So we have negative of b plus m equal to 0, right? So the first equation, I have m equals 2, right? Substitute 2 for m into the second equation. So we have b plus 2 equal to 0 and b equals negative 2. So finally, m equals 2 and b equals negative 2 is the final answer. We're going to review Unit 8 applications for integration of the AP Calculus, AB, and BC. Alright, first we're going to talk about the error between two curves. When ds slides in, then we have this formula. where y top and y bottom are written in terms of S. Right? So in this situation, it's going to be the vertical rectangle. Right? This one is the height. This one is the width. The height is the distance between the y top and y bottom. The width is ds. Right? Now, similarly, dy slicing, you have this formula where s right and s left are written in terms of y, right? And in this situation, you have the horizontal rectangle. Now, first, we need to sketch the region and draw a representative rectangle to be used in determining whether setting up with respect to ds or dy. Determine the slicing direction. Then find the volume of the slide, which will be the area of the face times the thickness. Determine the total volume by summing up the slides using the definite interval. Lastly, use the volume templates to set up a definite interval. ds slicing, you're going to use this formula, where A of S is the area of the surface written in terms of S. dy slicing, you're going to use this formula, where A of y is the area of the face written in terms of y. Now, the volume of a solid of revolution. First, you need to sketch the region to be revolved and a representative rectangle, whose width can be used to determine whether iterating with ds or dy. Second, set up a definite interval after determining whether the slicing using ds or dy, so that the slicing is perpendicular to the axis of revolution. Lastly, identify the outside radius and the inside radius and use the appropriate template from below. Now, this method, ds slicing v equals pi times the interval from left s to right s radius squared ds. Now, dy slicing, we're going to use this formula. Now, next one, the washer method. You're going to use this formula if ds slicing, and this formula if dy slicing. Now, let's take a look at the first example. The region enclosed by the x-axis, the line s equals 3, y equals square root of s, is rotated about the x-axis. What is the volume of the solid generated? Right? So we're gonna sketch the figure first, right? So it's gonna be something like this. Now this region right here rotate about the x-axis, so it becomes this solid right here, right? Now we can draw the circle. So the cross section perpendicular to the x-axis is a circle, right? So you have the radius is distance from here to here, right? Alright, so the radius is changing, right? So it could be the function y equals square root of s subtract this one y equals 0, right? So it could be square root of s subtract 0. It could be square root of s, right? Now you need to find the area of this circle. So the area is going to be pi r square, right? So it could be pi times this one square is going to be s, right? So the volume is going to be interval from left to right, right? So this is 0 and this one is 3, right? So it could be from 0 to 3. This one, right? A of s ds, right? So it could be interval from 0 to 3. Pi s ds, right? So it could be pi over 2s squared evaluated from 0 to 3, right? So it could be 9 pi over 2. So the answer should be C. Now let's move on to question 2. Find the area of the regions bounded by the lines x equals 0, x equals 2, y equals 0, and the curve y equals e to the x over 2. So we're going to sketch this one. to 0. And y equals 0, this is going to be the x-axis, y equals 0, right? The y-axis is going to be s equals 0, so keep that in mind. Alright, so we need to find the error of these regions right here, right? And it's very simple, right? So it could be interval from 0 to 2, right? Y top subtract y bottom, right? Y top is y equals e to the s over 2, right? So it could be e to the s over 2 subtract y bottom, which means y equals 0 right here, right? Then you just put the s right here, right? So it's going to be interval from 0 to 2 of e to the 1 over 2 s ds, right? Now keep in mind you have the formula antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c, right? You have antiderivative of sine of a s plus b ds is going to be negative 1 over a of cosine of as plus b plus c, right? And the last one, antiderivative of cosine of as plus b ds is going to be 1 over a of sine of as plus b plus c, right? So keep that in mind. So in this situation, a equals 1/2, right? So if you take antiderivative of this one, it's going to be 1 over a, which means 2, right? E to the 1/2 s, right? Evaluated from 0 to 2, right? So substitute 2 for s, so it could be 2 times e to the 1/2 times 2, it could be 1, right? Subtract e to the 0, right? So it could be 2 times e minus 1, right? So it's going to be C. Now let's move on to question 3. The region bounded by the x-axis, the part of the graph of y equals cosine s between negative pi over 2 and pi over 2 is separated into two regions by the line s equals k. If the area of the regions for negative pi over 2 to k is 3 times the area of the regions for k to pi over 2, then what is the value of k, right? So basically, we just get the graph. The maximum of the cosine function is 1, right? This one is negative pi over 2, and this one is pi over 2, right? So it could be something like this. The line s equals k, so we don't know k. We just put k right here. Alright, so this is the line s equals k. Now I call these regions A1. I call this A2, right? So I have A1 equals 3A2, right? Now I need to calculate A1 first, right? So A1 is the interval from negative pi over 2 to k, right? Y top subtract y bottom. Y top, which means y equals cosine s. Y bottom, y equals 0, right? So it could be cosine s ds, right? So it could be sine s evaluated from negative pi over 2 to k, right? So it could be sine k subtract sine of negative pi over 2 is negative 1, right? So you have negative of negative 1, it should be plus 1. Now A2 is the interval from k to pi over 2, right? Right here. Y top is right here. It's going to be y equals cosine s, right? Subtract y bottom, which means 0, right? So cosine s. So it's going to be sine s evaluated from k to pi over 2, right? So it could be sine of pi over 2 subtract sine of k, right? So it's going to be 1 minus sine of k, right? Now A1 equals 3A2. It's going to be sine of k plus 1 equals 3 times 1 minus sine of k, right? Now, if you simplify this equation, it's going to be 4 sine of k equals 2. Then sine of k equals 1 half. Now take inverse side both sides, so you have k equals sine of 1 half, right? And it's going to be pi over 6, right? So the answer must be C. Now let's move on to question 4. The base of a solid is the region in the first quadrant bounded by the y-axis. The graph of y equals inverse tangent of s. The horizontal line y equals 3. The vertical line s equals 1. For this solid, its cross-section perpendicular to the x-axis is a square. What is the volume of the solid? Right? So we're gonna sketch the figure first, right? And y equals inverse tangent of s. Let's look at the decimals. The red one is the y equals tangent s. The blue one is y equals inverse tangent of s. And these two guys right here reflect over y equals s. Remember, two functions are inverse of each other. They must be symmetric about the y equals s. Now we need to find the volume of the solid, right? So the cross section perpendicular to the x-axis is a square, right? So it's gonna be something like this. Now you need to find the area of the square, right? So area of the square is the side length square, right? Now the side length, this guy is the side length, this guy is still the side length, right? Now the side length is the difference of this guy right here and y equals inverse tangent of s, right? So it's gonna be 3 minus inverse tangent of s squared, right? So the volume should be the integral from 0 to 1 right here of a of s ds, right? So that be integral from 0 to 1 of 3 minus inverse tangent of s squared ds, right? So you're allowed to use the calculator. So you print up the calculator. Add calculator. Now go to menu, calculus, integral right here, 0 to 1. You press enter. The answer is 6.6123. Now let's move on to question 5. The question comes from AB Calculus AB and BC question 1 in 2010 from B. Alright, in the figure above, the region R is the shaded regions in the first quadrant bounded by the graph y equals 4 times ln 3 minus s. It's going to be right here. The horizontal line y equals it, so y equals it is right here. The vertical line s equals 2 is right here. Find the area of the region R. Alright, so basically the area of the region R is the integral from left to right, 0 to 2, right? Y top subtract y bottom. Y top is y equals it. Subtract y bottom is going to be 4 times ln of 3 minus s ds, right? So we're going to bring up the calculator. I'm going to copy this one over here and change the number. That's it. Then you press Ctrl Enter. It's going to be 6.81665. Now question B. Find the volume of the solid generated when R is revolved about the horizontal line y equals 8. Now we're gonna sketch this region. So y equals 8 is gonna be right here. Alright, so if this region revolve the line y equals 8, you're gonna use the washer method because you have a hole in the middle right here. Right? You have the volume of the solid is gonna be the integral from left s to right s, right? And then pi times the outside radius square, right? Subtract pi times the inside radius square, right? ds v equals the integral from left to right, which means 0 to 2, right? I put pi outside, right? Now the outside radius means the radius of the bigger circle, right? So it could be from here to here, right? So it's gonna be y top subtract y bottom. Y top is y equal 8. Y bottom is right here, right? Now subtract the inner radius square. The inner radius is right here, which means the radius of the smaller circle, right? So it's gonna be y top subtract y bottom, which means 8 subtract 6, right? So we just print out the calculator. Then you press Ctrl Enter. It's gonna be 168.8. Now question C. The region R is the base of the solid. For this solid, its cross-section perpendicular to the x-axis is a square. Find the volume of the solid. Alright, so we go back over here. Now we just draw the cross-section. The cross-section perpendicular to the x-axis is a square, right? So it's gonna be something like this. Alright, now you need to find the area of this square, right? So area equals the side length square, right? So the side length is the difference between the line y equals 6 and the bottom one right here, which means this one right here, right? Y top subtract y bottom, right? So you have 6 subtract this guy, right? And then you square, right? So the volume is gonna be, alright, so you just print up the calculator and press Ctrl Enter. It's gonna be 26.2666. Now let's move on to question number 6. Calculator not allowed. This question comes from AP Calculus AB and BC question number 3 from B in 2011. Now the function f and g is given by f of s equals square root of s and g of s equals 6 minus s. Let R be the region bounded by the x-axis. The graph of f and g is shown in the figure above. Find the area of R, right? So since these two functions right here intersect at the points 4 and 2, right? So we just separate this region into two regions, right? The first one is going to be from 0 to 4, and the second one is going to be from 4 to 6, right? So the area of the region R is the integral from 0 to 4, right? Y top subtract y bottom. Y top is y equals f of s, right? Y bottom, which means y equals 0, the x-axis, right? So f of s is right here. It's going to be square root of s, right? ds plus the integral from 4 to 6. Y top is going to be g of s, it's going to be 6 minus s right here, right? So 6 minus s subtract y bottom is going to be 0, right? ds. So it's going to be 2 over 3 s to the 3.5, right? Evaluated from 0 to 4 plus 6s minus 1/2 s squared evaluated from 4 to 6, right? Then we substitute 4 for s. So it's going to be 2 third 4 power of 3.5, right? Substitute 0 for s is going to be 0, right? Plus sit times sit minus 1/2 times sit square, right? Subtract sit times 4 minus 1/2 times 4 square, right? And if you simplify this one, it's going to be 22/3 is the final answer. Now you have the second way to calculate the error of the second one right here faster. Basically, we just calculate the error of this right triangle right here. Base times height divided by 2. The base is 2, right? The height is 2, right? So 2 times 2 divided by 2 is going to be 2, right? So this guy right here, actually 2/3 times 8 plus 2. So the answer is 22/3. Now question B. The region R is the base of a solid. For each y value, y from 0 to 2, the cross-section of the solid taken perpendicular to the y-axis, be careful, okay, is a rectangle whose base lies in the region R and whose height is 2y. Right, but do not evaluate an integral expression that gives the volume of the solid, right? So the cross-section is perpendicular to the y-axis. Now the area of the rectangle is going to be base times height, right? Now since the cross-section perpendicular to the y-axis, you need to convert every single thing in terms of y, right? Now the base right here is the difference between G of s and F of s, right? Right, subtract, left, keep that in mind. Alright, now G of s is right here, right? So we have y equals 6 minus s. You need to rewrite s in terms of y, right? So we have s equals 6 minus y, right? Now F of s right here is going to be y equals square root of s, square both sides, so you have y squared equals s, right? So s equals y squared, right? Now right subtract left, right, which means 6 minus y, right? So it could be 6 minus y. Subtract left, left is going to be minus y squared right here, right? The height is given, it's going to be 2y, right? So the error is going to be base, it's going to be 6 minus y squared times 2y, right? And the bound is from 0 to 2 right here, right? Remember, you need to use the lower limit and upper limit of the y values. Keep that in mind. So I have volume equals the integral from 0 to 2 of 6 minus y squared times 2y dy, right? And I'm going to simplify this one. It's going to be integral from 0 to 2. Distribute this one is going to be 12y minus 2y squared minus 2y cubed dy, right? So it's going to be y times y squared over 2, right? Minus 2/3y cubed minus 2/4y to the 4, evaluated from 0 to 2, right? 12 divided by 2 is going to be 6, so you have 6y squared minus 2/3y cubed minus 1/2 y to the 4, evaluated from 0 to 2, substitute 2 for y, so it's going to be 24 minus 16/3 minus 8. So it could be 16 minus 16/3, right? So it could be 32/3. Now let's move on to question C. There is a point P on the graph of F at which the line tangent to the graph of F is perpendicular to the graph of G. Find the coordinates of the point P. Alright, so suppose point P is right here, and then you have the tangent line, it's going to be like this. Now we need to find the coordinate of point P. In order to do that, we need to find the slope of the tangent line, right? Now, since this line and this line perpendicular, their slope product equals -1, right? The slope of this function is -1 right here, right? So m equals -1. The slope of this function right here, we just take derivative of this guy right here, right? So we have f prime of s equals 1 over 2 square root of s, right? This guy times this guy must be -1, right? So we have 1 over 2 square root of s times -1 equals -1, right? So it could be 1 over 2 square root of s equals 1, right? Then 2 square root of s equals 1, right? And then square root of s equals 1/2. Square both sides, s equals 1 over 4. Right? Now substitute 1 over 4 for s into the graph fs right here. So you have f of 1 over 4 equals square root of 1 over 4. It's going to be 1/2, right? So the coordinate point P is 1 over 4, comma 1/2, right? Now let's move on to question 7. This question comes from AP Calculus AB and BC question 1 in 2007. Let R be the region in the first and the second quadrants bounded by the graph y equals 20 over 1 plus s squared and below by the horizontal line y equals 2. So basically we need to sketch this one. Now we need to find the intersection right here, and right here, right? This one is the y-intercept, right? We just let s equal 0, right? So when s equals 0, y equals 20. Now we need to find the intersection between the graph right here and the line y equals 2, right? So we just have 20 over 1 plus s squared equals 2. It's the same thing as 2 plus 2s squared equals 20, right? And then it's going to be 2s squared equals 18, right? And s squared equals 9. S equals plus and minus 3, right? So this one is -3. This one is 3, right? Now question 9, find the error of the region R, right? So basically we have the error is going to be the interval from -3 to 3. Top subtract bottom, right? Top which means this guy. Bottom which means y equals 2, right? So we have 20 over 1 plus s squared subtract 2, right? ds. Now you're going to print up the calculator. Press Ctrl Enter to approximate the value, right? So it should be 37.9618. Now question B. Find the volume generated when the region R is rotated about the x-axis. Alright, so when this guy rotated about the x-axis, you see the hole right here. Right? So you need to use the washer method, right? So the volume formula is given by pi times the integral from -3 to 3, right? -3 to 3 of outside radius square minus inside radius square ds, right? Alright, so outside radius is the bigger radius. It's going to be from here to here, right? So y top subtract y bottom. Y top is y equals 20 over 1 plus s squared. Y bottom is y equals 0 right here, right? So it's going to be pi, the integral from -3 to 3 of 20 over 1 plus s squared all together square, right? Subtract y bottom. Y equals 0, so I don't need to write it, right? Now the inside radius square is going to be this guy right here, right? Y top is y equal 2, y bottom is y equal 0, right? So it could be 2 subtract 0 is going to be 2 so square, and then you put the s right here, right? I'm going to print up the calculator, enter to approximate the value, right? So it's going to be 1871.19. Now let's move on to question C. The region R is the base of the solid. For this solid, the cross-section perpendicular to the x-axis and semicircle. Find the volume of this solid, right? So we go back over here. The cross-section is the semicircle perpendicular to the x-axis, right? So it could be something like this. Alright. Now, you need to find the area of this semicircle, right? So in order to find the area of the semicircle, you need to find the diameter, right? So diameter is the distance from the function right here and the function right here, right? Top subtract the bottom, right? So it can be 20 over 1 plus s squared subtract 2, right? And then you need to find the radius. It could be 1/2 of this guy, right? 20 over 1 plus s squared minus 2, right? Alright, so now you need to find the error. So error is going to be 1/2 pi r squared, right? So substitute value 1/2 pi times this guy right here, 1/2 times 20 over 1 plus s squared minus 2 altogether squared. The volume of the solid is going to be the integral from -3 to 3 of a of s ds, right? So it can be integral from -3 to 3. A is right here. So I put pi over 2 in the front, right? 1/2 square, it turns out to be 1/4, right? So it should be pi over 8. And then I only have 20 over 1 plus s squared minus 2 altogether squared ds, right? Now we're going to print up the calculator. So I'm going to use this one. I just copy this one down here. This one should be pi over 8. Integral from -3 to 3. 20 over 1 plus s squared minus 2. And then press Ctrl Enter. The answer approximately 174.268. Now let's move on to question 8. This question comes from AP Calculus AB and BC question number 6 from B in 2004. Let L be the line tangent to the graph of y equals s to the n, right? So the curve right here is y equals s to the n. At the point 1, 1 right here, where n greater than 1 as shown above. Find the integral from 0 to 1 s to the n ds in terms of n. So this one very simple, right? So it can be s to the n plus 1 over n plus 1 evaluated from 0 to 1. So it could be 1 over n plus 1, right? Now question B, let T be the triangular region bounded by the line L. The x-axis, the line s equals 1. Show that the area of T is 1 over 2n. Alright, so this region T is right here. Now, since line L tangent to the graph y equals s to the n at this point right here, we need to find the slope of line L, right? So the slope of line L is FRQs of s, right? Evaluated at 1, 1, right? So take the derivative of this one is going to be n times s to the n minus 1. So substitute 1 for s is going to be n, right? Now we have the second way to find the slope of line L. It's going to be rise over run, right? Now rise is right here. It's going to be 1 right here. Run, I'm going to let this one be b, right? So this is b, right? Now this guy and this guy right here must be the same, right? So we have 1 over b equals n. So then b equals 1 over n, right? Now the area of the triangle T is 1/2 base times height, right? 1/2 times 1 over n times the height is 1 right here. So the answer is 1 over 2n. Then this one has been proved, right? Now question C. Let S be the region by the graph of y equals s to the n. The line L and the s-axis express the area of S in terms of n and determine the value of n that maximize the area of S, right? So the region S is right here. Now we know that the area of the region S is the interval from 0 to 1 of s to the n ds, right? The function right here. From 0 to 1 right here, right? The error under the curve. Subtract the error of the region T right here, right? The error of the triangle, which is you calculated in question B. It's going to be 1 over 2n, right? But this one you calculated in question A. It's going to be 1 over n plus 1, right? So it's going to be 1 over n plus 1 subtract 1 over 2n, right? Now the question says we need to find the value of n that maximize the error of this one, right? So we just let this one as the function f of n. Now when it comes to minimum, maximum, increasing or decreasing of the function, we need to find the first derivative. So keep that in mind. So I have f prime of n is -1 times n plus 1 power of -2 minus -1 times 2n power of -2 times 2, right? So if we simplify this one, it's going to be -1 over n plus 1 altogether square, right? Plus 2 over 2n altogether square. Now we're going to let this one equals to 0 to find the critical number, right? So f prime of n equal to 0 is the same thing as 2 over 2n altogether square equals 1 over n plus 1 altogether square, right? So it's going to be 1 over 2n square equals 1 over n plus 1 altogether square, right? The top 1 and 1 the same, the bottom must be the same. So you have 2n square equals n plus 1 altogether square, right? Now take square root both sides. So we have n square root of 2 equals n plus 1, right? And n square root of 2 equals -n minus 1, right? So we just solve for n. So it will be n equals 1 over square root of 2 minus 1, right? And this one n equals -1 over square root of 2 minus 1, right? We look at the domain right here, n must be greater than 1, right? So we need to eliminate this guy right here because this one is negative number, right? So we have n equals 1 over square root of 2 minus 1. Radicalize this one, so it could be 1 times square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1, right? So n equals square root of 2 plus 1, right? Now we're gonna sketch the side charts. We pick number 2 right here, right? Substitute over here. So we have -1 over 2 plus 1 is going to be 3 squared, it could be 9, right? Plus 2 over 2 times 2, it could be 4 squared, it could be 16, right? And of course, this one is positive, right? So this interval should be positive, this interval should be negative. Alright, so the function is increasing over this interval and decreasing over this interval, right? So we need to say that f prime of n changes sign from positive to negative at n equals √2 plus 1. Then the only critical values is √2 plus 1. Now let's move on to question 9. This question comes from AB, Calculus AB and BC, question 1 in 2008. Let R be the region bounded by the graphs of y equals sine of pi s and y equals s cubed minus 4s as shown in the figure above. So, of course, you look at this one, the top one should be y equals sine of pi s, right? The bottom should be y equals s cubed minus 4s, right? Now find the error of the region R, right? So the error equals the integral from 0 to 2, right? Y top subtract y bottom, right? So we have sine of pi s subtract s cubed plus 4s. Be careful, right? You need to distribute -1, right? ds. And then you just print up the calculator. And then you press Ctrl Enter. It's going to give you exact value 4, right? Now let's move on to question B. The horizontal line y equals -2 splits the region R into 2 parts, right? But do not evaluate an integral expression for the error of the part of R that is below this horizontal line, right? So the horizontal line is y equals -2 right here. Right? Now you need to find the intersection right here, right? So basically you just equate this guy and this guy to find the intersection, right? So does that mean you have s cubed minus 4s equals -2, right? And then s cubed minus 4s plus 2 equals 0, right? So you just let f of s equals s cubed minus 4s plus 2 and you find the 0 of this one, right? So I'm going to bring up the calculator. I'm going to go to the home screen, hit graph. Now I'm going to press tab. I need to go to F1 right here. Now I need to change this one to s cubed minus 4s plus 2 and press enter. It's going to be right here, right? And you need to find two intersections. Since the s value right here is positive, right? So you have 3 zeros right here. You only pick 2 positive zeros right here, right? So I'm going to press menu, analyze graph, and 0 right here. Go to the left, go to the right. You have the first 0. It's going to be 0.593, right? Do exactly the same thing. Menu, number set, number 1. Go to the left, go to the right. You have the second 0 right here. So it's going to be 0.593 and 1.68, right? You have the error equals the integral form, right? Y top subtract y bottom. Y top is -2. Y bottom is s cubed minus 4s, right? So you subtract s cubed plus 4s ds, right? This one is the error of these regions right here. Now question C. The region R is the base of the solid. For this solid, its cross-section perpendicular to the x-axis is a square. Find the volume of this solid. Right. Now, the cross-section perpendicular to the x-axis is a square. So, you have a square right here. Alright, so error is sine square because this one is the square. So, it will be sine times sine, right? Sine is the distance from the top graph and the bottom graph, right? So, it's going to be top one is right here. Sine pi s subtract the bottom one is right here, right? So s cubed plus 4s all together square, right? And the integral from 0 to 2, right? So question C is going to be v equals the integral from 0 to 2a of s ds, right? And it's going to be integral from 0 to 2 of sine pi s subtract s cubed plus 4s square ds, right? Now we're going to bring up the calculator. Press the button right here. From 0 to 2 of sine pi s and press Ctrl Enter. It's going to be 9.978. Now, question D. The region R models the surface of a small pond. at all points in region R at a distance s from the y-axis. The depth of the water is given by h of s equals 3 minus s. Find the volume of the water in a pond. Alright, so this one is exactly the volume of the solid whose cross-section is the rectangle where the height is 3 minus s. The base is the difference between the top and the bottom graphs right here, right? So we're going to use exactly the same thing right here. Instead of the square right here, it's going to be the rectangle, right? So you have the height is right here, right? And the base is right here, right? The base is the distance between this graph right here and this graph right here, right? So you have v equals the interval from 0 to 2, right? Of the cross section a of s ds, right? And it's going to be interval from 0 to 2. A of s is the area of the rectangles, right? Base times height. The base is the distance between this guy, so it's going to be sine of pi s subtract s cubed plus 4s times the height is going to be 3 minus s, and you put the s right here. And print up the calculator. I'm going to copy this one down over here and to change the number. Three minus s close parenthesis. Press Ctrl Enter. It's going to be 8.36995. Let's move on to the next section, particle motion. You need to understand the expression and mathematical translation. Alright, initial position, velocity, or acceleration of the particles. It means t equals 0. It's going to be s of 0, v of 0, or a of 0. Now, the particle is at position s equals s1 at time t equals t1. So you have s of t1 equals s1, right? Now, the particle is at rest means the velocity equals 0. Particles moving to the right means velocity greater than 0. Particle moving to the left means velocity less than 0. The average velocity of the particle on the interval a and b is to be 1 over b minus 8, interval from a to b of v of t dt, right? So it will be 1 over b minus a anti-derivative of v of t, which means s of t, right? This is a position function, and it's going to be s of b minus l of a over b minus a. The instantaneous velocity of the particle at time t equals t1 is going to be v of t equals s prime of t, right? Acceleration of the particle at time t equals t1 is going to be. Now next one, velocity of the particle is increasing. It means the derivative of the velocity is positive, right? So a of t equals v prime of t is greater than 0. Velocity of the particles is decreasing, v prime of t less than 0, right? The speed of the particles. The speed is the absolute value of the velocity. The speed of the particle is increasing or the particle is speeding up. It means v of t and a of t have the same sign. In other words, v of t times a of t is always positive, right? Now the speed of the particle is decreasing or the particle is slowing down. It tells us that v of t and a of t have the opposite sign, or v of t times a of t is always less than 0, right? The total distance traveled by the particle over the time interval a to b is to be interval from a to b of absolute value of v of t dt. Now, displacement of the particles or the net distance traveled by the particle over the time interval a to b is to be interval from a to b of v of t dt. Position of the particle at time t equals t2. So s of t2 equals the initial position s of t1 plus the interval from t1 to t2 v of t dt, right? Now the particle changes direction. This occurs when the velocity of the particles changes from positive to negative or from negative to positive. Particle is farthest to the left or to the right. you need to find the minimum or maximum value of s of t over the interval. Find the value of t squared s prime of t1 equals v of t1 equals 0. The critical points of s. Consider the position of the particle at the critical points and if the interval is closed at the endpoints of the interval. So basically, in this situation, we mostly use the candidate test, right? Alright, now let's move on to question 1. A particle moves along the x-axis with the velocity given by the v of t equal 3t squared plus 6t for t greater than or equal to 0. If the particle is at position s equal 2 at time t equals 0, what is the position of the particle at time t equals 1, right? So you have the formula s of t2 equals s of t1 plus the integral from t1 to t2 v of t dt, right? So it's going to be s of 1 equals s of 0, right? This one is t1. This one is t2, right? Plus the integral from 0 to 1 v of t dt, right? So s of 0 equals 2 right here, right? So you have 2 plus integral from 0 to 1 v of t given this one. And then it's going to be 2 plus t cubed plus 3t squared evaluated from 0 to 1, right? So it could be 2 plus, substitute 1 for t, right? So it could be 1 plus 3, right? And the answer is going to be 6. So answer choice B. Now let's move on to question 2. A particle travels in a straight line with a constant acceleration of 3 meters per second per second. If the velocity of the particle is 10 meters per second at time t equals 2 seconds, how far does the particle travel during the time interval when its velocity increases from 4 meters per second to 10 meters per second, right? The question asks you how far, which means position, right? S of t. In order to find this one, you need v of t, right? And in order to find v of t, you need a of t, right? So you have the particle travels in a straight line with a constant acceleration 3 meters per second, right? So we have a of t equals 3. Then v of t equals antiderivative of a of t, right? Which means 3 dt, right? And it's going to be 3t plus c, right? And we use the condition right here, right? So we have v of 2 equals 10. Substitute over here to solve for c, right? So you have 10 equals 3 times 2 plus c, then c equals 4, right? So v of t equals 3t plus 4, right? Now, we given the velocity increases from 4 meters per second to 10 meters per second, right? We substitute over here, we solve for t, right? So we have v of t equals 4. Then you have 3t plus 4 equals 4. And then t equals 0, right? V of t equals 10. Then 3t plus 10 equals 4. Then t equals 2, right? Then in order to find s of t, we need to take antiderivative of v of t, right? So s of t equals antiderivative of v of t dt, right? And then we have the interval from 0 to 2, so we put 0 to 2 right here, right? Now, the question says how fast does the particle travel during the time interval, right? Asks you to find the total distance, so you need to put the absolute value of v of t right here. Alright, so it's going to be integral from 0 to absolute value of 3t plus 4 dt, right? So it's going to be 3 over 2 t squared plus 4 t evaluated from 0 to 2, right? So it could be 3 over 2 times 4 plus 4 times 2, and it's going to be 6 plus 8, and it's going to be 14, right? So the answer must be B. Question 3. If the position of the particles on the x-axis at time t equals negative 5t squared, Then the average velocity of the particles for 0 to 3 is, so we have the average velocity is s of 3 minus s of 0 over 3 minus 0, right? Now the position is s of t equals negative 5 t squared, right? So we have negative 5 times 3 squared minus negative 5 times 0 squared over 3, right? So it could be negative 45 over 3. It could be negative 15, right? The answer must be C. Now let's move on to question 4. The table below gives selected values of the velocity v of t of a particle moving along the x-axis at time t equals 0. The particle is at origin. Which of the following could be the graph of the position, so s of t, of the particle for 0 to 4, right? So we look at this one, we see that the first order pair right here tells us that v of 0 equals negative 1, which is less than 0, right? So remember, velocity is the first derivative of the position function, or it could be the slope of the tangent line, right? At s equals 0, right? So right at s equals 0 right here, the velocity is negative, right? So we draw the tangent line right here. We use the Christmas tree trick. If the line is going up, the slope is positive. Line is going down, slope negative. Line is horizontal, slope is 0. Line is vertical, slope is undefined, right? Now tangent line is going up, so slope is positive. Tangent line is right here going up, the slope is positive, right? This one, tangent line is going down, so the slope is negative. Tangent line is going up, the slope is positive. Tangent line is going down, the slope is negative, right? Now we need this one to be negative, right? So we need to eliminate A, B, and D, right? We're going to use the second order pair right here. So we have V of 1 equals 2. So it tells us that the position function is increasing at t equals 1, right? So at t equals 1, it's going to be right here, and it's going to be right here. This guy is increasing because the slope is positive, right? This guy is either decreasing or constant, because the slope right here could be 0, right? It could be horizontal tangent line, right? So you need to eliminate E. Now we're going to check the remaining order pair. V of 2 equals 3. So it's going to be positive. The function is increasing at t equals 2. 2 right here, yes, it's increasing. T equals 3, so you have V of 3 equals 0, right? So 3 right here. You see the horizontal tangent line right here, right? The slope is 0, right? And the last one, V of 4 equals negative 4, which is negative. The function is decreasing, yes. At 4 here, the function is decreasing, the slope is negative, right? So the answer choice C is correct. Now let's move on to question 5. A particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given by v of t equals 3 plus 4.1 cosine 0.90. What is the acceleration of the particle at time t equals 4? So you know that acceleration is the first derivative of the velocity, right? So it's going to be 4.1 times 0.9 sine of 0.9 t. Don't forget to have the negative side right here, right? So A of 4 equals negative 4.1 times 0.9 sine of 0.9 times 4, right? So we're going to print up the calculator. Make sure your calculator in the radian mode. So you're going to check this guy right here. It should be radian, right? So you have negative 4.1 times 0.9, and then check his side right here of 0.9 times 4, it could be 3.6, right? And then press Control Enter. It's going to give you approximate value 1.6329, right? So you're gonna grab this one. The answer is C. Let's move on to question 6. two runners A and B run on a straight track for t from 0 to 10 seconds. The graph below, which consists of two line segments, shows the velocity in meters per second of runner A. The velocity in meters per second of the runner B is given by the function v divided by v of t equals 24t over 2t plus 3, right? Question A. Find the velocity of runner A and the velocity of runner B at time t equals 2. So t equals 2 right here, right? This point is on this line, right? So we need to find the equation of this line first, right? So we have v of t equals ms plus b, right? The graph of this function past origin, so b equals 0, right? So it could be ms only, right? Now we're gonna use rise over run to find the slope, right? So rise is 10, run is 3, right? So the slope is 10 over 3, right? So v of t equals 10 over 3t, right? So the value of s right here in this situation is going to be t, right? Velocity of the runner A is 10 over 3 times 2, right? Because you can substitute 2 for t into this function, right? So it's going to be 20 over 3 meter per second, right? The velocity of runner B is, use this function right here, right? So you have 24 times 2 over 2 times 2 plus 3 is going to be 48 over 7 meter per second, right? Now question B. Find the acceleration of runner A and the acceleration of runner B at time t equals 2. You know that acceleration is the first derivative of the velocity, right? So I have A of A. It's going to be v prime of A at 2, right? So you put 2 right here, right? Now take derivative of this one. It's going to be 10 over 3, right? So it could be 10 over 3 meter per second square, right? Now acceleration of runner B at t equals 2 is going to be v prime of B at 2, right? Now you need to take derivative of this guy right here. So you're going to use the quotient rule, right? So we have 24 times 2t plus 3, right? Minus 2 times 24t over 2t plus 3 altogether square, right? So I have 24 times 2 times 2 plus 3 minus 2 times 24 times 2 over 2 times 2 plus 3 altogether square, right? So it's going to be 24 times 2 times 2, it could be 4, 4 plus 3, it could be 7, minus 96, right, over 49, right? 24 times 7 is going to be 168, minus 96 over 49, right? So it's going to be 72 over 49 meter per second square. Now question C. Find the total distance run by runner A and total distance run by runner B over the interval 0 to 10 seconds. We have the total distance of runner A equals the interval from 0 to 10 of absolute value of V of T of A dt, right? So we look at the graph right here. We just calculate the error under the curve, right? So this one is the triangle and this one right here is the rectangle, right? So it could be 3 times 10 divided by 2. Plus this guy right here is 7, right? This guy right here 10, right? So 10 times 7. The answer is 85 meter, right? Now, distance the runner B travel. It's going to be integral from 0 to 10 absolute value of V B of T dt, right? So we have the integral from 0 to 10 of 24t over 2t plus 3 absolute value of this one dt, right? So we're going to bring up the calculator. Alright, so we're going to hit this button right here, pick the integral right here. Integral from 0 to 10 of absolute value. So we hit the button right here, pick the absolute value side. Hit this button, put the fraction. Control, enter. It's going to be 83.336, right? Now let's move on to question 7. A particle moves along the y-axis with velocity given by this guy for t greater than or equal to 0. In which direction, up or down? Is the particle moving at time t equals 1.5. So we have v of 1.5 equals 1.5 times sine of 1.5 altogether square, right? And you're going to print up the calculator. You have 1.5 times check sine of 1.5 square. Press enter. It's going to be 1.167, which is greater than 0, right? So if it's greater than 0, it tells us that the particle moving up, right? Now question B. Find the acceleration of the particle at t equals 1.5, right? So we have a of 1.5 equals v prime of 1.5, right? So we're going to print up the calculator. We just store the function, right? So you're going to press v of t. Then you're going to press control this button right here. Then it's going to be t times sine of t square. Alright, you press enter, done. Now keep in mind you need to put the multiplication between t and sine. If you don't do that, the calculator won't understand that, right? Now you need to calculate v prime of 1.5, right? So you're gonna press the button right here, this guy right here. Alright, so we put t, variable t, right? Right here you just put v of t. Now you're gonna press control equals and put the line right here. Press t equals 1.5. You press enter. It's gonna give you the values negative 2.0487. Is the velocity of the particle increasing at time t equals 1.5? This guy less than 0. So you need to say no, because a of 1.5 less than 0, right? Question C. Given that y of t is the position of the particle at time t and that y of 0 equals 3, we need to find y of 2, which means y of 2 equals initial position is going to be y of 0 plus the integral from 0 to 2, right? This guy right here and this guy right here tells us that the interval from 0 to 2 of v of t dt, right? So it could be y of 0 is going to be 3 plus the integral from 0 to 2. V of t is going to be t times sine of t square dt, right? So we're going to print up the calculator. Now we already stored the function v of t, right? So now we just press this button right here. Then we're going to pick the integral It's going to be from 0 to 2 of v of t dt. Alright, and you press enter. Now you need to convert this value into the decimal. You press Control enter. It's going to give you 0.826822. And then you need to add 3. Press enter. It's going to be 3.8268, right? Now question D. Find the total distance traveled by the particle from t equals 0 to t equals 2. Right? So the total distance equals the number from 0 to absolute value of v of t dt. Right? So we're gonna print out the calculator right here. We just copy this one down over here. Alright? We just put this guy inside the absolute value side, right? So we just highlight this one, press the button right here, hit this guy right here, right? And then press Control enter. It's gonna be 1.17318, right? Now let's move on to the last topic, rate in and rate out problems. Question 1. A popular 24-hour health club has 29 people using its facility at time t equals 0. During the time interval from 0 to 20 hours, people entering the health club at a rate given by the function right here. During the same time period, people leaving the health club at the rate of this guy. Question A. Is the number of people in the facility increasing or decreasing at time t equals 11? This one is entering, right? And this one is leaving, right? Now we need to calculate E of 11. And then L of 11, right? Now we need to print up the calculator. We need to store the function. First, we need to store E of t. Press Control the button right here. Then we're going to input negative 0.018 t squared plus 11. And then press enter, right? And then we need to store the leaving function, right? So L of t equals this guy, right? So we need to press Control this button right here and then type 0.013 t squared minus 0.25 t plus 8 and then press enter. Now we need to calculate E of 11, right? So we have E parenthesis 11. Press enter. It's going to be right here. And L of 11. Press enter. It's going to be right here, right? So E of 11 is 8.822 and L of 11 is going to be 6.823, right? From these two guys, we can conclude that E of 11 is greater than L of 11, right? It tells us that the number of people in the facility is increasing. Now let's move on to question B. To the nearest whole number, how many people are in the health club at time t equals 20? Alright, so we have P of 20 equals P of 0, right? This one is the initial one, plus the interval from 0 to 20 of E of t dt, right? This one is the number of people entering the building. Subtract the number of people leaving the building, right? We look at this one right here at t equals 0, we only have 29 people, right? So we're going to print out the calculator. We have 29 plus, hit the button right here, and then press this guy. The interval from 0 to 20 of E of t dt. Then you're gonna subtract L of t, right? Because both functions have the same upper bound and lower bounds, right? And then you just press Control Enter. It's gonna give you 56.33, but you need to round to the nearest whole number, right? So the answer is approximately 56 people. Now question C. At what time t for t from 0 to 20 is the amount of people in the health club maximum? Now we need to use the candidate test, right? This one is the closed interval 0 to 20. Now we have the function p of t is p of 0 is going to be 29 plus the interval from 0 to t e of s ds, right? Minus the interval from 0 to t of L of s ds, right? Now, in order to find the maximum value, we need to take the derivative of function p of t, right? So you have p prime of t equal derivative of this one equals 0. Derivative of this one, you just print t over here, right? So you have e of t minus L of t, right? Print this one over here. Now, you need to let this one equal to 0. So it's the same thing as e of t equals L of t, right? Now, you need to find the intersection between e of t and lt, right? So you're gonna print up the calculator. You're gonna press home screen, go to the graph, negative 0.018 s square plus 11. Press enter. You couldn't see the graph, so you need to go to menu, window zoom, window setting right here. Now the s value is 0 to 20. The y values is to be negative 30 to 30. Press enter. It's going to be right here. Right. Now we do exactly the same thing for the second function, right? So we're gonna press tab 0.013 s square minus 0.25 s plus 8. Press enter. It's gonna be right here. Alright, so we're gonna find the intersection between this guy and this guy, right? So we're gonna press menu, analyze graph, and intersection right here. Go to the left, go to the right, the answer is right here. 14.7, right? Now we're gonna use the candidate test. So we get the table. Now we're gonna place t equals 0, t equals 14.7, and t equals 20, right? At t equals 0, this guy equals 0, this one equals 0, you have 29, right? T equals 14.7, you're gonna plug it in over here. So we're gonna print up the calculator. Press home screen, go to calculate. Now you have 29 plus the interval from 0 to 14.7, right? And I press enter. It's gonna be 67.2872. Now we need to find P of 20. So we print up the calculator again. P of 20 is right here, 56.333, right? Now the maximum value is this guy right here, right? So we need to say the number of people is maximum at t equals 14.7 hours. Now let's move on to question D. If the health club has less than 10 people using its facility, the owner will serve everyone a special health drink. Set up but do not solve an inequality involving one or more intervals that could be used to find the time h when the number of people in health club is less than or equal to 10. Alright, so this one very simple. We just use the equation right here. Alright, we just replace t right here with h right here, right? So we have p of h equals 29 plus the interval from 0 to h. E of t subtract L of t dt. And this guy must be less than or equal to 10. That's it, right? Question 2 right here, similar to question 1. I'm going to leave this one for you to practice. I just give you the answer. The answer for question A is 510.1599 cos. The answer for question B is E prime of 5 is negative 1.6273. Now question C. The answer is 65.103 cos. Now question D. The maximum number of cars in the parking garage is 65 cars. We're going to review Unit 9, Part 1 of AP Calculus BC, Parametric and Vector Equations. Question 1. If s equals t squared and y equals ln t squared plus 1, then at t equals 1, d squared y over ds squared is. Alright, so the first thing you need to do is to take the derivative of this function with respect to t, right? So it could be s prime of t, right? So it could be 2t, right? Now we're going to take the derivative of this one with respect to t. So it could be dy over dt equals. We need to use the chain rule, right? So derivative of ln u. It could be u prime over u, right? So this guy becomes 2t over t squared plus 1, right? Now, in order to find the second derivative of this one, we need to find the first derivative, right? So we have dy over ds equals. Divide the top bottom by dt. So we have dy over dt over ds over dt, right? Now dy over dt is going to be right here. So you have 2t over t squared plus 1 divided by ds over dt is going to be this guy, 2t, right? Now we're going to multiply the top bottom by t squared plus 1. This guy and this guy cancel out, right? And then this guy cancel out, right? So we have 1 over t squared plus 1, right? Now we need to calculate the second derivative, which means we need to find the first derivative of this one, right? So we have d over ds of dy over ds, right? Now this guy is the same thing as d of dy over ds, right? Now you're going to divide the top bottom by dt. So it could be, now on the top we need to take the derivative of this one with respect to t, right? So it's going to be right here, right? So we're going to use the quotient rule, right? U over v prime is going to be u prime v minus v prime u over v squared, right? So this guy becomes derivative of 1 equals 0 multiplied by this one is going to be 0, right? Minus 2t, right? Times 1 is going to be negative 2t over t squared plus 1 altogether square over ds over dt is given right here, right? So you have 2t. Now you're going to multiply the top bottom by t squared plus 1 altogether square. So this guy cancel out, right? This guy cancel out. So the answer is negative 1 over t squared plus 1 altogether square, right? Now we substitute 1 for t into this guy right here, right? So we have negative 1 over 4, right? So the answer is A. Now let's move on to question 2. For any time t greater than or equal to 0, if the position of the particle in the xy plane is given by this guy and this guy, then the speed of the particle at time t equals 1 is. Alright, so we know that the speed is given by the formula square root of s prime of t square plus y prime of t square. Right? Now we need to check the derivative of this one with respect to t. So we have s prime of t equals e to the t, right? And y prime of t equals negative e to the negative t, right? So we substitute over here. So it's going to be square root of e t squared. So it could be e to the 2t, right? Plus this one square is going to be e to the negative 2t, right? Now we substitute 1 for t into this expression right here. So we have square root of e squared plus e to the negative 2, right? Now we're going to bring up the calculator, press Control and the button right here to put square root sign, right? And e squared plus e to the negative 2. Press Control Enter. It's going to be 2.743, right? So the answer is B. Now question 3. The length of the curve determined by the parametric equation s equals sin t, y equals t for t from 0 to pi is. So in order to find the length of the curve, we need to use the formula, the integral from 0 to pi, right? Look at this one right here. Of square root of s prime of t square plus y prime of t square, right? dt. Alright, so we need to find s prime of t first. It's going to be cosine t, right? And y prime of t is going to be 1, right? So we substitute over here. We have the integral from 0 to pi square root of cosine square of t plus 1 dt, right? So the answer must be A. Now question 4. Consider the curve in the xy plane represented by s equals 2 over t, y equals ln t for t greater than 0. The slope of the tangent line to the curve at the point where s equals 1 is. Alright, the slope which means dy over ds, right? So we need to take the derivative of this one first. So s prime of t is the same thing as ds over dt, right? So it's going to be negative 2 over t squared, right? And dy over dt actually y prime of t, right? So it could be 1 over t. Now dy over ds, we need to divide the top and bottom by dt. So we have dy over dt divided by ds over dt, right? So dy over dt is going to be 1 over t. ds over dt is going to be negative 2 over t squared, right? Now we need to multiply the top and bottom by t squared, right? This guy cancel out, so it's going to be t on the top. The bottom, this guy cancel out, it's going to be negative 2, right? So it's going to be the slope is dy over ds equals negative t over 2, right? Now s has equal 1. We substitute over here to solve for t, right? So we have 1 equals 2 over t, so t equals 2. Then we substitute 2 for t into this one right here to find the slope, right? So the slope equals negative 1. So the answer must be A. Now question 5. A curve is defined parametrically by s equals e to the t and y equals 2 e to the negative t. An equation of the tangent line to the curve at t equals ln is, right? So we need to find the slope first, right? So we need to find s prime of t equals e to the t and y prime of t equals negative 2 e to the negative t, right? So we need to find the slope dy over ds equals dy divided by dt over dx divided by dt, right? We just divide the top bottom by dt, right? Now we need to utilize this one right here. dy over dt is going to be right here. So you have negative 2 e to the negative t, and dx over dt is going to be right here, e to the t, right? Alright, now we're going to simplify this one. I bring this one down to the bottom, so it's going to be negative 2 over e to the 2t, right? Now at t equals ln 2, so the slope should be dy over dx at t equals ln 2. It's going to be negative 2 over e to the 2 ln 2, right? So remember you have log base a of b, and then you have k right here. You can bring k back over here. This could be log base a of b power of k, right? So I can bring 2 back over here. So I have negative 2 over e to the ln of 2 power of 2 is going to be 4, right? Now I have the formula a to the log base a of b equals b, right? In this situation, a equals e, so I have e to the ln of 4 should be 4, right? So this guy should be negative 2 over 4, and it's going to be negative 1/2, right? Now I need to find the order pair, right? I'm going to substitute ln2 for t into these two guys right here to find s and y, right? So I have s equals e to the ln 2, right? So it could be 2, right? Now y equals 2 times e to the negative ln 2. So it could be 2 times e to the pre-negative 1 back over here, right? So it could be ln of 2 power of negative 1, right? So it could be 2 times 2 power of negative 1 is going to be 1/2. So it could be 1, right? So the order pair is 2 and 1. The equation is y minus y1 equals m times s minus s1, right? So y1 equals 1. So y minus 1 equals, the slope is negative 1/2 right here, times s minus s1. S1 is right here 2, right? Now let's convert this one to standard form by multiplying both sides by 2. So you have 2y minus 2 equals, distribute negative 1, so it can be negative s plus 2, right? So I'm going to add s both sides, so I have s plus 2y, right? And subtract 2 both sides, so it can be negative 4 equals 0. The answer must be B. Question 6. The position of a particle moving in the xy plane is given by this guy and this guy. What is the speed of the particle when t equals 2? Alright, so remember the speed is given by the formula square root of s prime of t square plus y prime of t square, right? Now this one right here, I need to find s prime of t. It's gonna be 2t plus 2, right? This guy y prime of t is gonna be 4t minus 6, right? So I substitute over here, so the speed should be square root of 2t plus 2 altogether square plus 4t minus 6 altogether square, right? I need to substitute 2 for t into these expressions, right? So I have square root of 2 times 2 is going to be 4 plus 2 is going to be 6, square is going to be 36 plus 2 times 4 is going to be 8, subtract 6 is going to be 2 square, it's going to be 4, right? So it could be square root of 40, right? So it's going to be 2 square root of 10, right? So the answer should be A. Now, question 7. If x equals sine t, y equals cosine square of t, then the second derivative at t equals pi over 2 is, right? So again, we need to find s prime of t is the same thing as dx over dt, right? So it can be cosine t. Now y prime of t is the same thing as dy over dt. So it can be negative 2 sine t cosine t, right? We have dy over dx, divide the top bottom by dt. So you have dy over dt divided by dx over dt, right? So it can be negative 2 sine t cosine t over cosine t. So it can be negative 2 sine t, right? Now we need to take the second derivative, right? So it's going to be d of dy over dx over ds, right? Divide the top bottom by dt. So you have d over dt of dy over dx divided by dx over dt, right? Now take the derivative of this one with respect to t. So it's going to be negative 2 cosine t. Now the bottom derivative of s with respect to t, so it can be right here, cosine t. So the answer is negative 2, right? In this situation, we don't need to use this value, right? So the answer must be D. Now let's move on to question 8. A curve is parametrically defined by the equations s equals 2 cosine t and y equals 2 sine t. The length of the arc from t equals 0 to t equals 2 is. Alright, so remember you have the formula. The arc length is going to be the interval from 0 to 2, right? 0 to 2 of square root of s prime t square plus y prime t square dt, right? Now we need to find s prime of t is going to be negative 2 sine t, right? And y prime of t is going to be 2 cosine t, right? The interval from 0 to 2 square root of this one square equals 4 sine square of t. This one square is going to be plus 4 cosine square of t dt, right? So it can be the interval from 0 to 2. Factor 4 out and bring it outside, so it can be 2, right? You have sine square plus cosine square is going to be 1 square root of 1 equals 1, so you have dt right here, right? So you have 2t evaluated from 0 to 2, so it can be 4, right? So the answer must be B. Now let's move on to question 9. A particle moves in the xy plane so that at time t greater than 0, its position vector is this guy. So remember, position vector is going to be r of t equals s of t, comma, y of t, right? Then at time t equals pi over 2, the velocity vector is going to be derivative of this guy right here, s prime of t, comma, y prime of t, right? Now we take the derivative of this one, so we have v of t is going to be r prime of t is going to be 3 cosine 3t minus pi over 2, right? Comma 6t, right? Substitute pi over 2 for t, so you have v of pi over 2 is going to be 3 cosine of 3 pi over 2 minus pi over 2, comma 6 times pi over 2 is going to be 3 pi, right? 3 pi over 2 subtract pi over 2 is going to be 2 pi over 2, and then simplify is going to be pi. Cosine of pi equals negative 1, so the final answer is negative 3 comma 3 pi, right? So the answer must be A. Now question 10. A particle moves on the circle x squared plus y squared equals 1. Show that at time t greater than or equal to 0, its position is given by the vector right here. Find the coordinates of the point at the particle approaches as t increases without bound. So it means t approaches infinity, right? So basically, you need to find the limit of this guy right here, 1 minus t squared over 1 plus t squared when t approaches infinity. Now you're going to use the relative growth rate. This guy right here grows faster than this guy. This guy right here grows faster than this one, so you can ignore 1, right? So it could be limit of negative t squared over t squared when t approaches infinity, right? So it could be t squared divided by t squared, it could be 1, so the answer is negative 1, right? Now second one, limit of 2t over 1 plus t squared when t approaches infinity, right? We're going to use the relative growth rate, right? So we can ignore 1 right here. So it could be limit of 2t divided by t squared when t approaches infinity, right? So divide the top bottom by t, right? So it could be limit of 2 divided by t when t approaches infinity, right? It's going to be 0. So you have the order pair negative 1 comma 0, right? So the answer must be B. Now let's move on to question 11. In American football, a field goal attempt on a flat field is made. when a football is kicked at an angle of 30 degrees to the horizontal with an initial speed of 65 feet per second. To score a field goal, the ball must clear the crossbar of the goal post, which is 10 feet above the ground. What is the farthest from the goal post that the kick can originate and score a field goal? Now remember, you have the formula for the position vector for a projectile. It's going to be R of t is V0 cosine of theta t I plus H plus V0 sine theta of t minus 1 over 2 gt squared. Alright, now remember g could be 32 feet per second square or 9.8 meter per second square depending on the units right here. So the unit right here is feet, we need to use this guy. If the unit right here is meter, we need to use this guy. Alright, so keep that in mind. Now, initial speed, which means you have V0 right here, right? The angle right here, theta, right? And g equals 32. Now, the initial height is 0, right? So, you have R of t equals S of t, comma, Y of t, right? S of t is going to be this guy right here. Alright, so it's going to be V0 is going to be 65, so you have 65 times t, and cosine 30 degree, right? Comma, this one equals 0, V0 is going to be 65 t sine of 30 degree minus 1/2 times g equals 32, so it can be minus 16 t squared, right? Now we're going to simplify this one. It's going to be cosine of 30 is going to be root 3 over 2, right? So you have 65 t times root 3 over 2, comma, sine of 30 is going to be 1/2, right? So it can be 65 t times 1/2 minus 16 t squared, right? The crossbar of the goal post is 10 feet above the ground, which means this guy right here is 10, right? So we have 65 over 2t minus 16t squared equals 10. Now we're going to simplify this one by multiplying both sides by 2. So we have negative 32t squared plus 65t, right? Minus 20 equal to 0, right? So we're going to print up the calculator. Go to the home screen, graph. So input this guy is going to be negative 32s squared plus 65s minus 20. And then press enter. It's going to be right here. Alright, now we need to find the 0 of this guy, right? So we need to press menu number 6, number 1, go to the left, go to the right. We have the first 0 right here. Do exactly the same thing for the second one, right? We have the second 0 right here, right? So the first 0 is 0.378. Second one is going to be 1.65, right? Now, since the question say what is the farthest from the goal, right? So we need to pick this value right here. We substitute this guy back to the S value right here to find the distance, right? So we have 65 times 1.65 times root 3 over 2, right? So we're going to print up the calculator, go to the calculator, and then press 65 times 1.65 times control and the square root 3 divide by 2. So press enter. It's going to give you the value 92.881. Now look at the answer choice right here. The unit should be yards, right? So we know that 1 yard is going to be 3 feet, right? So we're going to take this number divide by 3, right? So we're going to print up the calculator again. Divide this guy by 3. So it could be 30.960, right? The number that closest to this number is going to be answer choice B. Now let's move on to question 12. In a major conference men's basketball game on January 21st, 1980, between Florida State and Virginia Tech, a record was set. Les Hansen, who is 6 feet 6 inches tall. So we need to convert this one to feet. It's going to be 6.5 feet. Made a basket from 89.4 feet down the court to win the game for Virginia Tech by a score of 79 to 77. Assuming he released the ball at a height of 6 feet 6 inches and threw it at an angle of 45 degrees to maximize distance. What was the initial speed of the ball? See the figure. Alright. So, similar to number 11, we have the formula. Now we're going to plug in values. V0 is not given, so we just leave it, right? So we have V0 cosine of the angle right here, 45 degrees, right? Cosine of 45 degrees, right? I put T right here. Comma, the initial height is right here, which means the height of this person, right? 6.5. So we have 6.5 plus V0 sine of 45T. So I put T right here, right? Minus 1/2 G. Now, in this situation, we look at the unit right here. It should be feet, right? So we need to use 32 instead of 9.8, right? 32 divided by 2, it could be 16. So we have 16 T squared, right? Now we're going to simplify. So it could be cosine of 45 is going to be root 2 over 2. So you have root 2 over 2 V0 T, comma, negative 16 T squared plus root 2 over 2 V0 T plus 6.5, right? Now we need to use this information right here. It's going to be 89.25 feet. This guy actually the value of S of T, right? So we substitute over here. So we have root 2 over 2 V0 T equals 89.25, right? So then V0 T equals 89.25. Multiply both sides by 2 over root 2, right? So this guy times 2 over root 2, right? Now divide both sides by V0, so T equals 2 divided by root 2, it could be root 2, so it could be 89.25 times root 2, right? Divided by V0. Now we have this information right here. This guy actually y of t, right? So y of t equal this guy right here, right? So we have negative 16 t squared plus root 2 over 2 v0. Now t right here, I'm going to use this guy right here, right? So I have 89.25 over v0 times root 2, right? Plus 6.5, right? This one equals 10 right here, right? Now v0 and v0 cancel out, right? Root 2 times root 2, it could be 2 divided by 2 cancel out, right? So I have negative 16t squared plus 89.25 plus 6.5 equals 10, right? Now I'm going to subtract 89.25 and 6.5 both sides, so I'm going to end up with negative 16t squared equals negative 85.75, right? So then t squared equals 85.75 divided by 16, right? So t equals square root of 85.75 over 16, right? We're not going to take the negative number, right? So we're going to print up the calculator. Control the square root side right here. 85.75 divided by 16 is going to be 2.315. Now substitute this guy over here to solve for V0, right? So V0 equals 89.25 root 2 divided by 2.315, right? So we're gonna print up the calculator again. Now we have 89.25 times square root of 2. Press enter. Then we need to divide by this guy right here. And then press Ctrl enter. It's gonna be 54.513. So the answer must be D. Now let's move on to question 13. A curve C is defined by the parametric equation, this guy and this guy for t greater than or equal to 0. Find dy over ds in terms of t, right? So we need to find ds over dt first, right? Now we can rewrite this one so that we can use the power rule, right? So we have t plus 1 power of negative 1/2, right? So ds over dt is going to be negative 1/2, right, times t plus 1 power of negative 3/2, right? And then it's going to be negative 1 over 2 times t plus 1 power of 3/2, right? Now dy over dt equals, we're going to use the quotient rule, right? Divided over this one equals 1, so it could be t plus 1 minus divided over this one is going to be 1, right? So it could be minus t over t plus 1 altogether square, right? So it could be 1 over t plus 1 square, right? Now dy over ds, we just divide the top and bottom by dt, so we have dy over dt divided by ds over dt. So it could be dy over dt is going to be right here, so we have 1 over t plus 1 altogether square divided by negative 1 over 2 times t plus 1 power of 3/2, right? We're going to multiply the top and bottom by 2 t plus 1 power of 3/2. Alright, so it's going to be this guy cancel out, right? You have negative 1 right here, so it could be negative 2. Now this guy and this guy cancel out, so it's going to be t plus 1 power of negative 1/2, right? And it's going to be negative 2 over square root of t plus 1, right? Now question B, find an equation of the tangent lines to C at t equals 3, right? So we substitute 3 for t over here to find the slope, right? So the slope is negative 2 over square root of 3 plus 1. It's going to be negative 1, right? And you're going to substitute 3 for t into this guy right here to find the order pair, right? So you have s equals 1 over square root of 3 plus 1. It's going to be 1/2, right? Y equals 3 divided by 3 plus 1. It's going to be 3 over 4, right? So equation y minus y1 equals m times s minus s1. Substitute, so y minus y1 is going to be 3, 4 right here. Equals the slope is going to be negative 1. So minus s minus s1 is going to be 1/2 right here. Alright. Now question C, set up but do not evaluate a definite interval representing the length of the curve C on the interval 0 to 1, right? So remember you have the formula, the length equals the interval from 0 to 1 square root of s prime of t square plus y prime of t square dt, right? Now if you square this one, it's going to be s prime of t square. It's going to be 1 over 4 t plus 1 power of 3, right? So we're going to put it right here. Square root of 1 over 4 times t plus 1 cube plus y prime of t. We got it right here. This one square, so it could be 1 over t plus 1 power of 4 dt, right? Now question D. Find an equation for the curve C in terms of x and y, right? So we go back over here. X right here, y right here, right? We copy this one down. Now for this equation, we need to solve for t, right? So we square both sides, so we have x squared equals 1 over t plus 1, right? So t plus 1 equals 1 over s squared. Then t equals 1 over s squared minus 1. Substitute this guy for t into the function y right here. So you have y equals 1 over s squared minus 1 divided by 1 over s squared minus 1 plus 1, right? Now it's going to be 1 over s squared minus 1 divided by 1 over s squared, right? Now you're going to multiply the top and bottom by s squared. So this guy cancel out, right? This guy cancel out, so it could be 1 minus s squared, right? Then you need to put y right here, and this is the final answer. Now question 14. For t from 0 to 5, a particle is moving along a curve so that its position at time t is this guy. At time t equals 1, the particle is at position 2, -7. It's known that dx over dt is this guy and dy over dt is this guy. Write an equation for the line tangent to the curve at a point 2, -7. Alright, so you need to find the slope first, right? So we have dy over dx, right? Now you need to divide the top bottom by dt. So you have dy over dt divided by dx over dt, right? Dy over dt is going to be right here. So you have e to the cosine t divided by sine of t divided by t plus 3, right? Now t equals 1. Substitute 1 for t, so you have dy over dt evaluated at t equals 1 equals e to the cosine of 1 divided by sine of 1 over 4, right? Now we're gonna bring up the calculator. So make sure your calculator in the gradient mode, right? So you have e to the cosine of 1 divided by sine of 1 over 4. Then press Ctrl Enter. It's going to be 6.938. Now you need to find the order pair. Now the order pair is given right here, so we don't need to find, right? So we have y minus y1 equals m times s minus s1, right? So then y minus -7, so it could be plus 7 equals, the slope is going to be 6.938 times s minus 2. This one is the final answer. Now question B. Find the y coordinate of the position of the particle at time t equals 4. Now we need to use the fundamental theorem of calculus, right? So we see that dy over dt is right here, right? So we have the final position y of 4 equals initial position is going to be right here, right? Y of 1 plus the interval 1 to 4 dy, right? Now y of 1 is -7 right here, right? So you have -7 plus the interval from 1 to 4, right? Now dy, we got it right here. We just multiply both sides by dt, so it could be e to the cosine t dt, right? Substitute this guy over here. So you have e to the cosine t dt, right? Now we need to print up the calculator. So we have -7 plus, hit the button right here, the interval right here, from 1 to 4. E to the cosine t dt. Press Ctrl Enter. It's gonna give you -5.00667, right? Question C. Find the total distance traveled by the particle from t equals 1 to t equals 4, right? So we have distance equals the integral from 1 to 4 of square root of s prime of t square plus y prime of t square dt, right? Now we substitute values. So we have the integral from 1 to 4. S prime of t is right here, and y prime of t is going to be right here, right? So we have. Now we're going to bring up the calculator. I'm going to copy this one over here. I just change the number. This guy should be 3. Right? And then press Ctrl Enter. It's going to be 2.469. Right? Now let's move on to the last one. Find the time at which the speed of the particle is 2.5. Find the acceleration vector of the particle at this time, right? So the speed equals 2.5. You know that the speed is given by the formula square root of s prime of t square plus y prime of t square, right? And then it's going to be square root of sine of t over t plus 3 altogether square plus e to the cosine of t altogether square, right, equals 2.5, right? Now we're going to square both sides, so we have sine square of t over t plus 3 plus e to the cosine t. When you square, it's going to be 2 right here, right? Equals 6.25, right? Now we're going to wrap these two guys on the graphing calculator, and we're going to find the intersection, and that's the answer, right? So we're going to print up the calculator. Go to graph right here, press tab, go to y1, clear this one. It's going to be sine of t over t plus 3, right? So it could be, then press enter, it's going to be right here. Now we're going to press tab, y2 is 6.25, press enter, it's going to be right here. Alright, now we need to find the intersection. Remember, we need to restrict the domain. The domain is t from 0 to 5 right here. Alright, so we're gonna press menu, window, zoom, window setting right here. As min is 0, as max is 5, right? And then press enter, it could be right here. Now we couldn't see the intersection on the right hand side, so we need to go to menu, window, zoom, window setting right here. We just put as mask like 7. Alright, press enter. It's gonna be right here. Now remember the domain is from 0 to 5, right? Now we need to find the intersection, so we need to press menu, analyze graph, intersection. Go to the left, go to the right, it's gonna be 0.415. And the second one right here, menu, analyze graph, intersection, it's going to be right here. Now remember the domain is from 0 to 5, right? This one is 5.8, is outside the domain, so we only have one solution, 0.415. That's it, right? Now the acceleration is the second derivative of the position, right? So which means we need to take the derivative of this guy right here, right? So we have a of t equals s double prime of t comma y double prime of t, right? So basically we need to take the derivative of this guy right here, right? I think we're allowed to use the calculator, so I just store this function as u of t and this one as v of t, right? And then I'm going to check the derivative of this one, right? So I'm going to print up the calculator, right? So I have u of t is going to be right here. And then press Ctrl the button right here. And then we just input the function, right? So we have sine of, put a fraction, t over t plus 3, and then press enter. Now v of t, press Control the button right here. It's gonna be e to the cosine of t, right? And then press enter. Now we need to take derivative of these two guys and evaluate the value of the function at t equals 0.415, right? So we're gonna press this button right here. Then we're gonna hit this guy right here. Alright, so this one should be t. Alright, this is u of t. Then you go to the right, you need to press Control equal sign, put a line right here. You put t equals 0.415 and then press enter. It's gonna give you the value 0.2553, right? Now we do exactly for the bottom one, right? So the v of t, right? We're gonna review AP Calculus BC topic 9.7 through 9.9 polar curves. Alright, so you need to know the formula S equals R cosine theta, Y equals R sine theta. And then if you square both sides, it's gonna be S squared equals R squared cosine square theta. And this one Y squared equals R squared sine square theta. Now if you add them up, you're gonna end up with S squared plus Y squared equals R squared. So keep this one in mind, right? Now if you need to find the slope of the tangent line dy over ds, you need to divide the top and bottom by d theta, and then you need to calculate the derivative of y and s with respect to theta, right? So this formula you need to remember. Now, in order to find the area enclosed by a polar curve, we're going to use this formula. A equals 1/2 integral from a to b r squared d theta. Alright, now look at this example right here. A equals 0, b equals 2 pi, right? The radius is right here. And we just plug this one into the formula, we get the answer, right? Now, the area between two polar curves, we're going to use this formula. The area equals 1/2 times the integral from a to b of the outer radius square minus the inner radius square d theta. Alright, now let's take a look at the first question. Which of the following is equal to the area of the region inside the polar curve r equals 2 cosine theta and outside the polar curve r equals cosine theta? Now, you're not allowed to use the calculator for this question, so basically you need to know how to sketch this one by hand. Alright, so how do I know it? Now I'm going to start with this guy first, right? So I'm going to multiply both sides by r, so I have r squared equals 2r cosine theta, right? Remember you have s squared plus y squared equals r squared, right? You have s equals r cosine theta, right? You have y equals r sine theta, right? So keep this one in mind. So r squared is going to be s squared plus y squared equals 2. R cosine theta is going to be s, right? Now I'm going to subtract 2s both sides, so it could be s squared minus 2s plus y squared equals 0, right? Now I need to do complete square, right? So I'm going to take 2 right here, the middle term right here, divide by 2 and square is going to be 1. So I'm going to add 1 both sides, right? So the first 3 terms right here is going to be complete square formula, right? So s minus 1 r together square plus y square equals 1. Now remember the circle equation is going to be s minus h r together square plus y minus k r together square equals r square, right? The center is going to be h and k. The radius equals square root of the number on the right hand side, which means r squared right here, right? So this guy has the center is going to be 1, 0, right? And the radius is square root of 1, which means 1, right? Similarly, I have r equals cosine theta, right? multiply both sides by r, so it could be r squared equals r cosine theta, right? So it could be x squared plus y squared equals x, right? So it could be x squared minus x plus y squared equals 0, right? Now check the middle term right here. It's going to be 1 divided by 2 and square. So basically you just add 1 for both sides, right? So this guy becomes x minus 1/2 altogether square plus y square equals 1/4, right? So you have the center is going to be 1/2, comma 0. And the radius is going to be square root of 1/4 is going to be 1/2, right? Now we're going to sketch this one, so it could be something like this. The radius for the smaller circle is going to be 1/2 right here, right? The radius for the bigger circle is going to be 1 right here, right? Now we're going to use the formula, the error equals 1/2 the integral from a to b of the outer radius, I'm going to call this the bigger radius square, subtract the inner radius, which means the smaller radius square, d theta, right? Now the outer radius is going to be this one right here, right? The inner one is going to be this one right here, right? Now remember that both circles right here trace from negative pi over 2 to pi over 2, right? So it's going to be 1/2 integral from negative pi over 2 to pi over 2 of this guy square is going to be 4 cosine square theta, right? Subtract this guy square is going to be minus cosine square theta d theta, right? So it's going to be 1/2 integral from negative pi over 2 to pi over 2 of 3 cosine square theta d theta, right? You have two portions right here. I call this A1, A2, right? They symmetric about the polar axis, right? So you just calculate the upper one and you multiply by 2, right? So the upper one is going to be from 0 to pi over 2, right? So I have the error is going to be 2 times 1/2 integral from 0 to pi over 2, right? 3 cosine square theta d theta. And I'm going to simplify this guy cancel out. So I'm going to end up with this guy right here, right? So the answer must be A. Now let's move on to question number 2. This is not a calculator active problem. This question comes from AP Calculus BC question 19 in 1998. Alright, the error of the regions inside the polar curve is this guy, and outside the polar curve is this guy. Alright, r squared equals 4r sine theta, right? Now this one is turned out to be x squared plus y squared equals 4y, right? So then it's going to be x squared plus y squared subtract 4y equal to 0, right? Now I need to do complete square. So basically I look at the middle term here, 4 divided by 2, it's going to be 2 squared, it's going to be 4, so I'm going to add 4 both sides, right? So this guy becomes x squared plus y minus 2 altogether square equals 4, right? So the center is going to be 0, 2, and the radius is going to be 2, right? Now similarly, this one is the circle with the radius 2, and the center is going to be origin, right? So if you sketch this figure, it's going to be something like this, right? And observe that this region is symmetric about the y-axis, right? So you just calculate the error of one region and you multiply by 2, right? Now first, I need to find the intersection between this guy and this guy, right? So I just equate this guy and this guy, right? So I have 4 sine theta equals 2. So sine theta equals 1/2, right? And theta equals pi over 6 and 5 pi over 6, right? Now you have the formula, error is going to be 1/2. The integral from pi over 6 to 5 pi over 6, right? The outer radius, right? The outer radius is this guy right here, right? So you have 4 sine theta altogether square, subtract the inner radius. The inner radius is right here, 2 square d theta, right? It's going to be 1/2 integral from pi over 6 to 5 pi over 6, 16 sine square theta subtract 4 d theta, right? So the answer must be D. Now let's move on to question 3. Calculator is not allowed for this question. This question comes from AP Calculus BC question 26 in 2008. Which of the following expression gives the total error enclosed by the polar curve or equal sine square theta shown in the figure above? Alright, so it's going to be this region. Now observe that these two regions right here is symmetric about the polar axis. So basically you just calculate the error of one section and you multiply by 2, right? Now you need to find the lower limit and upper limit, right? So you see that at the origin the radius equals 0, right? So you're gonna let radius equals 0 is the same thing as sine square theta equals 0, right? And then it's gonna be sine theta equals 0, right? Theta equals 0 and pi, right? So the lower limit is 0, the upper limit is pi. So you have the error is gonna be 1/2 integral from 0 to pi, right? The radius square, so it can be sine square theta altogether square d theta, right? Now you need to multiply this guy by 2 to get both sections right here, right? So you have 2 times this guy to get the top and the bottom. Now we're going to simplify. It's going to be integral from 0 to pi sine to the 4 theta d theta, right? Because this guy cancel out, right? So the answer must be D. Now let's move on to question 4. Calculator is not allowed for this question. Alright, what is the error of the regions enclosed by the limit scale? R squared equals 18 cosine 2 theta, shown in the figure below. Alright, so again, at the origin, the radius equals 0, right? So we need to let the radius equal to 0 to find the lower limit and upper limit, right? So this square equals 0 is the same thing as 18 cosine 2 theta equal to 0, right? So cosine 2 theta equals 0 divided by 18, it could be 0, right? And then it could be cosine 2 theta equals cosine of pi over 2, right? So 2 theta equals plus and minus pi over 2, right? Remember, this is what you learned from AP pre-calculus, so make sure you review this concept, right? So divide both sides by 2, you have theta equals plus and minus pi over 4, right? So this one is negative pi over 4 right here. And this one is positive pi over 4, right? So the error is going to be these regions, right? So the error is going to be 1/2 the integral from negative pi over 4 to pi over 4 r squared. So it can be 18 cosine 2 theta d theta, right? This one already is square, right? Now you need to multiply this guy by 2 to get the one on the left hand side, right? So I need to put 2 right here, right? Now we need to review the whole concept. If the function f(s) is even, then you have the integral from negative a to a of f of s ds equals 2 times the integral from 0 to a of f of s ds, right? If the function f(s) is odd, you have the integral from negative a to a of f of s ds equal to 0. So keep that in mind. Now the cosine function is even, right? So this guy cancel out. So this guy becomes the integral from 0 to pi over 4, and you need to put 2 right here, right? Of 18 cosine 2 theta d theta. So it could be 36 integral from 0 to pi over 4 cosine 2 theta d theta, right? And it's going to be 36 over 2 sine 2 theta evaluated from 0 to pi over 4, right? Now remember, if you have sine of as plus b, and then when you take antiderivative of this one, it turns out to be negative 1 over a cosine of as plus b plus c. Similarly, you have antiderivative of cosine of as plus b ds. It turns out to be 1 over a sine of as plus b plus c. If you have antiderivative of e to the as plus b ds, it turns out to be 1 over a e to the as plus b plus c. So keep that in mind. Alright, so this guy turns out to be 36 divided by 2, it could be 18, right? Times sine of 2 times pi over 4, it could be pi over 2, right? Substitute 0 for theta, the bottom one should be 0, right? So the answer should be 18, right? Because sine pi over 2 equals 1, right? So the answer must be C. Now let's move on to question 5. Calculator is not allowed for this question. This question comes from AB Calculus BC question 23 in 1988. Which of the following gives the area of the regions enclosed by the loop of the graph of the polar curve r equal 4 cosine 3 theta shown in the figure above? Alright, so basically you need to find the lower limit and upper limit, right? So observe that at the origin the radius equals 0, right? So we're gonna let r equal to 0 is the same thing as for cosine of 3 theta equals 0, right? Divide both sides by 4, so cosine 3 theta equals 0, right? So cosine 3 theta equals cosine of pi over 2, right? So 3 theta equals plus and minus pi over 2, right? So theta equals plus and minus pi over 6, right? So the upper limit is pi over 6. The lower limit is going to be negative pi over 6, right? So the error is going to be 1/2 in the form negative pi over 6 to pi over 6, right? Of the radius square, so it could be 4 cosine 3 theta all together square d theta, right? Now we're going to simplify, so it could be 1/2 in the form negative pi over 6 to pi over 6. 4 square equals 16, right? So I put 16 outside, right? So it could be cosine 3 theta all together square d theta, right? 16 divided by 2, it could be 8. So it could be 8 in the form negative pi over 6 to pi over 6 cosine of 3 theta all together square d theta, right? So the answer must be E, right? Now let's move on to question 6. Calculator is not allowed for this question. This question comes from AP Calculus BC question 24 in 1985. The area of regions enclosed by the polar curves for 0 to pi over 2 is, this is very simple, right? So you have A equals 1/2 in the form 0 to pi over 2, the radius square, right? So it could be sine square of 2 theta d theta, right? So we're going to use this formula. Sine square of theta is going to be 1 minus cosine 2 theta divided by 2, right? Remember, you have cosine square of theta is going to be 1 plus cosine 2 theta divided by 2, right? Now, since the angle is 2 theta, so if I put 2 right here, and this guy must be double, right? So it should be 4, right? This guy stay. Keep in mind, you don't double this guy, right? So this guy becomes 1/2 in the form 0 to pi over 2 of 1 minus cosine 4 theta divided by 2 d theta, right? Now 1/2 inside right here, I'm going to bring this one outside, so I have A equals 1 over 4, right? Now I'm going to take antiderivative of this one, it's going to be theta, right? Antiderivative of this one is going to be 1 over 4 sine 4 theta, and I have the negative side right here, so it could be negative 1 over 4 sine 4 theta, right? Evaluated from 0 to pi over 2, right? So it could be 1 over 4 pi over 2 minus 1 over 4 sine of 4 times pi over 2, it's going to be 2 pi, right? And if I substitute 0 for theta, it's going to be 0, so I don't need to worry about the low limits, right? So this guy becomes pi over 8. This guy becomes 0 because sine 2 pi equals 0, right? So the answer must be D. Now let's move on to question number 6. Calculator is not allowed. Determine the slope of the line tangent to the polar curve. R equals 1 plus 2 sine theta s, theta equals pi over 2. Alright, so remember you have s equals r cosine theta, right? So, but r equals 1 plus 2 sine theta, so it can be s equals 1 plus 2 sine theta times cosine theta, right? Now y equals r sine theta. So y equals 1 plus 2 sine theta times sine theta, right? Now the slope of the tangent line is going to be dy over ds, right? So I'm going to divide the top bottom by d theta. So you have dy over d theta divided by ds over d theta, right? So I'm going to take the derivative of this guy right here with respect to theta, right? So I'm going to use the product rule, right? So it's going to be 2 cosine theta times sine theta plus 1 plus 2 sine theta cosine theta, right? Over derivative of this guy is going to be 2 cosine theta times cosine theta. Derivative of cosine is going to be negative side, so it's going to be negative 1 plus 2 sine theta times sine theta, right? Now I'm going to substitute pi over 2 for theta, right? So dy over dx at theta equals pi over 2 equals cosine of pi over 2 equals 0, so this guy gone, right? Cosine of pi over 2 equals 0, so this guy's gone. So the top equals 0, the bottom. Cosine of pi over 2 equals 0, right? Sine of pi over 2 equals 1. This guy equals 1, right? So it could be negative 3, so the answer is 0, right? So the answer must be A. Now let's move on to question 8. Calculator is not allowed for this question. This question comes from AP Calculus BC question 5 in 1993. Which of the following represent the graph of the polar curve r equals 2 secant theta, right? So remember you have s equals r cosine theta, right? So then s equals r equals this one, right? So it can be 2 secant theta times cosine theta, right? But secant theta is going to be 1 over cosine, so it can be s equals 2 times 1 over cosine theta times cosine theta. This guy cancel out, so s equals 2. This guy actually the vertical line at s equals 2. So the answer must be D. Now let's move on to question 9. Calculator is allowed. This question comes from AP Calculus BC question 3 in 2003. Alright, the figure above shows the graphs of the lines s equals 5 over 3y. So we mean this one s equals 5 over 3y. And the curve C is given by s equals square root of 1 plus y squared, right? So this one s equals square root of 1 plus y squared. Let S be the shaded regions bounded by the two graphs and the x-axis. The line and the curve intersect at point P. Find the coordinates of point P and the value of the s over dy for the curve C at point B. So basically, we need to find the intersection between this guy and this guy, right? So we see that they both equal s, right? We just equate the right-hand side, right? So we have, and then we're going to square both sides. So it can be 1 plus y squared equals 25 over 9 y squared, right? 25 over 9 squared subtract y squared is going to be 16 over 9 y squared equals 1, right? Then y squared equals 9 over 16, right? Take square root both sides, so y equals plus and minus 3 over 4, right? Now since point P in the first quadrant, so the y value should be positive, right? So we only take y equals 3 over 4 is the final answer, right? Now we need to find ds over dy. We need to take the derivative of this one with respect to y, right? So remember, if you have the square root of u prime, it's going to be u prime over 2 square root of u, right? So this guy turns out to be ds over dy equals 1 plus y squared prime over 2 square root of 1 plus y squared, right? Now we're going to simplify. It's going to be 2y over 2 square root of 1 plus y squared, right? So it could be y over square root of 1 plus y squared, right? But square root of 1 plus y squared equals s right here, right? So you have ds over dy equals y divided by s, right? But y equals 3 over 4, so it could be 3 over 4 over. Substitute 3 over 4 over here to solve for s. So s equals 5 over 4, right? So substitute 5 over 4 over here. So you have 5 over 4. Multiply the top bottom by 4, so the answer must be 3 over 5, right? Now let's move on to question C. The curve C is a part of the curve s squared minus y squared equals 1. Show that s squared minus y squared equals 1 can be written as the polar equation r squared equals 1 over cosine squared minus sine squared theta, right? So we're going to start from here. we know that s equals r cosine theta, right? So we have r square cosine square theta minus y square. Y equals r sine theta, right? So it could be r square sine square theta, right? Equals 1. And then I'm gonna factor r square out. So you have r square times cosine square theta minus sine square theta equals 1, right? Divide both sides by this guy, so r square equals 1 divided by cosine square theta minus sine square theta, and this one has been proved. Now question D. Use the polar equation from part C to set up an integral expression with respect to polar angle theta that represents the error asked. So we know that the error equals 1/2 integral from A to B of radius square d theta, right? So we need to find the lower limit and upper limit first, right? So we're gonna go back over here, the region S right here. The lower limit is right here, right? It's gonna be 0. The upper limit is right here, right? We don't know it. We need to find it. And we know that the angle right here is gonna be theta, right? So we have the coordinate point P right here. We just draw the vertical line, right? So this one is the right triangle. Now we're gonna use trigonometric ratio in the right triangle, right? So we have tangent theta is gonna be opposite over adjacent, right? So I call this is PA, right? So it could be PA over OA, right? PA which means the Y value, OA which means the S value, right? And Y over S, we got it right here, 3 over 5. So this one is 3 over 5. Now we need to find the measure of angle theta. We're gonna take inverse tangent both sides. So we have theta equals inverse tangent of 3 over 5, right? So this one is the upper limit for this guy right here, right? So I'm gonna go back over here and substitute into this guy, right? So I have 1/2 integral from 0 to inverse tangent of 3 over 5. The radius square is gonna be 1 over cosine square theta minus sine square theta d theta, right? Remember, it's right here, right? Now let's move on to question 10. Calculator is not allowed for this question. This question comes from AP Calculus BC question 2 in 2005. The curve above is drawn in the xy plane and is described by the equation in polar coordinates r equals theta plus sine 2 theta for theta from 0 to pi, where r is measured in meters and theta is measured in radians. The derivative of r with respect to theta is given by dr over d theta equals 1 plus 2 cosine 2 theta, right? Question A. Find the error bounded by the curve and the x-axis, right? So we need to find the error of this region. Now it's very simple. You just plug in the formulas, right? You have the formula A equals 1/2 integral from A to B, the radius square d theta, right? So you have A equals 1/2 integral from 0 to pi, right? Of this one square theta plus sine 2 theta altogether square d theta, right? Now you're allowed to use the calculator, so you print up the calculator. Go to the home screen, press calculate, right? Press this button right here, put the integral right here, right? It's gonna be 0 to pi of x plus sine 2x altogether square dx. And don't forget to put 1/2 in the front, right? So it can be 0.5. And then press Ctrl Enter. It's gonna be 4.382. Now question B. Find the angle theta that corresponds to the point on the curve with x coordinate -2. Now remember, you have the formula s equals r cosine theta, right? But x equals -2, so you have negative 2 equals or equal this one right here, right? So you have theta plus sine 2 theta times cosine theta. Now you're gonna bring up the calculator. Add graphs right here. F1, which means negative 2, right? Press enter. Now F2, you're gonna press tab right here. So you're gonna put parentheses s plus sine 2s times cosine s. Now remember, you need to restrict the domain, right? Domain is going to be from 0 to pi, right? Which means 0 to 3.14, right? So you're going to restrict the domain. Press menu number for Windows setting right here. It's going to be from 0 to 3.14, so I'm going to put 3.2, right? And then press OK. It's going to be right here. Alright, so you have one intersection. So you're going to press menu number, set number for go to the left, go to the right. The answer is right here, 2.79, right? Now, question C. For theta goes from pi over 3 to 2 pi over 3, dr over d theta is negative. What does this fact say about the radius? What does this fact say about the curve? Alright, so we have dr over d theta less than 0, right? So this one is the first derivative of the function of the radius, right? Less than 0, right? So it tells us that the function r of theta is decreasing on this interval. So we just answer this question. Now, when the radius is decreasing, it's getting closer to the origin, right? Now we go back to the graph right here. We can observe it. The radius is right here, bigger than this guy, right? So when the radius is decreasing, the distance from this guy less than this guy, and this guy right here getting closer to the origin, right? Now question D. Find the value of angle theta in the interval theta from 0 to pi over 2 that corresponds to the point on the curve in the first quadrant with radius distant from the origin. Alright, so when it's come to radius or least or minimum or maximum, increasing or decreasing, think about the first derivative, right? So radius, which means maximum, right? And you given the closed interval right here, think about the candidate test, right? So first we need to find the derivative of the radius, right? dr over d theta is gonna be, we're gonna go back over here, the function r equals theta plus sine 2 theta, right? So it's gonna be d of theta plus sine 2 theta over d theta, right? Now we're gonna check the derivative of this one with respect to theta, right? So it could be 1 plus 2 cosine 2 theta, right? So this guy actually the first derivative, right? So we need to let this one equal to 0, right? So r prime equal to 0 is the same thing as 1 plus 2 cosine 2 theta equal to 0. Remember, we have the domain from 0 to pi over 2, right? So it's going to be cosine 2 theta equals negative 1/2, right? And cosine 2 theta is going to be cosine of 2 pi over 3, right? So 2 theta equals plus and minus 2 pi over 3, right? And then theta equals plus and minus pi over 3, right? Because theta between 0 to pi over 2, right? So we only pick theta equals pi over 3. That's it, right? Now we're going to use the candidate test. So we're going to sketch the table. Theta equals 0, it's going to be this value, right? Theta equals pi over 2, it's going to be the ending value right here, and theta equal pi over 3. This one is the critical number, right? Now substitute these three guys into the equation. R equals theta plus sine 2 theta, right? So theta equals 0 is going to be 0, right? Theta equals pi over 3 is going to be pi over 3 plus sine 2 pi over 3, right? So I'm going to bring up the calculator. You're going to go to calculator, right? So you're going to press home screen right here, go to calculate. Now it's going to be pi over 3. So you're going to press the fraction right here. Put pi over 3 plus sine of 2 pi over 3. And then press Ctrl Enter. It's going to give you the decimal number 1.913. Now, theta equals pi over 2. We do exactly the same thing, right? So we're going to have pi over 2. And then you press Ctrl Enter. It's going to give you 1.5708. Now, since we need the greatest distance, which means the maximum, so the answer must be this guy right here, right? So we need to say the greatest distance occurs when theta equals pi over 3. Now let's move on to the last question, question 11. This question comes from AP Calculus BC question 3 in 2007. Calculator is allowed. The graph of the polar curves r equals 2 and r equals 3 plus 2 cosine theta are shown in the figure above. The curves intersect when theta equals 2 pi over 3 and theta equals 4 pi over 3, right? So this guy right here, 2 pi over 3. This guy, 4 pi over 3, right? Let R be the regions that is inside the graph of R equals 2, and also inside the graph of R equals 3 plus 2 cosine theta, right? So this one is R right here. As shaded in the figure above, find the error of R. Observe that the region R includes two sections that symmetric about the polar axis. Now the one on the top traces from 0 to 2 pi over 3, right? This region right here enclosed by the inner circle, which means this one right here, right? And from 2 pi over 3 to pi right here, this region right here enclosed by the function right here, right? So we have A is 1/2 the interval from 0 to 2 pi over 3, right? Of the radius square. So this guy right here enclosed by radius equals 2, right? Look at this one right here. So it could be 2 square d theta, right? Plus this guy right here, right? The yellow one right here enclosed by the guys right here, right? So it could be integral from 2 pi over 3 to pi of 3 plus 2 cosine theta all together square d theta, right? And then remember 1/2 multiplied by the whole thing right here, right? And then you need to multiply by 2 to get the bottom part right here, right? So 2 right here, right? This guy right here cancel out, right? So the integral from 0 to 2 pi over 3 of 2 square dx plus the integral from 2 pi over 3 to pi of 3 plus 2 cosine theta, and then press Ctrl Enter. It's gonna be 10.3705, right? Now question B. A particle moving with non-zero velocity along the polar curve r equals 3 plus 2 cosine theta has position s of t, y of t at time t, with theta equals 0 when t equals 0. This particle moves along the curve so that dr over dt equals dr over d theta. Find the value of dr over dt as theta equals pi over 3 and interpret your answer in terms of motion of the particle. Alright, so we have dr over dt at theta equals pi over 3, right? Right here, the question wants us to find this one, right? But this guy right here equal this guy, right? So we have dr over d theta at theta equals pi over 3, right? Now, dr right here, so we need to take derivative of this one. So it's going to be negative 2 sine theta evaluated as pi over 3, right? So it could be negative 2 sine of pi over 3, right? We're going to print up the calculator. So we have negative 2 times sine of pi over 3. And then you press Control Enter. It's going to be negative 1.732, right? So that is one less than 0, right? It tells us that the function r of theta is decreasing. So what does it mean? It means the particle is moving closer to the origin, right? Now let's move on to question C. For the particle described in part B, dy over dt equals dy over d theta. Find the value of dy over dt at theta equals pi over 3 and interpret the answer in terms of the motion of the particle. So remember, we have y equals r sine theta, right? But r equals this guy right here, right? So we have 3 plus 2 cosine theta times sine theta, right? Now we have dy over dt at theta equals pi over 3, right? This is what we need to find right here. It's going to be dy over d theta at theta equals pi over 3, right? Now we need to take the derivative of this one with respect to theta, right? So we're going to use the product rule, right? Negative 2 sine theta times sine theta is going to be sine square theta, right? Plus derivative of this guy is going to be cosine, right? So it's going to be cosine theta times 3 plus 2 cosine theta, right? And we substitute pi over 3 over here. So we have negative 2 sine of pi over 3 all together square, right? Plus cosine of pi over 3 times 3 plus 2 cosine of pi over 3, right? Now we're going to print up the calculator. So I'm going to store the function y, right? So I'm going to name this one as y of x. Hit Control the button right here, right? So I have 3 plus 2 cosine x times sine x, right? And I press Enter. So I'm gonna press the button right here, derivatives right here, right? With respect to x, and this one I just copy this one over here, and then I'm gonna press Control equals, put the line right here. I put x equals pi over 3, right? So I'm gonna put the fraction right here. Put pi over 3, and I press Control Enter. It's gonna give you 0.5, right? Now, since this derivative is greater than 0, right? It tells us that y of theta is increasing. Then the particle is moving away from the x-axis. We're going to review Unit 10, Topics 10.1 to 10.10, Sequences and Infinite Series. Alright, first I'm going to show you the strategies for testing series. Now we have total 10 tests, right? But each of which will be tested on the AP Calculus BC exam. Now suppose you given the infinite series a sub n, right? So what you need to do is to find the limit of a sub n when n approaches infinity, right? You have two possible cases. Now you're going to check to see if this limit equals 0 or not, right? If the limit of this series not equal to 0, right? So you have this case right here. Then the series divergent by the n-term test or divergent test right here, right? Now, if the limit of a sub n when n approaches infinity equals 0, so it's going to be yes, you're going to check to see if the series is geometric. Now, if the series is geometric, then you're going to check the absolute value of common ratio to see if it's less than 1, right? If it's yes, and then the series converges, right? If it's no, and then the series diverges, right? If this series is not geometric, then you're going to check to see if there are positive terms. If no, and then you're going to check to see if the sign alternates. If yes, and then you're going to check to see if the series decreasing. If the series is decreasing, then the series converges. If the series not decreasing, and then you're going to try absolute convergence. Now after you check the sign and you don't see the sign alternating, and then you're going to try absolute convergence. If there are positive terms, we're going to think about the P series first, right? Now you're going to check to see if this series is a P series. If it is, and then check to see if P greater than 1. If yes, and then the series converges, right? If no, and then the series diverges, right? Now, what if the series right here is not a P series? Think about the integral test. Now, if this one is, the series converges. If you cannot use the integral test, think about the ratio test. If you succeed, and then the series converges. If you cannot use the ratio test, think about the root test. If you succeed, and then the series converges. If not, think about the direct comparison test. If you succeed, and then the series converges. If not, think about the limit comparison test. If you succeed, and then the series converges. Now here's the series test for convergence or divergence that we will use in the tree diagram. Alright, first we have the definition of the infinite series. Now the first test is called the n-term test or divergent test. The second one is going to be geometric series. The next one is going to be P series and harmonic series. The next one is going to be integral test. Next is going to be ratio test, the root test, direct and limit comparison test, the alternating series test, and the last one, absolute and conditional convergence. Now, for problem 1 to 5, be sure to justify your conclusion by thoroughly demonstrating the test you use, right? Now, question 1 and 2, we talk about the sequence and series, right? To remember the difference between sequence and series. Sequence is a list of numbers, and series is a sum of numbers. For example, I have the sequence a sub n equals 1 over n, right? If n equals 1, I'm going to get 1. N equals 2, I get 1 half. N equals 3, I get 1 over 3, right? I just list the number, right? Now, for the series right here, I need to put the summation in front of this one. So it's going to be a sub n like this, right? And it's go from 1 to infinity. N equals 1, we get 1. N equals 2, we get 1 half. N equals 3, we get 1 third, right? So we need to add them up. Now we're going to go back over here. Does the sequence a sub n converge or diverge, right? So we're going to find the limit of 3n over 2n minus 1 when n approaches infinity, right? Now we're going to use the relative growth rate, right? So we can ignore this guy, right? Because when n approaches infinity, this guy right here grows faster than 1, right? So this guy turns out to be 3 over 2, because you cancel out n and n, it's going to be 3.5, right? So we can say that this sequence converges, right? Now, number 2, does the series a sub n converge or diverge, right? Now we'll find the limit of 3n over 2n minus 1 when n approaches infinity, right? Again, it's going to be 3.5, right? And this guy actually different from 0, right? So, by the n-term test right here, the series diverges, right? Question 3. Use the n-term test on the series and say its conclusion, right? So we're going to use limit 6n over 4n squared plus 1 when n approaches infinity, right? Again, we're going to use the relative growth rate, right? So we get it now, this guy, right? So it could be limit of 6 over 4n, right? Because you can cancel out n. Now, when n approaches infinity, the bottom approaches infinity, the top approaches 6. So it could be 0, right? So, using the n-term test, it's going to be inconclusive, right? If the limit of a sub n equals 0, the n-term test is inconclusive. Now, number 4, can you find the sum of the series? If so, find that sum. Alright, so this one can be written as n goes from 1 to infinity of 2 over 5 altogether raised to the n, right? And you have 1 over 5 right here, right? And this guy actually the geometric series, right? With the common ratio equals 2 over 5, right? Less than 1, right? So by geometric series test, the series converges to a over 1 minus r, right? Look at the geometric series right here, right? Now a is the first term which means n equals 1. Substitute 1 for n over here. We have 2 over 25, right? Over 1 minus 2 over 5. So if we simplify this one, it turns out to be 2 over 15, right? Now let's move on to question 5. This guy actually telescoping series, alright? So first we need to expand this one. If n equals 1, we get 1 minus 1 over 3, right? N equals 2, we get 1 and half minus 1 over 4, right? N equals 3, we get 1 over 3 minus 1 over 5. N equals 4, we get 1 over 4 minus 1 over 6, right? Now, we're going to generalize this one. So what if n equals k minus 3, right? So we have 1 over k minus 3 minus 1 over k minus 1. Now n equals k minus 2. We get 1 over k minus 2 minus 1 over k, right? Now n equals k minus 1. We get 1 over k minus 1 minus 1 over k plus 1, right? And the last one, n equals k. Then we get 1 over k minus 1 over k plus 2. Remember, the telescoping series has the term cancel, right? So look, this guy and this guy cancel out. This guy and this guy cancel out. Now this guy and the terms somewhere right here cancel out, right? This guy and the term somewhere right here cancel out, right? This guy and this guy cancel out. This guy and this guy cancel out, right? This guy and the term somewhere right here cancel out, right? So we only have the 4 terms left, the first, the second, and the last 2 right here, right? So it's gonna be, now I'm gonna take limit of this one, so I'm gonna factor -1 out, right? So it can be like this, right? When k approaches infinity, right? So this guy approaches 0, this guy approaches 0, we only have this one left, it's gonna be 3.5, right? Now let's move on to question 6. Match the series with its behavior by circling the appropriate word. Alright, question A. The series 1 over n to the e. This guy actually the p series, right? So the series converges, right? Because p equals e greater than 1, right? Now question B. This guy actually the p series, right? And p equals ln 2, which is less than 1. The series diverges, right? Now let's move on to question 7. Find the common ratio if it exists in the series, right? So this is actually the geometric series, right? In order to find the common ratio, you just take the next term divided by the previous terms, right? So the next term right here, -9 over 2, divided by 3, right? So it could be -9 over 6, which is -3 over 2. Now, we have another way. R equals this guy right here, 27 over 4 divided by -9 over 2, right? And we multiply the top bottom by 4, right? So it's going to be 27 over -18, right? Now divide the top bottom by 9, so it could be -3 over 2, right? The common ratio is -3 over 2. Now question 8. How many terms of the series are needed to approximate the sum of the series with an error that is less than 0.001? Alright, so this is the alternating series, right? So we're going to use the alternating series error bar, right? So we have error equals absolute value of the sum of the infinite series, subtract the partial sum, right? And this guy is the error bar, right? And this guy must be less than or equal to the next omitted terms, right? It could be a sub n plus 1. Now a sub n is right here, right? So a sub n plus 1 actually 1 over n plus 1 altogether raised to the 4, right? And we need this one to be less than 0.0001, right? So this one less than 1 over 1000, right? Now I'm gonna take reciprocal both sides, so it turns out to be n plus 1 power 4 greater than 1000, right? We're gonna take 4 root both sides, right? So it could be n plus 1 equals 4 root of 1000, right? We're gonna hit the button right here. This guy right here, 4 root of 1000. Press Ctrl Enter. It's gonna be 5.623, right? So n equals 5.623 subtract 1 is gonna be 4.623, right? Now n greater than 4.623 and n must be an integer, right? So the least number should be 5 right here. Question 9. If the series a sub n equals 1 over n raised to the 1.01 converges, which of the following series also converges by the direct comparison test? Question A. This guy actually the harmonic series where p equals 1, right? So this one diverges by the p series, right? Now this one can be written as 1 over n power 1/2, right? So 1/2 less than 1. This one diverges, right? Now this one right here, it will take absolute value of this one. And it turns out to be the series of 1 over n power 1.01, right? And this guy actually right here, right? But this one converges, so this one is the right answer, right? Now we're going to check question D right here. P equals 0.09 less than 1, right? So by the p series, this one diverges, right? And this one p equals 0.01 less than 1, right? By the p-series test, this one diverges. Now, question 10. Find the sum of the series 1 minus 1 over 3 plus 1 over 3 minus 1 over 5, etc. Right? So if we keep doing this one, it turns out to be 1 over 7 minus 1 over 9, right? Plus, etc. Now, we need the two general terms right here. So how do we find the general terms, right? So we look at this one right here, 3, 5, 7, right? So we have 3, 5, 7 right here, and we have 1 right here, right? So right here, n equals 0, n equals 1, n equals 2, n equals 3, right? In order to get 3 from 1, we're going to add 2, add 2, add 2, right? And this guy actually arithmetic sequence, right? So we have a sub n equals a sub k plus n minus k times d. This is the formula to find the general term, right? So we have a sub n equals a sub k. For example, I'm going to pick this guy. 1 plus n minus 0 times 2, right? So I'm going to simplify a sub n equals 2n plus 1, right? So I have 1 over 2n plus 1 right here. And the terms before that should be 1 over 2n minus 1, right? Subtract. So this guy cancel out, this guy cancel out, this guy cancel out, right? This guy and the terms right here cancel out. This term and the term before it cancel out, right? So we only have this guy and this guy left, right? So it's gonna be 1 minus limit of 1 over 2n plus 1 when n approaches infinity, right? The bottom approaches infinity, right? So it could be 1 minus 0, it could be 1. So the answer is D, right? Now let's move on to question 11. Which of the following series is absolutely convergent, right? So we're going to take absolute value of each of this one, right? So we have absolute value of this one. It turns out to be the series 1 over n raised to the 0.99 when n goes from 1 to infinity, right? This guy actually the p series where p equals 0.99 less than 1, right? So the series diverges, right? Now question B. Check absolute value of this one is going to be the series 1 over n squared, right? Now this guy again is a p series, right? Where p equals 2 greater than 1. So this one converges by the p series, right? Now question C. We're going to take absolute value of this one. So it turns out to be the series 1 over n. This guy diverges because it's going to be harmonic series, right? Question D. Check absolute value of this one. It's going to be the series of 3 raised to the n, right? And this one actually the geometric series, right? With the common ratio equals 3 greater than 1. So the series diverges by the geometric series, right? And the last one. Absolute value of this one is going to be the series 1 over ln of n, right? Now we know that n always greater than ln of n, right? Now I'm going to take reciprocal, so it could be 1 over n always less than 1 over ln of n, right? Now this one right here diverges by harmonic series test, right? So by direct comparison test, this series right here diverges, right? So the answer must be B. Now question 12. Which of the following series is conditionally convergent? Alright. We're going to take absolute value of this one. So it's going to be the series 1 over n squared. This one is absolutely convergent by P series test, right? Now question B. Check absolute value of this one. It's going to be 1 over square root of n is going to be n power 1 half, right? And this guy is divergent by the p series test, right? Because p equals 1 half less than 1. Now question C. Absolute value of this one is going to be the series 1 over n cubed, right? And this guy absolutely convergent by p series because p equals 3 greater than 1, right? Check absolute value of this one is going to be the series 1 over n factorial, right? This guy is absolutely convergent by the ratio test because you have limit of a sub n plus 1, which means 1 over n plus 1 factorial, over a sub n, which is 1 over n factorial, when n approaches infinity, equals limit of absolute value of 1 over n plus 1 factorial times n factorial over 1 when n approaches infinity, right? N plus 1 factorial is to be n plus 1 times n factorial, right? This guy cancel out. So it could be limit of absolute value of 1 over n plus 1 when n approaches infinity, and this guy equals 0, right? Less than 1, right? So it could be absolutely convergent by the ratio test right here, right? Now the last one, if you take absolute value of this one, it's going to be the series e to the n, right? And when n approaches infinity, this guy divergent by the n-term test, right? The question wants you to find the series that is conditionally convergent, right? So the first one is absolutely convergent. We're going to cross this one out, right? The second one could be, right? The third one, absolutely convergent. We cross this one out. Question D, absolutely convergent by the ratio test. We're going to cross this one out, right? Now, question E could be, right? Now, for question B right here, we're going to use the alternating series test. The series right here converges if limit of this one right here equal to 0. And this one right here is a decreasing sequence, right? So we're going to check to see if it's right or wrong, right? So we have limit of b sub n is going to be this guy right here. 1 over square root n when n approaches infinity, right? So it could be 0, that's correct, right? And you know that b sub n equals 1 over square root n is a decreasing sequence, right? Because when n getting bigger and bigger, this sequence getting smaller and smaller, right? So two conditions are met, then this series converges. The answer must be B. Now question 13, very simple. This one is the geometric series where the common ratio equals 2 over 5, which is less than 1, right? So the series converges to a over 1 minus r, right? Substitute a equals 1, right? Put 1 right here, a over 1 minus 2 over 5, right? So we're going to multiply the top bottom by 5. So it could be 5 over 5 minus 2. It could be 5 over 3, right? The answer must be D. Now question 14. If this series diverges, which of the following series also diverges? The answer obviously C. Why? Because we can rewrite this one as 0.5 times the series 1 over n, right? So the constant right here does not affect the convergence, right? So if the original one right here diverges, the new one right here must be divergent, right? Now let's move on to question 15. Consider the series -1 raised to the n plus 1 over n to the p. Determine the values of p for which the series converges. Alright, so we look at this one right here. Alright, it's going to give you a hint. We need to use the alternating series test, right? So I'm going to let a sub n equals 1 over n to the p, right? Now, in order to use the alternating series test, you need to check to see if a sub n greater than 0. Yes, it's greater than 0, right? Now, next, you're going to check to see if a sub n equals 1 over n to the p is decreasing. This guy is decreasing if p greater than 0, right? If p positive. Now, third one, you need to check to see if limit of a sub n, which means 1 over n to the p when n approaches infinity, this guy equals 0 if and only if b greater than 0, right? So, to summarize this one, the series converges if p greater than 0, right? By the alternating series test, right? Now question B, find the maximum value of the error if k terms are used to approximate the sum of the series, right? So we're going to use the alternating series error bound, right? So it's going to be the error equals absolute value of s sub infinitive subtract the partial sum. This guy actually the remainder, and it should be less than the first omitted term, right? Which is absolute value of a sub n plus 1, right? Now, the first omitted terms is k plus 1 terms, right? So it's going to be 1 over, instead of n, I'm going to put k plus 1, right? Raised to the p. And this one is the maximum error. Now, question 16 to 18, we are allowed to use the calculator. Now, question 16, we need to find the sum of this sequence, right? So we're going to bring up the calculator. Press the button right here, and then you're going to hit this guy. And then press Control Enter. The answer is 0.783, right? Now question B. What is the maximum value of the error of this series if the sum of this one is approximated by the answer in part A? If we use the part A to do part B, we see that n equals 10, right? And then the first omitted term should be n equals 11, right? So we're going to use the alternating series error bound, right? So it's going to be absolute value of s sub infinitive subtract s sub 10. This guy must be less than or equal to absolute value of the first omitted term, which is a sub 11, right? But a sub 11, substitute 11 for n over here. So we have absolute value of negative 1 raised to the 12 over 11 raised to the 11, right? And it's going to be 1 over 11 raised to the 11, right? If we want to convert this one to decimal, we just use the calculator, right? Press Control Enter. It's going to be 4 times 10 to the negative 12, right? Now question C. If the sum of the first 20 terms was used instead in part A, would the error in part B be increased or decreased? Right, so we do exactly the same thing, right? Error equals absolute value of s sub infinitive subtract the partial sum. This guy less than absolute value of a sub 21, right? So it's going to be absolute value of negative 1 raised to the 21 plus 1 over 21 raised to the 21, right? So it's going to be 1 over 21 raised to the 21, right? And this guy absolutely less than 1 over 11 raised to the 11, right? So we can conclude that the error would be decreased, right? Now let's move on to question 17. Find the sum of the series negative 1 to the n over n squared, correct to 3 decimal places. State the number of terms needed to arrive at the answer. Alright, so when we see this guy right here, actually negative 1 raised to the n, think about the alternating series test, right? So we're going to use the alternating series error bound, right? So we have error equals absolute value of s sub infinitive subtract the partial sum. This guy must be less than the first omitted term, which means a sub n plus 1, right? And this guy must be less than 0.001, right? 3 decimal places. So we have a sub n right here equals 1 over n squared, right? Then a sub n plus 1 equals 1 over n plus 1 altogether squared, right? So we have 1 over n plus 1 altogether squared less than 0.001. This guy actually 1 over 1000, right? So we have 1 over 1000 here. Now we're going to take reciprocal both sides, so to be n plus 1 altogether squared greater than 1000, right? Then check square root both sides, so to be n plus 1 greater than square root of 1000, right? Then n greater than square root 1000 subtract 1, right? So we're gonna bring up the calculator, press the button right here, take the square root right here. 1000 subtract 1, press Control, Enter. It's gonna be 30.622, right? But n is an integer, right? So the least number should be n equals 31. So the series becomes -1 raised to the n over n squared when n goes from 1 to 31, right? So you're gonna print up the calculator, press the button right here, pick the summation notation right here, right? N goes from 1 to 31. Hit the fraction, -1 raised to the n over n squared, and then press Control, Enter. It's going to give you -0.822, right? Now, question B, we're going to do exactly the same thing, right? So we have error equals absolute value of s of infinity subtract s of n less than the absolute value of the first omitted term, right? Which is a of n plus 1. And this guy actually less than 0.001, right? So the first omitted term should be 1 over n plus 1 factorial, right? This guy right here is a sub n, right? And this guy less than 1 over 1000. So check reciprocal both sides could be n plus 1 factorial greater than 1000, right? Now we're going to test n equals 1. We have 2 factorial is less than 1000, right? N equals 2. We have 3 factorial, which is 6, right? N equals 3. We have 4 factorial, which is 24, right? It doesn't work, right? N equals 4. We have 4 plus 1 could be 5. It could be 120. It doesn't work. N equals 5. We have 6. It could be 720. N equals 6. It's going to be 50, 40. So this one greater than 1000, right? So this one works, right? So n equals 6. Now we have the sum from 1 to 6, -1 raised to the n over n factorial, right? So we're going to print up the calculator. I'm going to copy this one down over here. The button right here. And then press Control, Enter. It's going to be -0.631. Now, question 18. Find the error when the alternating series is approximated by the first 4 terms of the series, right? So, again, we're going to use the alternating series error bound, right? So we have error equals absolute value of s of infinity subtract the partial sum, right? And this guy actually less than absolute value of a sub 4, right? The first 4 terms. And it's going to be -0.25 raised to the 4, right? So it's going to be, we're going to bring up the calculator. -0.25 raised to the 4. Press Control, Enter. It's going to be 0.0039, right? Now question B. Find the exact sum of the series and use it to find the actual error between the exact sum and the approximate sum using the first 4 terms of the series. Compare the answer to the question A, right? So we have the sum equals the series -0.25 raised to the n, and go from 0 to infinity, right? Now this guy actually geometric series where the common ratio equals -0.25, right? So absolute value of common ratio right here less than 1. So then geometric series converges, right? And it's going to be a over 1 minus r, right? A equals 1 right here. 1 over 1 minus -0.25, right? And then it's going to be 1 over 1 plus 1 over 4, right? Multiply the top bottom by 4. So we have 4 over 4 plus 1 it's going to be 4 over 5, right? Error is absolute value of the series subtracted partial sum, right? Which is the sum of the series subtract s sub 3, right? The first 4 terms we need to use s3, right? So it's going to be 4 over 5 subtract s3, which means the sum negative 0.25 raised to the n when n's go from 0 to 3, right? So it's going to be absolute value of 4 over 5 minus, we're going to print up the calculator. It's going to be 0.7968, right? 0.003125, right? Now we're going to compare this number right here with this guy right here. And we see that 0.003125 less than 0.0039, right? We're going to review Unit 10, topics 10.11 to 10.15, Taylor and Maclaurin series. Alright, question 1. The coefficient of the third degree term in the Taylor series for fs equals lns, center about s equals 1. Alright, so remember we have the Taylor series, center at c. c in this situation is 1, right? Now, the question wants you to find the coefficient of the third degree. Alright, so the third degree is going to be right here, because you have this guy right here, right? Now, coefficient, which means you only need this guy. Alright, so we're going to take the third derivative of this function, right? So we have f prime of s is going to be 1 over s is going to be s power of negative 1, right? Now f double prime of s is going to be negative s power of negative 2, right? And f triple prime of s is going to be 2 s power of negative 3, right? Now we're going to substitute the center right here, right? So it can be f triple prime of 1 equals 2, right? So the coefficient is 2 divided by 3 factorial, which means 2 over 6, which is 1 over 3. So the answer must be D, right? Now let's move on to question 2. What are all values of s for which the series converges? Alright, so we're going to use the ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity, right? Now this guy right here is a sub n, right? So a sub n plus 1 equals s minus 1 raised to the n plus 1 over n plus 1, right? So I have limit when n approaches infinity, absolute value of s minus 1 raised to the n plus 1 over n plus 1 times reciprocal of this one is going to be n over s minus 1 raised to the n, right? Now we're going to simplify this one, so it can be limit when n approaches infinity, right? The top and this guy cancel out, we have s minus 1 on the top, right? We need to rewrite this guy and this guy, right? So it can be over n plus 1 times n, right? Now I can bring absolute value of s minus 1 outside. Then I'm going to take limit of n over n plus 1. So we're going to use the relative growth rate, right? We can cross out 1, right? So n over n is going to be 1, right? So final answer is absolute value of s minus 1, right? Now in order for this series to be convergent, this guy must be less than 1 by the ratio test, right? So this guy is the same thing as s minus 1 less than 1 greater than negative 1, right? Now we're going to add 1 3 sides, so it can be 0 less than s less than 2, right? Now we need to check the endpoints, right? S equals 0, substitute 0 for s back to the original one right here. So we have the series negative 1 raised to the n over n, right? And this guy actually alternating harmonic series, right? And it's going to be convergence, right? Now s equals 2. We have the series 1 over n. Then this one diverges by harmonic series, right? Finally, your answer should be 0 less than or equal to s less than 2, right? Now let's move on to question 3. If e to the s equals this guy, then this guy must be what? Alright, so remember you have the Taylor series for e to the s equals, if n equals 0, you have 1, right? N equals 1, you have s. N equals 2, we have s squared over 2 factorial. N equals 3, we have s cubed over 3 factorial, plus etc. Right? Now e to the negative s squared. So we just replace s with negative s squared, right? So it can be 1 plus negative s squared plus negative s squared altogether squared over 2 factorial plus negative s squared altogether cubed over 3 factorial plus etc. Right? Equals 1 minus s squared plus s to the 4 over 2 factorial, right? Minus s to the 6 over 3 factorial plus etc. Right? So this guy turns out to be, you just replace s right here with negative s squared, right? So you have summation n's go from 0 to infinity, negative s squared altogether raised to the n over n factorial, right? And this guy turns out to be the sum n's go from 0 to infinity, negative 1 raised to the n, s raised to the 2n over n factorial, right? I can rewrite e to the negative s squared equal this one, right? Now look at this one right here. The question asks you the summation of this one when n start from 1. This one start from 0, right? Look at this guy right here. It's going to be the same thing already, right? So if I start this one from 1, does that mean I have e to the negative s squared equals, so I need to change this one to 1, right? So it can be summation n equals 1 to infinity of negative 1 raised to the n, s raised to the 2n over n factorial, right? And if n equals 0, I substitute 0 for n. That gives me the answer 1, right? So I'm going to add 1, right? So I'm going to subtract 1 both sides. So I have e to the negative s squared equals summation n start from 1 to infinity, negative 1 raised to the n, s raised to the 2n over n factorial, right? So the answer must be D. Now let's move on to question 4. The power series e to the s equal this one. Let f be the function given by fs equal e to the negative s squared over 3. Find p4 of s, the 4th-degree Maclaurin polynomial for fs, right? So Maclaurin, which means the center equals 0, right? And p4 of s, the 4th-degree, right? So the highest degree should be 4, right? So we're going to look at this one. E to the s equal this one. We need to find e to the negative s squared over 3. So we replace s with negative s squared over 3. So we have p sub 4 of s equals 1 plus negative s squared over 3, right? Plus negative s squared over 3 altogether squared over 2, right? We're going to stop right here, because if you take s squared and then you square, it's going to be s to the 4, right? So we simplify this one. It's going to be 1 minus s squared over 3 plus s to the 4 over 3 squared equals 9. 9 times 2 equals 18, right? Now question B. Write FOS as a power series using summation notation. Alright, so we have e to the s equals, we just rewrite this one as a power series, right? So it can be the sum n start from 0 to infinity, right? Look at this one. This is s squared over 2 factorial, s cubed over 3 factorial, right? So it can be s to the n over n factorial, right? And then e to the negative s squared over 3. It's going to be summation notation n start from 0 to infinity of negative s squared over 3 raised to the n over n factorial, right? You just replace s with negative s squared over 3, right? So we're going to simplify this one. So it can be summation notation n start from 0 to infinity, right? Now 3 raised to the n, and bring this guy to the bottom, right? And then I have negative s squared raised to the n. It's going to be s raised to the 2n, right? And I have negative 1 raised to the n. I put negative 1 right here, raised to the n, right? And this guy actually alternating series, right? Now, question C. Use the polynomial p sub 4 of s in part A to approximate f of 0.3 to 5 decimal places, right? So we have f of 0.3 approximately p sub 4 of 0.3, right? So it could be this guy right here equals 1 minus 0.3 square over 3, right? Plus 0.3 to the 4 over 18, right? Now I'm going to bring up the calculator and then press Control Enter. Now it's going to be 0.97045, right? Now let's move on to question D. Find the interval of convergence of the power series for FS about s equals 0. Show the analysis that leads to your conclusion. Alright, so we're going to use the ratio test, right? So we have limit absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit a sub n plus 1, right? So we have negative 1 raised to the n plus 1 s raised to the 2 parentheses n plus 1, right? Over 3 raised to the n plus 1 times n plus 1 factorial. Multiplied by this one reciprocal, so it's going to be 3 raised to the n times n factorial over negative 1 raised to the n s raised to the 2n, right? Now we're going to simplify this one. Negative 1 raised to the n plus 1 can be written as negative 1 raised to the n times negative 1, right? This guy cancel out, right? So you have negative 1 left. When you take absolute value, it's going to be positive, right? So I don't need to worry about this one much, right? Now s raised to the 2 times n plus 1 becomes s raised to the 2n plus 2. Alright, so it could be s raised to the 2n times s squared, right? So this guy cancel out. We have s squared left, right? Now 3 raised to the n and 3 raised to the n plus 1, we have 3 on the bottom, right? N factorial and n plus 1 factorial, we have n plus 1 on the bottom, right? And we have the limit right here, n approaches infinity, take absolute value of this one, right? So when n approaches infinity, this guy approaches infinity on the bottom, right? So it could be 0 less than 1, right? So by the ratio test, this series convergent, right? For all real numbers, right? Let's move on to question E. For what value of n will absolute value of f of s subtract b sub n of s less than 0.0001, right? Now look at the question B right here. And this guy is the alternating series, right? So we need to use the alternating series error bound, right? So we have absolute value of f of s minus p sub n of s, right? Always equals the remainder, right? And this guy always less than or equal to the first omitted term, which is a sub n plus 1, right? Now you have a sub n right here, right? So a sub n plus 1, you just put 1 right here and 2n plus 1 right here, right? So we have, now we're going to check n equals 1. We have absolute value of f of s minus p sub 1 of s, right? This guy less than or equal to, substitute 1 for n over here, right? So have 1 plus 1 is going to be 2, negative 1 square is going to be 1, right? And absolute value of s raised to the 2 times 2 is going to be 4 over 3 square is going to be 9, right? Times 2 factorial is going to be 2, right? So it can be absolute value of 0.3 to the 4, right? Over 18, right? So I'm going to bring up the calculator. The answer is 0.00045, right? Now we need the answer to be less than this guy, right? But this is not right, so this is not correct answer, right? Now n equals 2. We have absolute value of f of s minus p sub 2 of s less than or equal to. So I have negative 1 raised to the third. It's going to be negative 1. When you take absolute value, it's going to be positive, right? Now substitute 2 for n right here. So it could be 2 plus 1, it could be 3. 3 times 2 could be 6. So s power of 6 over 3 power of 3, right? Times 2 plus 1, it could be 3. 3 factorial, it could be 6, right? So it's going to be absolute value of 0.3 power 6 over 3 cube times 6. And I'm going to print up the calculator and press Ctrl Enter. It's going to give you 0.00000045, right? And this guy actually less than 0.0001, right? So the least positive integer is n equals 2, right? Now let's move on to question 5. For s between -1 and 1, if f of s equals this one, then we need to find derivative of this one, right? So basically, we just use the power rule, right? So we have summation notation and go from 1 to infinity, -1 raised to the n plus 1 rewrite, right? Now, over 3 and minus 2, you just rewrite, right? Now, you just print this one to the front, right? So, it's going to be 3 and minus 2 times s raised to the 3 and minus 2 minus 1 is going to be minus 3, right? Now this guy and this guy cancel out, so the answer must be B, right? Now let's move on to question 6. We need to find the power series for sine of 2s, right? Alright, so this one is sine of s equal this one, right? Now sine of 2s, you just replace s with 2s, so it can be 2s minus 2s cubed over 3 factorial, right? Plus 2s to the 5th over 5 factorial minus 2s to the 7 over 7 factorial plus etc. plus -1 raised to the n minus 1 times 2s power of 2n minus 1 over 2n minus 1 factorial, right? So the answer must be B. Now let's move on to question 7. Consider the power series f of s equal this one. For what values of s does the series converge? Alright, so we're going to use the ratio test, right? So we have limit when n approaches infinity of absolute value of a sub n plus 1 over a sub n, right? This one must be less than 1, right? So we have limit when n approaches infinity absolute value of a sub n plus 1 is going to be -1 raised to the n plus 1 times 2 raised to the n plus 1 times s minus 3 raised to the n plus 1 over n plus 1 is going to be n plus 2, right? Times this one reciprocal is going to be n plus 1 over -1 raised to the n times 2 raised to the n times s minus 3 raised to the n, right? Now we're going to simplify. -1 raised to the n plus 1 can be written as -1 raised to the n times -1, right? So this guy cancel out. We have -1 left. When you take absolute value, it's going to be positive, right? Now 2 raised to the n plus 1 and 2 raised to the n cancel out. So we have limit when n approaches infinity absolute value of, you have 2 left on the top, right? Now this one n plus 1, so it could be times n plus 1. The bottom is n plus 2, rewrite n plus 2, right? S minus 3 raised to the n plus 1, and this one cancel out. You have s minus 3 left on the top, right? Alright, so I have absolute value of s minus 3 right here. I need to print it to the front, right? Because it's not related to this guy, right? Now, when n approaches infinity, this guy right here approaches 2, right? So we have 2 times s minus 3. This guy must be less than 1 in order for the series to be convergent, right? So it's going to be absolute value of s minus 3 less than 1/2, right? Or -1/2 less than s minus 3 less than 1/2, right? We're going to add 3 sign, right? So it's going to be, now we need to check for the endpoints, right? If s equals 5 over 2, we substitute 5 over 2 for s back to this one right here, right? So we have the series n start from 0 to infinity, -1 raised to the n, 2 raised to the n, 5 over 2 subtract 3 is going to be -1/2 raised to the n over n plus 1, right? So to simplify this one, it's going to be the series n start from 0 to infinity. Negative 1 raised to the n and negative 1 raised to the n is going to be negative 1 raised to the 2n, right? Now I have 2 raised to the n, I bring it to the bottom, right here. And I have 2 raised to the n on the top right here, right? And the bottom I have n plus 1, right? Because this one can be written as negative 1 raised to the n over 2 raised to the n, right? So this one cancel out, right? Negative 1 raised to the 2n is going to be positive 1, right? So the series becomes n start from 0 to infinity of 1 over n plus 1, right? Now, I'm going to start from 0, I get this series, right? If I start from 1, what happens? So I just rewrite this one as the series ends go from 1 to infinity. Does that mean this guy becomes 1 over n, right? And this guy actually harmonic series, and it's going to be divergent, right? If s equals 7 over 2, right? And then the series becomes n start from 0 to infinity, negative 1 raised to the n times 2 raised to the n times 7 over 2 subtract 3 is going to be 1/2, right? Raised to the n over n plus 1, right? So this series becomes n start from 0 to infinity, negative 1 raised to the n times 2 raised to the n. Now this guy becomes 1 raised to the n over 2 raised to the n, right? So I have 2 raised to the n right here times n plus 1, right? So this guy cancel out. So I have the series n start from 0 to infinity, negative 1 raised to the n over n plus 1, right? So I can rewrite this one as the series n start from 1 to infinity. This one start from 0, right? Now this one start from 1, right? So this guy becomes negative 1 raised to the n plus 1, and this guy becomes n, right? And this one converges by alternating harmonic series, right? So the final answer should be this guy right here, but you need to include the endpoint right here, right? So it could be 5 over 2 less than s less than or equal to 7 over 2, right? Now let's move on to question B. Let G be the function satisfying G of 3 equals 5 and G prime of s equals Ls for all s, right? Write the first 4 terms and the general term of the Taylor series for G about s equals 3, right? So the function f of s is given by this one right here. We just copy this one down, right? Now G prime of s equals f of s, right? So we have g prime of s equals f of s, right? Now we need to find the function g, so we need to take antiderivative both sides, right? So we have g of s equals antiderivative of f of s ds, right? So we're going to take antiderivative of this one, right? Now look at this guy right here, they are constant, so I just rewrite this one, right? Now this one right here, I just use the power rule, right? So it's going to be s minus 3 raised to the n plus 1, right? Over n plus 1, right? So I'm going to combine n plus 1 and n plus 1 right here. It's going to be n plus 1 squared, right? Don't forget to add the constant c. Now we need to solve for c, right? So in order to solve for c, we need to use the condition right here. G of 3 equals 5, right? So we have substitute 3 for s, right? So we have g of 3 equals 5, right? And this guy actually, and when you substitute 3 for s over here, this guy right here becomes 0. Right? Because 3 subtract 3 equals 0, right? So it could be C. So C equals 5. So I'm going to go back over here. I'm going to replace C right here with 5, right? So this one is the answer for the function g of s, right? Now the question wants you to write the first 4 terms, right? So we have g of s equals n start from 0, substitute 0 for s over here, right? So we have negative 1 raised to the 0 is going to be 1, right? This one 1, right? This one right here you have s minus 3, right? N equals 1, you have negative 2 over 4, right? Times s minus 3 squared, right? N equals 2, you have 4 over 9 times s minus 3 cubed, right? N equals 3, we have negative 8 over 16 times s minus 3 raised to the 4 plus etc. right? And finally, don't forget to add the constant right here. Alright, so this one is the answer for the first 4 terms, right? Now question C. What is the interval of convergence of the power series for the function g found in part B? Alright, it's gonna be right here, right? So we're gonna use the ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity. This guy must be less than 1, right? So we have limit when n approaches infinity, absolute value of a sub n plus 1 is going to be negative 1 raised to the n plus 1 times 2 raised to the n plus 1 times s minus 3 raised to the n plus 1 is going to be n plus 2, right? Over n plus 1 square, it could be n plus 2 square, right? Multiplied by this one reciprocal, it's going to be n plus 1 square over negative 1 raised to the n times 2 raised to the n times s minus 3 raised to the n plus 1, right? Now we're going to simplify this one, so it could be limit when n approaches infinity, absolute value of this guy and this guy cancel out, you have negative 1 left, right? So when you take absolute value, it's going to be positive, right? Now 2n plus 1 and 2 raised to the n is going to be 2 on the top, right? Now n plus 1 square, right? The bottom is n plus 2 square, right? And you have this guy and this guy cancel out, so you have s minus 3 left on the top, right? S minus 3 is not related to this one, I bring it to the front, right? So I'm going to take limit when n approaches infinity, absolute value of 2. Now, when n approaches infinity, 1 and 2 right here doesn't really matter, right? So it's going to be n square over n square, right? So when n approaches infinity, this guy cancel out, you have 2 left, right? So it could be 2 times s minus 3 right here. We need this one to be less than 1, right? So this guy is the same thing as absolute value of s minus 3 less than 1/2, right? So it's going to be negative 1/2 less than s minus 3 less than 1/2, right? Or add 3 both sides, so it could be 5 over 2 less than s less than 7 over 2, right? Now we're going to check for the endpoints, right? First, s equals 5 over 2. The series becomes, now we're going to simplify this one. 5 over 2 subtract 3. It's going to be negative 1 over 2, right? So negative 1 raised to the n plus 1 over 2 raised to the n plus 1, right? So this guy turns out to be the series n start from 0 to infinity, negative 1 raised to the n times negative 1 raised to the n plus 1, right? Times 2 raised to the n over 2 raised to the n plus 1 times n plus 1 square, right? Now negative 1 raised to the n and negative 1 raised to the n right here is going to be negative 1 raised to the 2n, so it could be 1, right? So you have negative 1 raised to the first left, right? So it could be negative 1, right? So you have the series negative 1 over 2 raised to the n and 2 raised to the n plus 1 cancel out, right? So we have 2 on the bottom, right? Times n plus 1 square, right? N start from 0 to infinity, right? So I just rewrite this one as the series. I'm going to start from 1 to infinity. It's going to be negative 1 over 2 times n square only. Alright, so I'm going to apply the p series, right? So p in this iteration equals 2 greater than 1, right? So by the p series test, the series conversion, right? Now, if s equals 7 over 2, I'm going to have the series n start from 0 to infinity, negative 1 raised to the n, 2 raised to the n, and 7 over 2 subtract 3. It's going to be 1 over 2 raised to the n plus 1, right? Over n plus 1 square. And it's going to be the series n go from 0 to infinity, negative 1 raised to the n times 1 raised to the n plus 1 times 2 raised to the n over 2 raised to the n plus 1 times n plus 1 square, right? And then it's going to be the series n start from 0 to infinity, negative 1 raised to the n left, right? 2 raised to the n, this one cancel out, you have 2 on bottom, n plus 1 square, right? Now I can rewrite this one as the series. I'm gonna start from 1 to infinity, right? So this guy right here becomes negative 1 raised to the n plus 1 over 2 times n squared, right? So by the alternating harmonic series, this series right here, convergent, right? So we're gonna include s equals 7 over 2 and s equals 5 over 2, right? So your final answer must be 5 over 2 less than equal to s less than equal to 7 over 2. Now let's move on to question 8. Consider the function f of s equal 4 over 3s plus 2. Find a power series for f of s center h s equal 3. Now if you remember the topic 10.15, you have similar problem, right? F of s equal 4 over s plus 2. But this problem has a power series center h 0, right? Which is Maclaurin series, right? This one, the center h s equal 3, right? So in order to do this one, you do exactly the same thing as example number 1 in topic 10.15 right here, right? You need to rewrite the power series in the form of the sum of an infinite geometric series, right? A over 1 minus R, right? So I have f of s equals 4 over 3s plus 2, right? Now s equals 3, I need to convert this one into factor form. So I just subtract 3 both sides, right? So I have s minus 3 equal to 0, right? This one is the factor, right? So I need this one to be right here, right? So I have 4 over 3, right? Instead of s, I put s minus 3, right? Because center s 3. And then I'm gonna rewrite to, now I need to check to see if everything is unchanged, right? So when I distribute this one, I have 3s. Distribute this one, I get negative 9, right? So I just literally subtract 9, right? I need to add 9 right here, so everything remains unchanged, right? So keep that in mind. Now I'm gonna simplify this one, so it can be 4 over 3 times s minus 3 plus 11, right? Remember, you need to rewrite this one in the form of the sum of an infinite geometric series, which is a over 1 minus r, right? Now 1 is in the front, right? So I need to flip this one. It's gonna be 4 over 11 plus 3 times s minus 3, right? Now I need the subtraction side right here, right? This one addition side. So I just replace addition side with 2 negative side, right? So it could be like this. Alright, now I need this guy to be 1, right? So I need to divide the top bottom by 11, right? So this guy turns out to be 4 over 11 divided by 1 minus negative 3 over 11 times s minus 3, right? So after I have this one, remember the series can be written as a sub k times r raised to the k, right? R is right here, and this one right here is the common ratio, right? So f of s can be written as the summation notation and go from 0 to infinity of 4 over 11, right? Times common ratio negative 3 over 11 times s minus 3 altogether raised to the n, right? Now let's move on to question B. Find the interval of convergence for your power series found in part A. Remember, the geometric series convergent if the absolute value of common ratio less than 1, right? So this one right here is the common ratio, right? So we need absolute value of negative 3 over 11 times s minus 3 less than 1, right? So this guy is the same thing as 3 over 11 absolute value of s minus 3 less than 1, right? Multiply both sides by 11 over 3. So I have absolute value of s minus 3 less than 11 over 3, right? So it's going to be s minus 3 less than 11 over 3 and greater than negative 11 over 3. Now I'm going to add 3 sides, right? So it's going to be negative 2 over 3 less than s less than 20 over 3, right? So the interval of convergence is right here, and it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.